the volcano Chai-10 erupted, producing a lot of ash that then fell out around the town of Chai-10, and a lot of rain. This is a very rainy climate here in southern Chile. There's abundant rainforest here, Valdivian forest with a lot of nothofagus trees. And so we get a lot of rain down here, and following that eruption there was very abundant rain events that caused what we call lahars. So very massive ash, muddy, very fast moving sediment transport down the sides of the volcano and through the town of Chai-10, basically bisecting it. Luckily the town was evacuated, but it completely transformed that landscape and actually extended the delta of a river system just going through Chai-10 out into the marine basin. And a lot of that ash made its way out into the deep marine basin, and that's where we're looking today. This is the most distal or farthest away from that source of the volcano of Chai-10, and the river's just nearby. And so we're hoping to see evidence on the seafloor out here in the deep ocean, and these submarine fans that just extend right beyond the submarine canyon called the Simpson Canyon here on the outer continental shelf and slope. So we're going to about 3,500 meters water depth. Right now, as you can probably see on your screen in the lower left corner, we are at about 2,000 meters water depth, and we've been seeing a lot of interesting critters on our dive into the water. And today is a very special day because we have Dr. Adrienne Copeland from NOAA joining us today. And her specialty is in acoustics and all the critters that you see in the water column. So we're going to let her kind of narrate a little bit and tell us about what we've seen thus far. There's been a lot of comments on what we've seen so far in this first 2,000 meters of our dive. And so are you ready, Adrienne?
Yeah.
Take it away.
Yeah, thank you, Becky. So right now we're not seeing as much. You might actually see in the background there, I think, what is a siphonophore, but most of what we're seeing right now is what we call marine snow. And it's just a conglomeration of a bunch of different things that will fall to the seafloor and actually feed some of the animals that we'll see in the seafloor once we get there. So the marine snow is made up of detritus or dead animals and other things that are going to come down to the seafloor and feed things like filter feeders like sponges, which hopefully we'll see once we land about 3,400 meters below the surface. So far, though, on this dive, we've gotten to see quite a bit of interesting things, which has been fun. We saw what we like to call the flying spaghetti monster. So that was that white siphonophore that we saw midway through the dive so far. Siphonophores are colonial organisms, and each part of the zooids will actually be specialized in feeding or locomotion, so they're a very interesting organism. We also saw quite a few jellyfish and jellies as we've descended down to the seafloor. We saw what looked like a helmet jelly. That was that kind of orangish purple organism. And we've also seen some other siphonophores. There's a couple different species of siphonophores that we've seen. Siphonophores are interesting because some of them will actually show up on acoustics. So my specialty is using the fisheries acoustics, or the EK80, to explore the water column. And we can use that because it will emit sound into the water column, and we can look at the reflections of that sound back to the transducer or this equipment on the hull of the ship. And based on those reflections, we can determine what animals we see, because everything that has a sound speed or density difference in the water column will reflect sound back. But a lot of these gelatinous organisms, or jelly-like organisms, won't actually reflect sound because they are filled with a fluid that's similar to the water around them. But some of the siphonophores actually will reflect sound because they're filled with air. Specifically the Volcanic siphonophore, which we actually have seen a couple of them. They're the clear ones that have swimming bells at the top, and actually maybe we'll get lucky and zoom in on. No, I think this is unfortunately a mucus strand. I was really hopeful it would be a fisonect, but it was not, sadly. But there might be actually one in the background there.
So, Adrian, you're saying that little mass that just floated past us is a mucus strand?
Yeah.
Okay.
Yeah. So,
But what do you think the mucus came from?
Here we go, though. Here is a siphonophore. Perfect timing.
Very cool.
And you can see at the top there, the top right, those are the swimming bells that are pulsing as this organism moves through the water column. Right on cue. Thank you, pilots.
Yeah, so today we have Zach and Claude flying the ROV, or I should say diving the ROV. We're doing a little deep dive here, all the way to 3,500 meters water depth. That is the goal. Right in the Simpson Canyon, offshore the continental margin of southern Chile. So we've been transecting all the way out across the Simpson Canyon, out on the continental slope. And we are trying to dive right down to the bottom here to see what we can see in the water column, but then also hopefully bring up some mud that will tell us more about both the recent eruptions and then eruptions that happened before 2008 that may be recorded in the sediment. We also have Carlos, our marine tech, who's operating the YouTube and multitasking with about a billion other things. And who else do we have in the room? We've got two biologists from the Universidad de Valparaiso, Gianluca and Diego. They're both working on their projects, one being a PhD project. We're having to balance a lot with theses and gathering data at sea. And Diego's working on his senior thesis project. So they're both students of Eulogio Soto at the Universidad de Valparaiso. So we've got a very international group here, and we hope here in a little bit, if you guys stay tuned in, you'll get to hear when we get close to the seafloor, my colleague Matilda Ferrante from the OGS in Italy. We'll talk a little bit more about what we're seeing on the seabed, and she can give us some background on what she's been seeing as we survey this area and looking at the acoustics of the seafloor. So seeing both the shape of the seabed, the bathymetry of the seabed, as well as the layering of the sediment below that. So she hasn't been in the ROV mission control very often. She's always taking care of all the mapping efforts that are going on in the background. And really the mapping is the first thing we have to do in order to target these sites, decide what are the geological features that we really want to target, where we think we will have sediment accumulation that may contain this layering that will hopefully include eruptive events, the marine expression of volcanic eruption events. Oh, and we just have as well another PhD student from, she just finished her senior thesis, which is more like a master's thesis at the Universidad de Chile in Santiago with Dr. Rodrigo Fernandez, who's also a PI with myself and Dr. Seb Watt on this project. And so she just finished her senior thesis on Antarctic marine diatoms and marine geology and marine geophysics. She did a lot of analysis of the maps from offshore Antarctica from a very particular basin that we were interested in. And now she's starting her PhD at University of Alabama.
Roll Tide.
Good job, Mane. Yeah, so we have got a very diverse group here. So thank you everybody for joining in. I can see a lot of people joined as we just were starting the dive and weren't really talking yet. But there's a lot of cool critters we've seen along the way. And this is really unique for this particular expedition because we've been in the shallows until now. I think Adrian's been the happiest today of all the days of the cruise, because this is really what she enjoys studying. This is what she does for NOAA. This is her day job, is getting to look at all of the organisms in the water column on these deeper dives in the deep ocean. Any other comments, Adrian, on what we're seeing right now?
Yeah, still some marine snow. Hopefully we'll be able to zoom in on some.
Oh, one just flew by.
Yep. A lot of these little things swarming around too are little crustaceans, probably amphipods. It's hard to tell because we're a little zoomed out, but there's quite a bit in the water column, all kind of microscopic. Ooh, that was, it went by really fast, unfortunately, but it looked like some type of jelly.
Mm. Ctenophore.
Thank you.
I'll see if I can see him again, but I think I zoomed past him so fast I set her spinning.
So you thought it was a ctenophore?
Ctenophore with a C.
Yep, which is a comb jelly.
I don't think we grabbed that one on our log.
You got like Roadrunner and Wile E. Coyote.
So also within this marine snow, just going to say this here, are the remains of planktic organisms that are falling, basically settling through the water column. And some of those, we hope, will make it all the way to the seabed before getting dissolved, so that Mane and I will have some cool forams in the core. We look for little tiny shells. Ooh, very nice. That was cool. Can't really tell what that was, but they're even smaller than that little particle we zoomed in on. They're about sand size, typically. But this marine snow can include the shells of very tiny microscopic protists that, if they're preserved on the seafloor, they can tell us a lot about past ocean conditions. This is actually the primary way that we reconstruct ice sheet history and climate history for the last 5 million years, and then even going back 65 million years, back to the extinction of the dinosaurs. I can tell you about ice volume from the chemistry of their shells. If you get old enough, if you get deep enough layers, so usually you need a drill core to go back millions of years. Here we're just scratching the surface, but these are really important organisms for telling past conditions because they leave behind these calcium carbonate tests that you can analyze for oxygen and carbon and calculate ice volume based upon the chemistry of those little shells. So hopefully there's some of these that we're seeing that are making their way all the way to the seafloor. That would make us very happy. Of course, there's a lot of grazing that happens in the water column. The other problem that I was mentioning just a second ago was dissolution. So the deeper you go in the water column, the higher pressure you have, and higher pressure leads to dissolution. Also colder temperatures. So it gets higher pressure and much, much colder, and so a lot of those calcium carbonate little shells will dissolve at depth.
Yeah, and Becky, we can kind of see some little pink or red things flying by as well. Those are mostly shrimp, so crustacean that we can see. Most of what we're seeing right now is pretty small though, so it's hard for us to zoom in on it.
Mm-hmm.
But I'm hoping we can get some other cool stuff for the folks at home.
Oh, what do you think that strand?
Unfortunately, that was probably not an animal. It looked like a mucus strand, potentially
okay.
from a squid or other organism that sheds that mucus layer.
Ooh, there's another one.
Mucus?
Mucus.
Yep.
I just think of someone sneezing on the screen every time we say that. Wow, and okay, so we're 2,400 meters water depth. So we're well on our way. We've got 1,100 meters to go. You can see the temperature is very cold, under 2 degrees C. Wow. About 40% saturation of oxygen. Let's see how that changes as we go down to the depths here. Oh, what's that crustacean there?
Yep, so we're zooming in now on a shrimp. You can see it with its long antenna there.
Another frame grab. Oh, and it swam away. Guess he's not used to seeing huge metal robots in the water. Or any lights, yes.
So Becky, maybe you can tell the folks at home why we're doing a deep dive today when we've been focused kind of solely at 150 and 200 meters for the expedition.
Okay, well, the reason we've been shallow the rest of this trip is because we were looking very proximal to the delta there, near Chai-10, as well as the Rias Delta a little bit farther north. If you remember, we started in the farthest northern part of Patagonia that you can access by boat, all the way up in the Rellencavi Fjord, and then we worked our way southward to Chai-10. And actually, this was a decision that was made as fast as we could out to the Simpson Canyon here, so that we could get some samples before the weather got bad. And then, of course, the plan is to then come back to the continental shelf and the middle part of the shelf and back to the inner shelf when the weather gets really bad. We want to be in those more protected areas. Yeah, so we have to contend with weather. You always have to have a backup plan, contingency plan. Actually, most of the projects of my PhD were all backup sites when weather got bad. Go into little fjords, and that ended up being, quite advantageous in the end. Our plan Bs and Cs and Ds ended up being very good for data collection, trying to escape weather. Do you want to comment any more on that, Adrienne?
No, I just completely agree. It's good to have backup plans. And selfishly, I was excited that we are in deep water today because most of my work focuses 200 meters and deeper.
Yeah, yeah.
But I've been very excited to see the coring. This is my first time seeing a vibrocore on a remotely operated vehicle. So I'm really excited to see us take it down to 3,200 meters today and see how that goes.
Yeah, this is very exciting. So I've done a lot of coring in deep water. I think the max that I've cored is probably 2,400 or 2,500 meters water depth, so about where the ROV is in the water column now. Oh, what's that there? Is that another siphonophore?
Yes. We're zooming in right now on a different species of siphonophore. This is different than the couple we've seen before. We saw a Physonect earlier, and then, of course, the flying spaghetti monster. So this is a different kind of siphonophore, and you can see that it, again, though, is that colonial organism. So each one of those are different, and they specialize in different things, whether it's feeding or locomotion.
Wow. So we're just hovering here to get a good view of it, and then we'll keep diving. Oh, that's really amazing. So it's colonial. So each little segment of that strand, is that an individual? Is that right, Adrienne?
Oh, yes. Sorry. Yeah. So it's each a specialized individual on the organism there.
Wow.
Looks like a bride.
Yeah, it looks like a veil. So the orange largest part of that strand at the very top, is that also an individual? What kind of role does it have?
Of course, you're going to ask me this. I believe that's the feeding organism. I will be completely honest with you, though. I do not study this species of Siphonophore. So hopefully someone in the chat will correct me. But yeah, I believe that's where they actually feed.
It's fascinating. Yeah, and so just to comment again, we're going really deep here. So I have, at least with science coring, I think the deepest I've cored is like 2,500 meters. We're going to 3,500 today. Of course, when I worked for industry, I think the deepest was on the order of like 5,000 meters, but that's kind of a different game altogether. I know Zach has done quite a bit of that as well. Some deep ROV work. But this particular ROV is rated to 4,500 meters. Is that right? Yeah, so pretty deep. Where was the deepest site that you guys explored?
Well, recently.
I know you did it recently. That's what I'm asking.
Atacama Trench.
The Atacama Trench.
Yeah, just off
Yeah.
Chile.
Yeah. Yeah.
4,500.
A little bit farther north in Chile, but still offshore Chile. Chile is a very long country. It extends pretty far north from here. So the Atacama Trench, the reason it's a trench is because there's a subduction zone all along the margin of Chile to the north. And that subduction zone is basically where you have heavier oceanic crust that is sinking into the mantle below the continental crust of the continent of South America. And that's why we have volcanism here. That's the whole reason for the volcanoes that we're studying. Over 10,000 volcanoes in Chile. And of course, we're looking at some of the most destructive ones. But the trench itself can be quite destructive. There was a very high magnitude, I think it was 9.1 or 2. Do you remember, Mane? Earthquake in 2010.
2010. Yeah,
2010.
sorry,
What was the
question?
magnitude of that earthquake?
Oh, I can check right now.
It's
But I
9
think
point
it was
something.
like, yeah.
Yeah, so there's a lot of different hazards here in Chile. Like every natural hazard you can think of, they have it here in Chile. The earthquakes and tsunamis that are caused by those earthquakes
So it was
being very destructive.
in Mercalli. Where is it? Sorry, I'm still looking for it. Yeah. So that will be 8.8.
8.8, okay.
Yeah.
I overestimated a little bit. It's very, very destructive because of the tsunami, the displacement of water. When that earthquake slips, it actually displaces the water, and so that's what causes the tsunami wave. And so it affected a very large area of Chile, but the
Yeah.
core of the destructive area would be Concepcion, which is just a little bit farther north of here.
Mm-hmm. Yeah, many of these islands as well were affected. As you say, the most affected zone was Concepcion, but we also had some repercussions towards even northern from Concepcion, like central and the southernmost part of northern Chile, so to
Yeah.
say.
Yeah.
And I don't know if you remember this, Becky, but we were talking about this the other day, about the other earthquake that was in Chile in 1961. Do you remember that? Yeah.
Yes.
We're still in that, even though it was in 1961, this is one of the biggest earthquakes in like the history that we have instrumental records of.
Yep.
This was in Valdivia, southern Chile, and we were still like seeing some kind of like repercussions, so to say, in the seafloor. We still have some faults that were from that earthquake, from that displacement. And actually, we're in a relatively fractured zone that some attribute to the remnants of that earthquake.
That earthquake in 1961. Yeah.
That was
Very,
a
very
magnitude
destructive.
of about 9
Okay, so
point
you want us to
something.
stop?
Yeah.
So
Coming to a controlled stop. I'll stop.
Now slowly pay out.
Slowly pay out.
So the Atacama Trench
Yeah, keep going.
is so deep. Oh, sorry, Dr. Soto has corrected us, Mane. It was 1960, he says.
oh,
Is that 1960, not 1961? And 9.2, he says. Thank you so much, Dr. Soto, for commenting in the chat here. But yeah, the reason that we have deep trenches just offshore Chile is because of this subduction zone that creates the biggest, most destructive earthquakes on our planet. And so, yeah, that very deep site that they accessed very recently with the ROV Sebastian to 4,501 meters, that was in the Atacama Trench. So the reason we have trenches is because of subduction zones. And right now, just to let you guys in on what's happening in the room, since you can't see a view of the room, is we're having a ship to shore from school children from the Chaiten area. And our teacher on board, Danny Levinyanko, and our outreach coordinator, Colombina, they are talking with the children and kind of showing them mission control, showing them what the ROV looks like. They'll also show them around the ship and explain what it's like to live on a ship and a little bit about the science that we are doing here. So they get to see the labs, they get to see what the cores look like that we're bringing up, and it's just really wonderful to get to share this, especially with students in the area and, you know, the people that come from communities that are so heavily affected by these events. Sharing with them and also learning from them. We've learned a lot especially from our teacher, Denny, on board. She shared a lot about the local culture and history and mythology around earth processes here. So volcanism and earthquakes and the sea all are very strong characters. And if you go back through the YouTube history, we actually had her talk last week about the mythology of the region, these two sister snakes for the land and the sea, and how they're always kind of interacting with one another. So we've been learning a lot about that. And they're going to talk later on this dive feed, so we hope you guys stay tuned after we get to the bottom. Once we start coring, we'll have Matilda Ferrante talk from OGS in Italy, and then we'll have Colombina and Danny talk a little bit more about the regional history here.
I begin.
And now we have, just joining the room, so the ship to shore, they just left mission control. They're going to go around the rest of the labs and areas on the ship to show the students. But we just picked up another science ninja.
Yeah.
Dr. Rodrigo Fernandez, my bestie from, I don't know, how many years now? A couple of decades. We were students together. Oh, yeah, we're very young.
Just turned 21.
We just turned 21. Today's my 21st birthday.
Happy birthday, Becky!
Woo woo!
Woo-hoo!
Thank
Happy birthday
you.
to
No,
you.
not on the live stream.
Happy birthday to you. Happy birthday, dear Becky. Happy birthday to you. Woo!
Thank you.
Hello, y'all. I'm Rodrigo Fernandez. I'm a marine geologist and geophysicist from Universidad de Chile. And I met actually Becky, I'm not going to say how many years ago, let's say not so long ago.
Yeah, not
While
too
doing
long.
our PhDs in Texas at Rice University. So I worked
Go
with,
Owls!
Yeah, go Owls. Fun enough, University of Chile has the same master.
Yeah.
We also have the owl. Yeah. So
It's very wise, you
yeah.
know.
So just change languages from Spanish to English. You know.
¿Cómo se
Spanish
dice en español owl?
Búho. Búho.
Búho.
Búho. Yes.
Me gusto.
See, Becky, they're saying happy birthday.
Aw, thank you
They
guys.
do, you know. Oh, there's a few questions about earthquakes.
Yeah, Eulogio's on.
tectonics. Yeah.
Eulogio's listening.
Yeah, look, but I think the earthquake magnitude is more like 9.4 to 5. It's been recalculated several times. First paper said was 9.5. Some people can lower that amount, but because the scale is logarithmic, between a 0.1 difference in magnitude actually makes a lot of difference. Terrain, something, yeah. So, right. So we are right now in the terrain, the contact between Nazca and South America plate. That's plate boundary. To the east, there is a north-south running fault system called the Geological fault system. And there is the proposition that this system actually is the eastern limit of a terrain, a crustal terrain called Chaitenia. So the Chaitenia will be limited between the Geological fault system and the trench. This is under study, it's been proposed. But yeah, there are still people working on that one. Another one, so Mane, right next to me, she doesn't believe in Chaitanya, so she's laughing and telling me not to tell that. But if you read the papers, actually there is some information pointing that there might be a crustal terrain in this area, different from the rest of Patagonia. There was another question about earthquake. Oh, what happened? Yeah, okay. Right, so in this area, which was mapped a few years ago by a Chilean science vessel, they found that there are evidence of several landslides, submarine landslides, mud flows and turbid flows that are being deposited at the foothills of the slope, and some of these sediments or material are coming down to the trench. So if anything like that happens, yes, we will see lots of material coming down from the canyon and from the sides toward this area, which it make it more interesting, don't you think, Becky?
Very interesting. That's what I want to see.
Right.
We want a nice
I'm
long
going over
sequence here.
the chat to see if I find any other question about local geology.
I think mostly people are saying local geology here is awesome, and Chile is one of the best places to study it.
Well, this is a nice place because we actually have a triple junction. So there is not that far south. There is the joining of three plates. On the ocean, we have the Antarctic and the Nazca plates, and they are in contact with the South American plate in something called the Taitao Peninsula Triple Junction. So it's a place where there's a lot of geothermal activity, submarine volcanism in some areas, some seismic activity, very shallow in this case, and it has attracted the interest of scientists for decades. And you have, I remember, you have ophiolites.
Yes, somebody asked about accreted terrain earlier. That is something that we geologists would call ophiolites.
Right. So there is outcrop of ophiolites, which is basically the rocks that made up the oceanic crust. Sorry for the mispronunciation. And the outcrops are right now on land and the western tips of the Taitao Peninsula. And if you think about water depth, so right now we're about 3,500 meters depth. So if the setting was similar, that means that those rocks up there rise up from the seafloor above sea level, moving more than 3 kilometers in vertical elevation.
Pretty substantial change.
Yeah. And we have also, because this part of South America was north-south, so you get a latitudinal gradient in climate changes in oceanic conditions, different oceanic currents. There's a chain of volcanoes that goes along the Andes, the Patagonian Andes. They're flanked by these fault systems. So you have several things going on at the same time.
So many things going on.
Glaciations,
Super
right?
complex.
Which Becky loves, of course.
Yes.
Glacial stuff, non-glacial, not so much.
Glacial, marine,
Yeah, right. So it's all happening together.
where
so
the
you have,
glaciers meet the sea.
right.
Yeah.
Another thing I just recall, because I see some people are getting into this, that in some areas near southeast from here, people have measured up to 3.5 centimeters of uplift per year, and in some cases a bit more. And this is related to glaciostatic rebound.
Uplift?
Yes.
Rodrigo, I thought that sea level was rising globally. How could it be uplift of the land and lowering of sea level here?
What
Explain
an
that.
amazing question, Becky. I can't believe you came out with that one. Wow. So the thing is, after during the glaciation has all this weight of ice on top, it actually lowered the crust a bit. And then after the retreat,
Pushes it down into the mantle.
Exactly.
Yeah.
Into, how do we call that, Becky? The part of the mantle that get pushed away?
Asthenosphere.
Asthenosphere. Yeah. And though,
You can
so
think of it like asphalt. Like it's
Yeah.
it's very
asthenospheric. It's very asthenospheric.
Asthenospheric.
Yeah. That's the way I will describe it. Is asthenosphere some kind of asthenospheric material that lives, where asthenospheric
Yeah.
kind of stuff live.
Yeah, asphalt on a really hot Texas day.
Right. So after the glaciation, you unload the crust, allowing the crust to rebound, and we call that isostatic rebound, and that's what's driven the uplift in some part of Patagonia. Because we got two ice fields, very large one, actually the largest bodies of ice outside Antarctica in the southern hemisphere. So when you thin and retreat glaciers, crust start uplifting, and you get all this. This is interesting because the coastline also rise up, right? So you get like archaeological sites, for instance, that are supposed to be originally at sea level because people who live out of the sea now are several meters above. So you get all this material that was supposed to be intertidal, let's say, and now are like several meters above. So
Yeah, and
it's pretty neat.
you don't have to really excavate it as much.
No.
You don't have all of these deposits on top of it.
Right.
Yeah. It's rising up. The land surface is rising up.
Right. Another cool fact that I just recall. So because glaciers tend to produce erosion in a very focalized way, so fjords here are very deep. We have some fjords that go down to
700 meters.
more than that. We got a record Messier Channel, 1,200 meters
1,200
of glacial
meters.
incision, and next to it some mountains. They call it mountains, 2,000 meters high. So you have 3
Wow.
kilometers of relief in
Wow,
very
that's like
tight
how
area.
far we're diving now. You can get a
Exactly.
feeling for just how long this is taking.
Right.
Yeah, that's really amazing relief.
Yeah, a lot of relief, and also something else I just recall. So during the last glacial maximum, this part of the Cordillera was joined and covered by a large ice sheet called the Pleistocene. I don't want to say Pisco, but remember the Pisco proposal?
Say Pisco.
Okay.
Go for it.
Okay.
Go. There's a proposal that was written many years ago
A few years ago.
with Rodrigo kind of leading this idea, but to name it after a very famous and good Chilean beverage,
Right, called Pisco.
Pisco sours.
Yeah, so Pisco goes for Patagonian ice sheet, climate and ocean interactions. So this would be the Pleistocene ice sheet in Patagonia I'm
Yep.
talking about. So when all of this was covered by the ice sheet, so part of the meltwater coming from the ice, it will go east into Argentina. So there will be like giant lakes in that part of the world. In the western part, actually, we don't know much about it. We don't know if there was ice in contact with the ocean or ice on land, and then, like a strip of land perhaps, and then the ocean.
Well, that's
Thing
kind
is-
of what we're looking for here, isn't it?
Yeah, we might find evidence of this kind of old evolution happening here.
Even though we are far and deeper than where those ice sheets would reach,
Right.
we can see the sedimentary products
Right.
of that ice sheet and how it evolved with time, we might even be able to see multiple glacial cycles.
Exactly. So here in Patagonia, we have evidence of glaciation starting about 7 million years ago. And this has been recorded by glacial sediments, mostly in the Argentinian side.
7 million.
Millions.
Just making
yeah.
sure we pronounce that carefully. Million.
Millions.
The Earth is only...
Millones.
Yeah. The Earth is only 4.6 billion years old, so...
Yeah.
Oh, they like
did
the
you hear
name.
billions?
They like Pisco.
They like Pisco? Oh, of course they like. Who doesn't? Who doesn't like Pisco?
Everybody.
Huh?
It's good. It's good.
Yeah, it's okay. So the thing is, I was telling this story. So when we got the ice sheet, so the drainage for big part of the ice sheet was going east towards Argentina, and then with the ice sheet started thinning, it got separated in the two ice fields we know now, and the drainage shifted from going east to the Atlantic to the Pacific.
Yeah.
So there's a big change in drainage, right? So in some areas not in this particular project, but in some areas we expect to see the evidence of this shift in drainage, which it should have been really something huge. You know, you have these huge lakes, almost like small seas, and then shifting drainage like very suddenly. That's the other thing, because this is related with the resistance of the ice itself to contain all this water. So
Yeah,
imagine
so it's like a dam holding
Exactly.
the water back.
Exactly.
So you actually have these lakes sitting behind the farthest extent of the ice sheet.
Right.
As
Yeah.
it's melting and producing a lot of fresh water there.
Exactly.
Yeah, but then at some point it becomes marine, right? Because it's marine today.
Right. So at some point, it's about 13,000 years ago, there was this shift in drainage from going towards the Atlantic and then towards the Pacific. And then we got the transgression, right? The inundation by the seas of the coastal
So what
areas.
does transgression mean?
Oh, I don't know. Maybe Mane wants to say
Maybe
something.
Mane wants
Because
to tell
Mane
us what a
is always,
transgression
making
is.
faces.
We've been teaching her all of these things.
Yeah. Mane is our student, just finished her undergrad thesis just before the cruise.
I already told them.
Oh, you say that? Okay, I'm repeating stuff you know.
But we co-advised her with Rodrigo really leading at Universidad de Chile, and now she's coming to University of Alabama, and we're gonna keep co-advising her. So
Yeah, we're gonna make the very best marine geologist / biologist / geophysicist of the world ever produced.
she just rolled her eyes, but
Yeah.
we know.
Yeah, we know.
All right, what's transgression?
This is an ongoing experiment.
Miss Heberlein.
Oh my god, everyone's looking at me right now in the room. Stop. So you were talking about sea level rise. You have two words, transgression and regression, right? It's the same in English as it is in Spanish?
Yes.
Okay.
También.
So yeah, transgression would be when we have a relative sea level rise and then the water is getting closer and closer to the land, and at some point starting to cover some of the, for example, beach front, and then getting more and more into land. And then regression is when the opposite happens, when we have a declining sea level, it starts to retreat, and then we have more and more exposed sediments that were before below the water. So that's the kind of idea.
Yeah, so the transgression is when you have marine flooding of the coast. The coast is becoming inundated because sea level is going up. The bathtub is filling up with more water. A lot of times, at least in this time period of the Earth, it's because of melting ice mainly. Over longer time scales, it might be because of fast seafloor spreading rates. So it could be more of a tectonic reason if you're looking over several millions of years, tectonic time scales. But on this time scale, where we have a major ice sheet in the south and a major ice sheet in the north, we actually know it's mainly because of ice melting and then warming of the seawater as well, because water will expand when you heat it up. Yeah, so transgression just means the water is flooding the coast. Anything else you want to add, Mane? Maybe you want to talk about the history a little bit of the part of Antarctica that you just studied.
Yeah,
And the
sure.
history of ice changing there and contributing to sea level rise.
I don't know if you've spoken a little bit before about Antarctica today. Have you?
Just start from the beginning.
Okay, from the beginning. So I did my undergrad / master's, kind of weird, thesis in Antarctica, in West Antarctica, actually. I studied a small basin called Craton Bay. This is in the Amundsen Sea, which is very well known for a few glaciers that are there, right, Becky?
Yes, the Doomsday.
The Doomsday Glacier. Yeah, exactly. Thwaites. But we also have another actor. That's the Pine Island Glacier.
Pine Island Glacier,
Mm-hmm.
the pig,
The pig.
PIG.
Yeah. So these two glaciers have been very well studied. Now, in 2019, they weren't. And the thing is, they have the highest retreat rates in Antarctica, and they are contributing a lot to sea level rise. Actually, the Amundsen Sea is one of the places that we have the highest amount of melting.
Yes.
So high
Yes.
melting rates and also elevated rates of ground ice retreat. So it's very interesting.
That means that the base of the glaciers and the ice sheet itself landward, right? So
Exactly.
it's getting smaller.
Mm-hmm.
Yeah.
And another cool thing about the Amundsen Sea is that it has this special configuration in terms of the seafloor. Normally, we would expect the seafloor to kind of like go shallower and shallower as you go into the continent. But in this sector, actually, the seafloor tends to deepen inland. So we have this revert slope.
Mm-hmm. Retrograde.
Retrograde slope.
Yeah.
Yeah.
Why is that? Why does it get deeper?
That's a good question. I actually am not sure. I believe it has to do with glacial carving or maybe.
Okay. Yeah. Some of it is that.
Oh yeah.
But also,
and
we just
I know
talked
the answer
about-
for this.
Yeah.
Yeah, we also have the Oceanographic rifting system. I think that
Yes.
could be
So
contributing
it's
as well.
also tectonics.
And isostasy.
Yes, that's the main one. It's actually like that across the Antarctic continent that you see the continental shelf edge is bathymetrically higher than the inner shelf. So it
Mhm.
actually slopes down landward. And that's something that you would expect anywhere you have a major ice sheet. So
Mhm.
it's highly relevant to where we are now, where we've had a major ice sheet in the recent past in Patagonia that started retreating about 17,000 years ago there.
Yeah.
But what about the retreat of the Antarctic ice sheet that you just studied?
Yeah, so we're very interested in that sector because as the glaciers retreat, more and more ice get exposed to the sea and the ocean. And that can trigger some more melting and then trigger
Mhm.
some more retreat. So
Mhm.
it's kind of this positive feedback where we
Yeah.
have more and more ice melting. So that's why people study a lot the Amundsen Sea.
Mm-hmm.
And actually, Becky was just talking about opportunistic
Yeah.
studies.
Yep.
Yeah.
Weather gets bad. You go to an area that's more protected and
Yeah.
yeah.
So in my case, it wasn't because of the weather, but it was because of the seals,
Yeah.
right? You can tell us more about that, but as far as I'm concerned, you guys only went to Craton Bay to do some seal tagging.
Yes, that's correct. So on that particular, it was NSF and NERC funded that expedition, actually 3 expeditions of the Thwaites Glacier Offshore Research Group. We were collaborating with oceanographers, kind of like we're doing on this expedition. And the oceanographers were doing something very different. They weren't just doing CTDs, looking at temperatures and salinity of the water. They were actually through a typical device that you just send off the side of the ship. They were actually tagging seals. So they were putting little, pretty small. They were like, let's see, like 2 inches by 1 inch, maybe, like
Sensors?
2 by 6 centimeters sensors on their foreheads. So you just glue them there, and then when they molt, they fall off. But they called them sentinels, so they would keep collecting data long after we put that sensor on them. So we went to the small island group, the Lindsay Islands, just to tag seals. But the ship was kind of, we didn't want to just do nothing while we were waiting on the seal taggers. So we collected cores and a bunch of geophysical data sets of the seafloor, and that became Mane's
Thesis.
thesis.
Yeah.
So,
So that beautiful core is core KC72,
yay.
and it's a 3-meter long cast core.
Mhm.
And at the beginning, we were just expecting to find a normal history of glacial retreat with beautiful diatoms and maybe some forams.
And diatoms coming in once the ice retreats, and you have marine water, because
Mhm.
they like to live in the surface
Yeah.
of the marine water, and also on the seafloor where it's shallow. You get some benthic diatoms.
Yeah.
So we were just hoping to see the normal sequence. But
Exactly.
What did you see?
But the thing is, and we haven't given this background to our audience yet, but there's this interesting water mass in Antarctica that's called the circumpolar deep water.
Mhm.
And it is actually one of the main actors of glacial retreat
Yep.
in the Amazon Sea.
Yep.
It's this relatively warm oceanic current.
Mhm.
It's about 1
Let's
degree
see.
Celsius.
So, yeah, if we're looking at the water we're going through right now, 1.79 degrees C, that's pretty cold. Like, if you were to
Mhm.
swim in this water, you get hypothermia pretty fast.
Mm-hmm.
Probably have maybe 5 minutes.
Mm-hmm.
Yeah.
Yeah. Before
But
we
that's the same temperature as the circumpolar deep water in Antarctica.
Exactly. So it might not sound as a very warm water mass, but actually when you put it in contact with the glaciers.
Yeah, it's above freezing, so
Mhm.
it'll melt it from below.
Yeah.
Yeah.
And well, the cool thing we found in Cranton Bay was that we weren't expecting circumpolar deep water to be there because it's a very shallow embayment. It's
Mhm.
about, well, bathymetry varies, but the highest bathymetric features are about 200 meters below sea level, sorry.
Mhm.
And circumpolar deep water flows at water depths of about 800 meters. Well, it depends, but it's very
Yeah,
deep.
like 800 to 400, 350 sometimes.
Yeah.
So,
So what we found in the core were this open marine diatoms.
mhm.
It's called Fragilarius kerguelensis.
Kerguelensis. Look it up. Those
Yeah.
of you guys who have the ability to multitask here, they're
Mhm.
beautiful diatoms.
Yeah, one of my favorites.
Yeah.
And
They're super trippy. They have
Yeah.
this very weird pattern of their areolae.
really- Yeah, and the cool thing is that that particular diatom tells us that circumpolar deep water was there in Cranton Bay in a period where we actually didn't expect to see it. So
Mhm.
that was the first thing we found out interesting about Cranton Bay, but also the radiocarbon ages.
Yeah.
The base of the core dated back to 13.5 thousand years before present, so that's the latest part of Pleistocene. That's a lot.
That's so
Yeah.
early
Mm-hmm.
versus other areas just nearby,
Mhm.
actually.
Exactly, yeah.
Yeah,
Just
really
nearby
early
we have
retreat.
like 10,000.
10,000
Even
is kind of the
yeah,
average.
It's kind of the
The inner
average.
shelf. Yeah.
So this small bay deglaciated earlier than the rest of the inner and middle shelf.
Mhm.
So that was another big thing we found out.
Yeah.
And when we put all of the proxies together, we got this beautiful story of retreat of this small basin. And we
Yeah.
are kind of trying to understand right now whether or not the small basins are causing big problems. That's how we
I
like
love
to
that
call
you're
it.
using that. You're trying to come up with catchy taglines for presentation titles.
Mm-hmm.
Small bays
basins.
cause big problems.
Yeah. So yeah, that's kind of the hypothesis right now. Right
Yeah,
now,
that it
to-
was connected to the ocean, so it
Mhm.
actually led to retreat of the rest of the ice sheet to the
Exactly.
intercontinental shelf. Yeah.
And we also kind of see something similar in Patagonia with the last glacier tongues that we have right now.
Mhm,
If you go to Google Earth and then zoom
Yeah.
into the southernmost part of this will be the northern
yeah, northern Patagonian ice sheet.
cap. They like to
Ice
call it
cap
ice.
now.
Ice sheet, ice
Yeah.
cap. Well,
When it gets smaller, we
Yeah.
decide it's just a little hat. It's no longer a sheet anymore. So we call it an
Exactly.
ice cap.
Mhm. So we've been also studying Stefan Glacier, and you
Yeah.
can see kind of like the same idea there.
Yeah.
The small lakes right now, they were glaciers in the past,
Yeah.
tributary to the main glacier, that's the
Mhm.
Stefan Glacier, and you can actually see that the small glaciers deglaciated and they just retreated faster than the main
Yeah.
system. So it's kind of
Yeah.
like the same idea, and we've been seeing
You
this
guys
over
have been
and over.
mapping this. You've been mapping from satellite images
Mhm.
how these glaciers in northern Patagonia are interacting with the water
Exactly.
at the bed and, you know, up slope of it, and
Mhm.
how it makes its way into these lakes downslope of the glaciers.
Exactly.
It's
But
quite fascinating.
we're mostly interested in understanding the glacial lake outburst floods,
Yeah.
which are very risky for
Yuckle
people.
hops.
Yuckle hops, yeah. For people that live around those
Yeah.
sectors.
Yeah.
So-
Yeah. So just another natural hazard in Chile.
Mhm. Exactly.
But yeah, that's really, really important. And so you mentioned earlier, Mane, just going to bring it back
Mhm.
to what we're doing here on board and what we plan to do with the sediment here after we leave the Falcor 2. You mentioned proxies.
Mhm.
What are proxies? You were talking about how you were using proxies to tell the story of this basin in Antarctica. Explain what proxies are, and then maybe expand on how we're using similar proxies here in northern Patagonia and these sediments we're collecting.
Okay, so a proxy, this is a word that comes from like the lawyer's world.
Yeah. Yeah.
Yeah, this is a proxy is someone that represents you when you can't be there.
Yeah.
So that's kind of like the idea behind the word. And the proxies we use are, in this case, for example, something from the sediment,
Mhm.
either, for example, the grain size or some materials that we can find in the sediment, in this case, algae or
Mhm.
foraminifera. Maybe
Mhm.
Becky has already talked a little bit about
A
this.
little bit.
But all of these things together, when we put them in a time context and when we plot them one next to the other, and we see, for example, how the grain size of the sediments vary throughout the core, how the diatoms, the algae in this case, vary throughout the
Mhm.
core, how the foraminifera vary, and how the species vary.
Mhm.
That tells you a little story of environmental changes,
Mhm.
and that's
And the
what
chemicals
we do.
of them
And the
too,
chemicals
yeah.
of them, yeah, isotopes, for
Stable
example.
isotopes. We love stable isotopes.
Mm-hmm.
Yeah.
So that's the
so
idea.
you can't directly measure temperature
Mm-hmm. But
5,000 years ago,
Exactly.
but you can have a proxy for it in one of these parameters. Like, for
Mhm.
example, if you are looking at species of diatoms, you might find diatoms that like warmer water or
Or-
more open water versus diatoms that like more sea ice and colder
Mhm.
water, right? So that is a proxy for temperature conditions in the environment. We can't directly measure it. We weren't there with our instruments 5,000 years ago, but we can indirectly measure it through these proxies.
Exactly. And so also other things. We can do element analysis in foraminifera. For example, we can do magnesium calcium,
This
right?
is what Mane really wants to do when we get home.
What's that, Becky? What's that for?
She wants to look at paleo temperatures. I should make you say it because this is your big, like, exciting thing
Yeah.
that you're proposing for your PhD. We've got a lot of forams in these cores, a lot of
Mhm.
these tiny microscopic shells that are, you know, in the sediment, not just at the surface, but luckily we find them at depth in the sediment cores. So in these long metal tubes that we're bringing back, we're actually finding forams throughout some of these cores. And if we find enough of certain species,
Mm-hmm.
we could actually analyze them for trace metals. We could look at things like magnesium and calcium and how they change with time
Mm-hmm.
as a paleothermometer.
Exactly. So yeah, those are all proxies, and that's kind of what we do. We take this multi-proxy approach to better understand the past, to try and understand the climate, the environment, the ocean. So that's what we do.
Yeah, what the volcanoes were doing,
Mm-hmm.
what the glaciers were doing.
Exactly. Hopefully we
what
can
the
go back.
ocean was doing.
Yeah.
Yeah, all the different parameters. That's why we do the multi-proxy, right?
Mhm.
So they each tell us something slightly different, and when we put them all together, we get more of a holistic view of past environments. And in this case, we're hoping for past environments before and after eruptive events.
Mm-hmm.
See how those eruptions affected not just the ecosystem really close to the volcano, but even farther away, like
Yes.
where we are on the slope in Simpson Canyon.
Mm-hmm.
And Dr. Fernandez is back. Do you have
Hello.
anything to add to that? We just talked about Cranton Bay, and we brought it around to talk about what we're planning to do here with the core
Right.
analysis.
A sec. Yeah, no, I just wanted to point out that we are very close to reach the seafloor. Right now,
Woo.
yeah, it's gonna be very soon.
Yeah, we have about 100 meters.
I'm gonna introduce something in Spanish if anybody
do.
from the area is listening to this. So, estamos ubicados al oeste de la isla Guafo. Esto es al oeste del Golfo del Corcovado. Y a una profundidad de cerca de 3.400 metros bajo el nivel del mar, a la salida de lo que se llama el cañón submarino Simpson. Un cañón submarino es, imagínense, un valle que tiene la apariencia de un valle fluvial, como el que todos conocemos, que conecta las zonas poco profundas de la plataforma, que en este caso son zonas de aproximadamente 150 metros de profundidad, con las zonas más profundas. En este caso estamos ubicados sobre la intersección de las placas tectónicas de Nazca y Sudamérica, un lugar que se llama La Fosa, y a la salida de este gran valle, que tiene meandros, en verdad no es totalmente recto, tiene sedimento, existe algo que se llama un abanico de pie de cañón, en español, que es una zona donde todos los productos, materiales que van bajando por este cañón son dispersados y se depositan a la salida. Entonces lo que nosotros queremos con el robot submarino Sebastián es tomar varias muestras de esto para ver si es que por ahí podemos tener un registro de estos sedimentos y encontrar alguna indicación de fenómenos glaciales o volcánicos. El objetivo del proyecto, o uno de los objetivos del proyecto, es estudiar los registros sedimentarios de volcanismo pasado a distintas escalas de tiempo y en distintos lugares geográficos. Y si cuando estamos estudiando en estos lugares tan profundos, tan lejos de la plataforma, estamos focalizando en la historia larga de los volcanismos y glaciaciones, con periodos de ocurrencia de cada 100.000 años por los últimos 1.000.000 de años. Entonces, estos son escalas de tiempo muy largas, que los glaciares avanzan, ¿verdad? Lentamente, más o menos cada 100.000 años retroceden, y cuando avanzan y llegan cerca del borde de la plataforma, todos los sedimentos que van trasladando en su interior y por abajo alcanzan estas zonas muy cercanas a la plataforma, llegan a los cañones submarinos y son transportados por los cañones submarinos hasta las profundidades oceánicas, en este caso de 3.400, 3.500 metros. Una vez que los glaciares retroceden, entonces también van retrocediendo hacia el este las zonas de acumulación.
Now we're all excited because we're on the seabed. What do we see, guys? Let's maybe talk about some of our observations here. Rodrigo, you want to?
Yeah, I'm just watching the cameras. So
Are those like sea cucumbers or sea pigs or something?
yeah, there's some.
Very interesting.
Yeah, they look like a biological
Wow.
material. This.
Ooh. It's very
what I'm-
fluffy here.
What I'm after in this occasion is
I'm
the geomorphological networks.
all right. Sorry, we just are everything comes together at once. We get really busy really fast once we get to the seafloor, so we're really excited. But I'm also very excited today to introduce. I'm going to pass the lead of this dive off to my dear colleague, Dr. Matilda Ferrante from OGS in Trieste in Italy. And she has been behind the scenes mapping and mapping and mapping. And in fact, she stayed up all night as she watched us traverse across Simpson Canyon. So, Matilda, would you like to take over the seat here?
Yeah, hi.
And just pass things off to her. Thank you. Woo!
Hello, everyone.
That's one way.
Hello, I'm Matilde. I'm a geophysicist. And we just touched the bottom with our ROV. We spent the whole night mapping the canyon with our multi-beam and with our sub-bottom profiler. The weather was pretty rough, so we still need to check for the quality of our data, but we will have time to map it again tonight. Yeah, let's get some sediment. We are here for this. It's one of the deepest diving of Sebastian, I think.
Matilda, so you have to tell them what to do next.
5 years off the
We got our
So
We got our
you
first-
want to go to the seabed and you want
want to go to the seabed. We're gonna take a Niskin,
Mm-hmm.
and then we're gonna vibrocore right away. Does that
How
sound
many?
good?
How many vibraphone?
One here.
One here.
One.
We lift up, browse around, pick another location, and we do another.
Do we want to do any push cores?
Yes.
Do we want to vibro
Maybe-
first?
Also here.
You could do
One
push go first. Yeah. So,
Okay,
how
so
much
do
weight?
one push, one
How much weight do you want to put on Sebastian? 3 vibros and all the push cords and all that, or that's my concern.
They will have to be 5. That's why you have 5 on the rank.
Do you think so?
Mm-hmm.
That's what they said.
I can check.
Oh wow! Look at these brittle stars.
Rodrigo, I'll grab this for a second.
Yeah.
One vibe, one push. Do you want to do push first?
No, I will do.
Vibro first. See what we get.
Yes, yes. I like to test the quality of the sound. Look at that.
Wow. That's a sea pig. I know. We've seen so many of them just to the left of the sea star there. It's kind of whitish.
This is the plan. I think we should try one.
John, can you change the view of the YouTube so they can see the seafloor?
So that one and that one has the modified core catchers.
Mm-hmm.
These 3 are the regular core catchers.
Mm-hmm.
So I'm thinking maybe we try yours first, see how they work, and then so we have the room for that and room for all these push cores. And
One Niskin on the bottom, yep.
and all these Niskin on the bottom.
Mm-hmm. And
And then that one, Niskin.
So I'm thinking that in this case, so you're the commander, I'm your sub-commander, so I advise you and you make the decision.
are you
because,
staying here or are you staying there?
whatever you want me to do.
Here. What do you write here except for
Yeah, we're gonna do 2 on the bottom.
that we did something? What do you write? Just on notes?
Yeah, I mean, there's people taking the logs. So since I am your sub, I'm gonna make sure that people log in, get the right number for the vibros and the right number for this. Hey, wait,
Yes.
I think they want me to be.
Sure.
And como digan, I
We're gonna sit here.
don't know. They just need one mic.
Okay.
It's my call. Whichever one. Maybe that one.
You're over. Okay.
after this now we're going to push cord or vibro?
Vibro.
That is totally a sea pig. Yeah.
We're excited about the sea pig.
So you can see the brittle star, and you can see the sea pig just next to it.
So after the next thing, you tell me that.
Okay, so fun fact,
Mhm,
because we
mhm.
pulled up
What
sea
did you
pigs
done?
in
You
wars
need to
before.
know the
They
number.
make
and
spiral
the number,
pools.
number 5.
Number.
Your head number. Yes.
I think so.
You just say that we want to modify.
No. That's already in place.
Okay.
It's already there.
Okay.
Vibrate starting or push in first.
I'll do vibro first.
Vibro first, okay. That's what I told
Okay,
him.
it's already there.
This is number 5.
That's number 5. Okay. And so I'm proposing we do that first before the push course, so we get a sense of
What the
how
sediments.
feels.
So we're putting the
And then
vibrocore in
we try the push
position.
core. And in the meantime, we need to
We're
decide
gonna
what we do.
try to get a
just-
vibrocore first. You should try it. I'm gonna try to get the cucumber. It's not gonna. All right, now we're vibrating, huh? see what the seabed looks like here.
So we started with the spider core. Once we see how the sediment responds, we will decide one or more.
Was there any resistance? Okay. Still no resistance, Andy? So what you're hearing here we're all reorganizing a bit because we have a full house. It's really exciting, isn't it, Matilda?
Yeah, today, yeah. Everyone is here for this exciting diving. Ah, yes, there is a question for the biologist.
Let's see. All right. Gianluca and Diego, comment if you wish. I believe that that's an echinoderm there. Little brittle star on the seafloor that's kind of pinkish. And on the sort of upper part of your screen. And then just in front of that, you can kind of see there's a light colored, almost transparent organism on the seafloor. And it's not really moving. But that we've talked about it and we've agreed that's a sea pig. And those actually do bioluminesce sometimes. We had some questions about bioluminescence earlier. And sea pigs make spirally poops. We've pulled them up in cores before and let them kind of sit on the surface before clearing off the water and removing them. And yeah, they kind of disturb that very surface of the sediment, and their poop is spiral in shape. It's very interesting.
Not resisting. So we're still vibrating. Wait for the touch. Something harder.
What do you think we hit?
Yeah, let's see. We believe that this canyon is one main exit for the exit pathway for the sediment from on land and from the proximal basin.
Yeah, a great thing.
So we actually expect to see some long-term recording of the volcano, of the Chaitan volcano, or other surrounding volcanoes. And unfortunately, from the seismic, we couldn't see the structure of the shallowest subsurface in a very detailed way. Again, because of the bad weather and the bubbles generating from the ship that was rolling, pitching, everything. But still, we know there must be some sediment coverage here.
I know, I think it makes sense to make less coverage.
Yeah. Yeah.
Rather than repetition. Just to get a sense of, you wouldn't expect huge local variation. But we may see local variation.
Could do 1 by 2 push.
That's quite hard.
Yeah, looks like it's quite hard here.
3.
Our vibrocore, it's
Can we
not
stop and
penetrating.
start again?
We may have found something,
Stop vibrating.
something sandy or harder.
What do you think about stopping the vibration and starting it again?
Yeah,
That's what we've been
we
doing.
did.
Oh,
we
yeah.
did it twice.
Andy knows.
We got, well,
It is going down slowly.
yeah, now yes.
Yeah. Yeah, we're gonna ask him right after the vibe is done
can we
to
do
do
that
this.
scoop?
You want to do it with the scoop instead of? Do you want to try the suction though?
This one is not gonna work with the suction.
Yeah, I know that won't work, but do you want to try
Oh, we're gonna try.
for because it might be easier to try with the suction on that because you don't move very fast,
This one with the scoop back.
and that one with the scoop. Okay. So I think we're gonna vibe, try the suction, push, and scoop. 1, 1, 1. So we won't have extra push cores. Okay.
Yeah, it seems like we touched hard thinking something harder.
Yes, please.
I don't want to break it. All right. This is going to be in Spanish. Estamos todavía en el sitio de muestreo de la salida del cañón submarino Simpson. En este momento estamos tomando una muestra con un equipo que se llama el saca testigo por vibración, en inglés el vibrocore, y tenemos un nuevo equipo de trabajo acá en las transmisiones. Está liderando en este momento la operación Matilde Ferrante, de Italia.
Hola.
Ciao. Ciao Matilde.
Ciao, buongiorno.
Estoy yo, Radio Fernández, de copiloto de ella. Está Rebecca Totten, de Alabama, dando consejos en la parte de biología marina y geología. Y tenemos en esta oportunidad a nuestras líderes de los programas de divulgación y difusión del proyecto, que están ahí, si pueden acercarse al micrófono y saludar, Amanda Colombina Venezuela y Dani Leviñanco, que nos van a estar ayudando para poder transmitirles esto en español a todos los que están escuchando en la región de los lagos y más allá en idioma español. Para los que no saben de idioma español, hemos hecho, ellas les van a contar un poco más, varias actividades de llegada a la comunidad, particularmente dirigidas a los niños de la comuna de Chaitén, Ellos estuvieron visitando el buque, ahí van a recibir más detalles. Y ahora están acá para ayudarnos a mostrarles esto, que es algo bien especial, porque este es el cañón, uno de los cañones submarinos más lindos que tenemos en Chile y que está llegando en este momento casi, bueno, en este momento estamos parados a 3.400 metros de profundidad. Así que algo bien especial, cercano, en una manera cercano y lejano ahí a la gente que vive en los lagos. Así que Amanda, Dani, si pueden saludar.
Bueno, buenos días a todos los que están conectados en esta transmisión este día sobre el cañón Simpson. Mi nombre es Dani Leviñanco, soy profesora de Educación General Básica. Vengo desde la pequeña isla de Chuit, en el archipiélago de Desertores de la comuna de Chaitén. Bienvenidos.
Hola queridos y queridas, por aquí Colombina Valdés, bióloga marina y comunicadora científica en este día tan especial para nosotros y nosotras, el equipo científico, Dani Leviñanco, la docente que nos acompaña, ya que fue el último día de transmisión del programa Ship to Shore a toda la comuna de Chaitén. Esperando que nos acompañen durante esta inmersión, vamos a proceder a comunicarles todo lo que pasa en vivo y en directo. En este momento, el robot submarino se encuentra a 3.407 metros de profundidad.
Un día muy sensible para nosotras. Ya acabamos con estas sesiones de divulgación científica que trató de conectar a las 16 escuelas de la comuna de Chaitén, tanto escuelas urbanas como del sector rural, considerando que la comuna de Chaitén manifiesta una importancia dentro del territorio porque considera parte urbana, que es la ciudad de Chaitén, sector cordillerano, cercano a Villa Santa Lucía, por ejemplo, sector El Amarillo. Tenemos sector costero, que involucró a las escuelas de Chana, las escuelas de Casa de Pesca, Chumeldén y Loyola. Sector peninsular, donde se encuentra la escuela de Will, que fue hoy día nuestro último Ship to Shore de la comuna de Chaitén. Tenemos al Liceo Peninsular Ayacara, a la escuela de Hueque y a la escuela de Pollo, que por una u otra implicancia no pudieron llegar a su cita. Creo que fue como nuestra última y única escuelita que no pudimos comunicar, pero también tenemos a las escuelas del sector insular, donde les doy un cariñoso saludo a todos quienes nos puedan estar escuchando en las escuelas de la isla de Chulín, Nueva Esperanza, de Isla Chuit, Escuela Rural Chuit, Escuela Autení, Nayagüe y de la isla Atalcán. Un saludo cariñoso desde esta transmisión en este día martes 17. ¡Wow! Hemos perdido ya un poco toda esta temporalidad que nos acompaña en nuestro cotidiano vivir. Estamos acá sobre un crucero científico llamado Falcor 2, que es nuestro dragón de color azul que nos transporta por todos estos mares. Estamos en este preciso momento en el Océano Pacífico, en el sector oeste de la isla Guafo, inmersos ya a 3.407 metros desde el sector donde está actualmente fondeado el Falcor 2 hasta la base donde el robot Sebastian ya comienza a hacer las primeras pruebas científicas. Estamos esperando expectantes, ¿cierto?, a este trabajo, Colombina.
Exactamente, y comentarles que no solo quedó ahí, no solo quedó en las escuelas de la comunidad de Chaitén, sino que incluso nos expandimos hasta Ushuaia, una escuela de Ushuaia, de Argentina, de, como dicen por ahí, la última ciudad del mundo. Nos acompañó durante estas transmisiones en vivo, que incluso nos comunican aquí desde el instituto, batimos el récord de las mayores transmisiones en vivo, del mayor número de transmisiones en vivo de este programa Ship to Shore.
Síganos en nuestras redes sociales, fireandiceproject.cl, esa es la dirección en Instagram. Repito, fireandiceproject.cl, y también toda esta información es retransmitida a través de las redes sociales de la Escuela Chuit. Repito, Escuela Chuit, a través de Facebook e Instagram. Por lo tanto, todo este trabajo de divulgación científica que se ha realizado con los estudiantes de las escuelas de Chaitén está contenido como una bitácora de viaje. Además de Ushuaia, creo que existieron otras escuelas. Colombina, ¿tienes un poco de conocimiento acerca de qué lugares del mundo pudimos conectarnos?
Exactamente, el programa Ship to Shore para las escuelas de la comuna de Chaitén contó con las 15 escuelas. 15 escuelas de 16, más la escuela de Ushuaia, y no solo queda aquí, sino que esto también es internacional, porque como les comentábamos, esta es una expedición, una investigación de carácter colaborativo e internacional, donde nos acompañan profesionales desde Nueva Zelanda, Inglaterra, Estados Unidos, Malta, Italia, Chile. Entonces, otras escuelas que hemos tenido y que de hecho el día de hoy también, el día de ayer, los días que se vienen, vamos a estar teniendo transmisiones en vivo en inglés, por supuesto. Va a ser la escuela de Nueva Zelanda, escuelas de Inglaterra, algunas escuelas de Malta, si no me equivoco. Así que esto no solo ha quedado aquí en Chile, sino que se ha ido para escuelas internacionales de todos los lugares, o sea, de todos los lugares del mundo, y más que todos los lugares desde donde provienen nuestros científicos y científicas que están aquí a bordo. Aquí estamos viendo cómo el Rob Sebastian entierra esta herramienta para la toma de testigos llamada Vibracor, que ingresa al sedimento a través de vibración. Uno de estos brazos robóticos controladores de Sebastian, nuestra estrella aquí en el crucero, sostiene este vibracor y lo entierra a través de vibración. Ahí observamos cómo lo está enterrando. Se ve cierta rugosidad en el fondo.
¿Cuál es la característica de todas estas transmisiones de Ship to Shore hacia los establecimientos tanto urbanos y rurales de la comuna de Chaitén? Es acercar la ciencia hacia las primeras edades. Es entendido que la ciencia viene siendo un nicho de trabajo metódico, donde si nosotros buscamos información en internet podemos encontrar a lo mejor paper o cierto tipo de material audiovisual que acompañe nuestros requerimientos científicos. La idea de todas estas transmisiones durante estos primeros 17 días fue contactar a las escuelas y de una u otra manera enseñar a los estudiantes todo este quehacer científico a bordo del buque Falcorchu, considerando los laboratorios existentes, tanto el trabajo acompañado del robot Sebastian con el trabajo de geofísicos, geólogos, biólogos marinos que realizan todo este estudio sincronizado, por decirlo de una u otra manera, en el que nos acompañamos constantemente haciendo trabajos paulatinos que dan muestras de un trabajo que va a tener a lo mejor una larga data. Considerar que este tipo de investigación va generando insumos para el trabajo en distintas universidades en el mundo para su análisis y posterior entrega de resultados. Estamos en la primera parte de esta misión científica que finaliza el día 23 de septiembre, cuando desembarcamos cercano a Talcahuano. Por lo tanto, iniciamos esta última semana de trabajo, semana 18era además, donde en Chile se celebran las fiestas patrias, estas fiestas que nos dicen que logramos ser un país independiente de una u otra manera. Dejamos ese yugo a lo mejor que nos conectaba en un momento con la corona española. Así que desearles a todos ustedes que a lo mejor nos observan, nos escuchan desde Chile, unas muy bonitas fiestas patrias. Nosotros también vamos a hacer un tiquitiquití desde acá, desde el Falcorchu, si es que nos permite un poco la marea o las olas que nos acompañan en este momento. Considerar que se inició este trabajo cercano al cañón Simpson con un breve adelanto, porque las condiciones el fin de semana creo que incrementan de velocidad del viento, por lo tanto va a ser un poco complejo hacer este tipo de trabajos dentro del buque. Hay que considerar que independiente a que la marea o la marejada esté fuerte, los científicos continúan haciendo sus labores dentro de cada uno de sus laboratorios, por lo tanto de repente es un poco complejo tener la estabilidad dentro de cada uno de sus laboratorios y tener el cuidado dentro de sus trabajos.
Entonces, siguiendo con las operaciones, ahora Matilde va...
This is 2 meters. we had very little recovery here. Well, a very little penetration, so recovery here maybe 15 centimeters, something like that. So after a while that we couldn't penetrate, maybe we hit a very dense sandy layers or something. Anyway, hard to core. We decided to retrieve it, and we're now doing a push core. And then after that, some sampling for biology purposes.
Entonces Matilde está explicando que acabamos de intentar un testigo por vibración que no alcanzó a penetrar mucho. Que vamos a hacer el otro tipo de un testigo como luego, que lo que hace es enterrar un tubo transparente en el fondo marino y se recupera esa muestra. Y luego de eso vamos a tratar de recuperar algunos organismos biológicos que están viendo en pantalla en la parte superior. En este momento esta es una de las operaciones más delicadas que trabajan los pilotos acá manejando los Sebastián, que es la manipulación del tubo una vez que ya contiene muestra adentro. Entonces lo que están haciendo es sacar el tubo y ponerlo de vuelta en su posición. Luego de eso, con los brazos mecánicos se va a tomar otro tubo sin utilizar y se va a poner en el sistema de vibración para prepararnos para el próximo sitio de muestreo.
Yes, so Rodrigo was saying that we are in the middle of a very delicate operation. You need to understand that we actually were in a very extreme environment here. 3,500 meters are more than 350 atmosphere of pressure. And to give you an example, your vacuum is maybe 3-4 atmospheres, so it's really a lot of pressure here. So everything must be done properly. But we have a great team.
You want to say that in Italian, Matilde, for your Italian community?
So for the Italians that are following us, per gli italiani che ci seguono, abbiamo fatto un tentativo con il Vibrocore per vedere se per vedere se riuscivamo a recuperare del sedimento, ma la penetrazione è stata all'inizio facile e dopo 10-15 centimetri abbiamo incontrato qualcosa di duro che l'ha impedita. Abbiamo vibrato per diversi minuti, siamo risaliti, siamo riscesi, ma non siamo riusciti ad andare sotto a questo strato che potrebbe essere della sabbia molto densa o qualcos'altro, e quindi proveremo in un altro sito. Nel frattempo faremo un push core e poi recupereremo un po' di biologia. C'è una stella marina, ci sono diverse cose sul seabed dopo al push core. Siamo a 3.500 metri di profondità, quindi la pressione è molto molto alta. Questo robot Sebastian è in grado di sopportare questa pressione, il cavo è in grado di sopportare questa pressione, i nostri tecnici sono in grado di manovrarlo e sta andando tutto bene ora. Semplicemente questo è un ambiente dove ci aspettiamo effettivamente anche della sabbia densa e che potrebbe impedire la penetrazione. D'altronde la sabbia è un elemento che noi vogliamo campionare, che vogliamo analizzare, solo che è sempre difficile perforarla perché ha delle proprietà meccaniche tali che si oppone alla trazione, si oppone alla argilla che è morbida e si fa manipolare, ecco. Sempre per gli italiani, ricordo che siamo nel Simpson Canyon, nord della Patagonia, la Patagonia cilena, e questo dovrebbe essere, noi pensiamo che sia un punto di uscita per i sedimenti che in un'ottica source to sink viaggiano dall'on-land, dal setting terrestre, sedimenti vulcanici, sedimenti anche di altro tipo, viaggiano dal vulcano nei bacini più vicini alla costa e poi escono in mare aperto, e essendo questo canyon un canyon molto profondo e molto scosceso, si passa da 200 metri a 3500 in qualche decina di chilometri di profondità, intendo. Pensiamo che questo potrebbe essere una via preferenziale per il sedimento e il loro accumulo, e quindi siamo venuti a cercare gli strati di materiale vulcanico, materiale che ci può aiutare a ricostruire il record delle eruzioni del Chaiten qua, solo che l'ambiente per l'appunto è piuttosto estremo. So now we are getting started with the pushcore. Cominciamo con il pushcore.
Now we're going to start trying a pushcore. The idea of the pushcore is to check out the quality of the sediments, what type of sediments we were able to penetrate, and because the pushcores, they use a transparent liner, you can actually see it, and we'll try to recover it. But if it doesn't work, just information of seeing what kind of sediment we get is useful for us for planning the next sampling. And then right after that, we're gonna use a suction mechanism to sample those nice gray and purple cucumbers you see on the screen. Entonces vamos a tratar ahora de sacar un testigo por empuje, que lo que nos interesa es saber el tipo de sedimento y la calidad de los sedimentos que tenemos ahí en el fondo, y luego de eso vamos a sacar unos que ahí colombianos puede ser el nombre correcto, yo los conozco como cucumbers, que ni sé, esos son como pepinos, ¿no? Colombianos. ¿Pero el nombre es pepino marino o qué?
Pepino de mar.
Pepino de mar. Entonces vamos a sacar un pepino de mar gris y un pepino de mar púrpura que se ve en la pantalla mediante succión, y estamos discutiendo qué método usar para sacar la estrella che se ve por ahí.
Allora, questa biologia sul fondale, che abbiamo chiamato cucumber prima, in grigio verdino, si chiamano pepino di mare, e li recupereremo dopo aver fatto questo pushcore che ora vedete manipolato dal braccio del Rob. Con il pushcore recupereremo i sedimenti più superficiali e ci faremo un'idea effettivamente di quanto è lo strato soft, e dopodiché con un meccanismo di suction, di suzione, faremo un campionamento sia di questi pepini di mare sia della stella marina che vedete più o meno in centro alla schermata, che anche di questa fauna più avanti in viola che non vediamo bene che cosa sia ancora, ma probabilmente mi interessa per i nostri biologi. Siamo ora cercando il sito esatto per il pushcore. So we are selecting the exact location for the pushcores to retrieve also this pepino de mar.
Pepino de mar o oloturio.
Oloturio. Gracias. This expedition is so good because there are people studying so many different disciplines, so you can actually around asking the most different questions. We have biologists, we have geologists. Well, Colombina and Danny told you that. We have geophysicists, volcanologists, oceanographers, plus the science technicians on board that are all specialists of ocean sciences. And here we go with the pushcore.
Crinoid! Is that a crinoid?
Something went out from the pushcore just in time.
Yeah. Oh, it's a crinoid. Oh, really?
There's excitement here. He's walking away.
There's another one still on.
Yeah.
They're just
That's favorite. That's Becky's favorite. Just for her birthday today.
Sea pigs and crinoids. I want to cry.
So we are actually going down.
Tipo de organismos que conviven con nosotros se llaman. Y esto es una operación sumamente delicada. Está operando los robots desde más de 30 metros arriba, ¿verdad? El mar, conectándose por fibra óptica. Dale conmigo.
The recovery was
Como
pretty
Rodrigo
good.
les comentaba, se cayó algo acerca de los holotúridos, que son conocidos comúnmente como pepinos de mar. Son clase de un filo llamado equinodermos, que incluye animales de cuerpo uniforme, alargado y blando, que viven en los fondos marinos de todo el mundo.
We want to try another push core.
On
The same,
the
yeah, because the liner of this one was not too thin. So we could suctionize the recovery that is working.
Do you want to collect more biology or is not
Yeah,
important?
it's same deal again.
Another fish for
Wow, this is way.
Another phenotype.
This is really great. Look at that sample structure.
another.
Yes.
Yes.
Yeah, that's the structure. So what is it?
I don't know. I don't know what that is.
What's that?
The thing that's in
It's
the
xenophile. Xenophile.
That's what it is.
So we have been told
I
that
can't spell
this biology that we collected with the push core, it's a
Xena, warrior princess?
xenophile spore. Xenophile spore. And we are going to collect another one with a second push core that we're gonna do here in the same way, because while the first one was very good, actually, we didn't expect that good after the vibrocore, that recovery after the vibrocore, but it looked like the liner was not clean, so completely clean, so maybe some contamination, something we want to avoid. So we're gonna do another one before the suction sampler.
And also because we also got such a nice sample. You've been following the feed. It's not always we get sample this nice. With seafloor creatures, the sediment look very fine grain. So we're gonna try another one the same way, similar location.
Okay.
We need to mention that the pilot did a great job.
Yeah. So we can give you all the scoops on the bushes. Xenophilophoria.
Bene, quindi il primo push core è stato un successo, il recupero è stato ottimo, ma ne faremo un secondo perché abbiamo avuto l'impressione che il liner fosse non perfettamente pulito, ci potrebbe essere un po' di contaminazione, quindi faremo un secondo push core qua. Siamo stupiti che sia andato così bene dopo al vibrocore, dopo la scarsa penetrazione del vibrocore, ma una volta aperti a bordo avremo un quadro più chiaro. Sì, se leggo if I read the comments properly, my Spanish is not so good. We are doing the suction for after the push core.
So we're going for trying to pick
Another.
which one would be nice to have.
And we're gonna use. So we now want to look for a specific location for the next push core. There is also
Okay, that's one. Yeah, I like this camera. But if we try too close to this guy, he might run away. I mean, oh, this is very nice.
Bring the rail in again.
Oh, what about now?
Thank you.
These are forests.
Like giant frogs. I mean the white thing.
Sí, sí, sí.
Ooh, look at the one on the left, but I don't think we're gonna get there, right? The one on the far
I'll
left.
have to move. I mean, I can try to bring the rail in, and it might be a little bit, maybe, but I don't know.
But the one in the middle looks very
Yeah.
They're complete. Yeah.
Get around to that as well, but we'll do that.
You want
Let's go for it. Yes,
Okay.
let's go for this one. Don't let's not move.
Reach
You
that
have the
far.
last one.
So, I don't know what- all right.
Can we? This is the maximum.
You need one with another finger like this.
Do you see the comment from Elogio?
Sí, sí, sí. Sí, vamos a
Mhm.
We already decided to
Mhm.
section for the cucumbers.
Before you grab it, hold back. Just want to just reach it. That's how I do it. Oh, that's just you want this? Yeah, just bring it over there. Let me bring this in some more. Just to give you as much melody as possible.
Dani, no sé si les gustaría explicar un poco
Yeah.
los organismos que estamos viendo ahí para los niños, qué tipos son y qué interés pueden tener las muestras de estos organismos para estudios.
Y muchos organismos marinos están en el lugar en el que están por alguna razón. Y muchos de estos organismos nosotros les llamamos bioindicadores. ¿Qué significa esto? Que biológicamente indican características del lugar en el que se encuentran, ¿no es cierto? Y nos van a dar una respuesta del estado de salud que tiene el ecosistema marino en el que nos encontramos. En el suelo marino en este momento podemos ver la presencia de un equinodermo. Uy, que se nos está cruzando
We have a
un
guest.
pez.
Oh, it's very nice. He likes the
Chocó,
push.
está
The push
luchando contra el
course.
push core. Y también estábamos viendo hace un rato en pantalla a un grupo un organismo de un grupo llamado xenofióforos, un grupo de protistas unicelulares gigantes que están presentes en un gran número de fondos abisales a mucha profundidad, como la que nos encontramos en este momento, a 3.407 metros de profundidad.
So we are going now with the second push core.
Dentro de las preguntas que nos hacían hoy los estudiantes de la escuela de Will, nos preguntaban cuáles habrían sido los mayores descubrimientos encontrados hasta el momento, y la verdad es que el día de hoy para nosotros es particularmente emocionante porque estamos viendo la superficie, un lecho marino, un cañón del cual no teníamos mayor material, no sabíamos con quién nos íbamos a encontrar. y yo creo que las características de este cañón van a salir a flote recién cuando hayan finalizado las transmisiones. Los tipos de organismos que se encuentren acá van a ser analizados hoy por el grupo de biólogos y todos los restos de sedimentos que se logren extraer van a ser parte de ese trabajo.
En pantalla seguimos viendo más organismos y qué lindo se escucha, ¿no es cierto?, todos los idiomas presentes, italiano, español, inglés, que forman parte de este equipo científico, porque recordemos que el futuro de la ciencia es colaborativo. Colaborativo, es muy importante realizar colaboraciones. Porque si queremos generar cambios, si queremos realizar cosas en comunidad, tiene que ser colaborativo.
Es increíble observar este fondo marino. Cualquiera podría pensar que nos encontraríamos con a lo mejor algún tipo de bosque de algún tipo de organismo, no sé, algas. Muchos estudiantes imaginan que el fondo marino está completamente poblado de especies, que vamos a encontrar una diversidad de colores, y la verdad es que tan diferente a todo lo que se piensa. Considerar que estamos a 3.407 metros de profundidad, donde la radiación solar no llega. Por lo tanto, veíamos ahora un tipo de pez que estaba ahí luchando contra los dispositivos instalados en el robot, y era albino. ¿Qué características crees tú, Colombina, que manifiestan este tipo de organismos? ¿Tú crees que alejados de a lo mejor de la luminosidad tienen colores más oscuros? Conversábamos hace un poco de tiempo sobre eso. Ok, Colombina tiene otras misiones ahora. Nos comentaba que a mayor profundidad menos coloración en las especies. Están nuevamente extrayendo este foraminífero, según nos comentaba Becky, muy emocionada aquí acerca de este hallazgo. Parte del equipo de investigación de Becky es la paleontología submarina, puede decirse de una forma, donde los foraminíferos nos muestran información acerca de cómo está la composición de sus caparazones. Nos dan impresión de cómo en el pasado el ambiente jugó una materia de importancia en la composición de sus características en sus caparazones. Viene este segundo vibracor, Colombina, ¿no?
Viene un pushcore, y como ven en pantalla hay varios pepinos de mar en el suelo marino que producen bioperturbación, nos comentaba Rodrigo Fernández, y producen dificultad al poder sacar estos pushcore que se ingresan en el sedimento. Ahí vemos cómo el pushcore fue extraído del fondo y están procediendo a colocarlo en este envase que lo trae a la superficie.
Este cañón submarino es de vital importancia para toda esta investigación que se ha estado realizando durante esta misión científica, porque según lo que cree nuestro grupo de científicos, es en este cañón submarino donde se depositan todos los sedimentos que vienen y son traídos por las corrientes marinas que ingresan tanto por la boca del Guafo y por el canal de Chacao hacia el mar interior de Chiloé, y que con combinación a masas de agua dulce traída por los ríos, más los sedimentos traídos por los ríos, van a lograr conformar un paisaje submarino diferente, considerando todo lo que significa las corrientes y la influencia de esta corriente de Cabo de Hornos que ingresa por la boca del Guafo y por el canal de Chacao. Se realiza todo este barrido. Lo que se quiere comprobar con esta investigación es cómo los restos de sedimentos incorporados por años, por decenios, por milenios, se ha ido depositando en esta fosa submarina, perdón, en este cañón submarino de 3.400 metros. Eso, la celebración del segundo push core. Cómo todo este sedimento se ha ido incorporando a este lecho y lograr comprobar la cantidad. Se habla no de metros, sino de aproximadamente a lo mejor 1 kilómetro de sedimento, considerando que nos encontramos cercanos a lo que es las placas, donde se juntan las placas. Toda la conversación del grupo científico tratando de incorporar estas muestras al push core. Es el segundo foraminífero, creo que fue capturado para análisis del grupo científico. Ahora van al tercer push core colombinés.
Exactamente, vamos a proceder a sacar el tercer push core. Se sacan 6 en general, según qué tan completos se extraigan.
Hay una estrellita ahí que está en discusión. ¿Cómo se extrae? La idea es no dañar estas muestras porque son de especial importancia tanto para el equipo de biólogos como para el resto de profesionales que está dentro del buque. Considerar que cada una de las muestras son guardadas cuidadosamente para su estudio posterior. Todo esto va a ser son tesis, memorias de estudiantes de pregrado, magíster a lo mejor y doctorados. Por lo tanto, es de vital importancia hacer una extracción limpia de estos residuos del fondo marino, tanto como los habitantes que están en este sector.
Thank you, Dani. We are now going for the suction sampler. Getting a bit closer to our
Ahora nos
target.
cambiamos de zona de muestreo, un poquito más al lado del lugar donde estábamos, donde veíamos estos animales para los niños y niñas que nos están viendo, que forman parte de los equinodermos, que es un filo de invertebrados exclusivamente marinos, que habitan en la zona bentónica de todos los océanos. La zona bentónica, el bentos, es el suelo marino.
Un método de muestreo que es la primera vez que intentamos en el crucero, que es por succión. Estas son las primeras muestras que sacamos por succión y la idea es recuperar estos organismos completos. Y nuestro objetivo es lo que comentábamos anteriormente, que son esas 2 criaturas que parecen como pepino, uno gris, uno púrpura, y por ahí vamos a ver qué más podemos atrapar.
Yeah, so this is the first time we try the suction sampler on board. Yeah, now we are in the middle of a biogenic tempest. Let's see what it is. Cool.
So another thing that I can comment, so we did survey the Simpson Canyon in 2019 using the Chilean research vessel AGS Cabo de Hornos. And with the vessel, we did a mapping of the canyon and all the areas surrounding the canyon, the slope, where we found several evidence of faults recently active. And also at the very end of the canyon, in this area, we found something that looked like sound waves, like mega scale sound waves. So this would be like a pattern, a radial pattern of waves coming away from the mouth of the canyon. So after we're done with this, we're gonna try to lift up and browse around to see if we see any geomorphology that would indicate that, you know, the nature of these sound waves. En español, este es el cañón submarino Simpson y las áreas de dañas las mapeamos el año 2018 en el buque científico chileno AGS Cabo de Hornos. Y ahí hicimos el mapa batimétrico del cañón y las áreas aledañas, donde vimos evidencia de fallas que aparentemente están todavía activas. Y en la parte baja, en la salida del cañón, en este abanico donde nos encontramos ahora, abanico submarino de cañón, de pie de cañón, ese es el nombre, vimos unas cosas que parecen como unas ondas con patrón radial que van, ¿cierto?, saliendo de la salida del cañón y van moviéndose en todas las direcciones. Entonces en este momento estamos arriba de una de estas ondas y la idea después de acá es, vamos a levantar el rope y vamos a mirar alrededor a ver si logramos reconocer estas formas. Porque, ¿cuál es la dificultad? Cuando trabajamos de la superficie, como es tan profundo, tenemos bien poca resolución espacial, tanto en la vertical como en la horizontal. Entonces nos serviría tener una idea de si esto que vimos nosotros y que procesamos, interpretamos, es real o no. Vamos a ver si nos resulta. So, can you guys tell us more about the creatures we want to sample? You just said like a sea pig, and the other one was a cucumber, sea cucumber. So they're two different organisms, right?
Three. Los tres organismos. We'll try to say this in Spanish. Rodrigo messed up the arm here. He's like a big brother who's always messing things up over here. Come on, Rodrigo. Okay. Gianluca and I are gonna have to reach here to explain. There's some really cool critters that we're trying to sample here. The first that you can see, let's see, can we get a view of the suction arm from above? Can we make that the main screen? Can we make this the main screen? Make it big. I want to show everybody what we're doing. Okay, so we've got a suction arm there. You can see now it's big. That orange tip has a hose on it, and we're going to try to suction this organism on the seabed. This is what I was calling the pepino di mare or pepino del mar. This is a sea pig. And Gianluca Federle, from Universidad de Valparaiso, I asked him, does he want to take a bet on this? $10. Does it bioluminesce?
Yeah.
Yeah?
Let's do it.
Let's do it. $10. How many thousand pesos is that?
Like 9.
Like 9,000 pesos. Okay, we're gonna see whether it bioluminesces. And the other thing that we've seen here is there's a brittle star, which you can see to the right of the robotic arm, just above that orange hose on your screen. And then the other thing we're hoping to sample are these purple sea cucumbers. I know I'm from Louisiana. I really am curious what they taste like, but I promise I won't eat them. Gianluca, would you like to explain that in Espanol? What we're doing here, what we're trying to sample.
Let me try to fix this. So I think I went the other way.
Rodrigo broke first.
There you go. That's
Oh,
for
okay.
that.
Yay, good job.
Buenas tardes a todos. Me presento, mi nombre es Gianluca Fedele. Como ya me presentó Becky, soy estudiante de quinto año de la Universidad de Valparaíso, actualmente realizando mi tesis de pregrado. Y bueno, lo que están viendo acá, estamos tratando de usar la succión, ya que véanlo como una aspiradora que contiene el robot para poder succionar estos organismos sin sin dañarlos. Ahí va, ahí se fue. Y esto luego van quedando almacenados en ciertos como receptáculos, por decirlo de alguna manera, en donde yo después puedo tomar esas muestras con mi compañero y empezar a analizarlas, hacerle la taxonomía, hacerle todo lo necesario para saber y ojalá llegar al nivel taxonómico más bajo, al nivel de especie. Entonces ahora vamos a tratar de obtener también este ofiuro, que es una especie de estrella bastante más frágil, que viene a la derecha del brazo del robot. Son muy frágiles, se mueven más rápido, eso sí, que una estrella común y corriente, son bastante carnívoros, así que eso. Para explicar un poco el trabajo que hacemos nosotros con mi compañero, nosotros estamos estudiando la macrofauna bentónica, los invertebrados bentónicos, que son todos los organismos que viven por sobre el fondo del mar, o también la infauna, que son todos los animales que viven por debajo del fondo del mar hasta los primeros 20 centímetros de las capas del sustrato. Entonces nosotros tomamos muestras de sedimento o también, como lo hicimos ahora, y la pasamos a 3 tamices de 1 milímetro, 500 micras y 300 micras, en donde vamos separando los organismos del sedimento. Luego, para el sedimento sobrante, llevarlo a una observación bajo lupa electrónica para poder comenzar a separar los organismos ya más pequeños que no se pueden ver a simple vista para los humanos. Entonces ahora lo que vamos a tratar de sacar es un pepino de mar. Así que para que estén atentos a las pantallas.
Gracias. I think Rodrigo broke this. It didn't light up. It didn't bioluminesce in the tube. You want to talk? Oh, but we have to wait. Okay, so the bet was, is it going to bioluminesce? It didn't bioluminesce in the tube. We have a little camera of the tube. But once we bring it to the surface, we might see better whether it bioluminesces. Ooh, thank you for turning off the light. Can we put that on the screen? So wait, no, never mind. We're missing the view on your screen, but we'll show you in a little bit. Maybe that sea pig will acclimate and decide to show off for us. I think it's mainly mating strategy. That's why they bioluminesce. They can see each other.
Can I say hi?
Yeah, please. Gianluca, go ahead.
Quería mandar un saludo a todos los que me están viendo, especialmente a la Mai, que está enfermita y en cama, así que se mejore pronto y que siga viendo el en vivo. Y un saludo para mi pampanita.
¿Qué hay? No, we're gonna lift up and browse. To the 295. That's what we're gonna be right. I'm gonna go.
295, about 100 meters. How many meters is that?
They usually do like 50 and then see if
And then
it's
see if it's good, and then
go
we can
another 50 something.
put another waypoint in.
It's more or less. I'm
Is
not
it
gonna-
bioluminescing?
No.
Uh-oh, I might owe you money.
Yeah.
Okay, and now do you want to explain? Right now we are sucking up, or attempting to suck up a sea cucumber. En español. Yeah, Diego Droguet is a... How do I pronounce? Say it one more time. Droguet. I said it right. Gianluca always gives me a hard time, but I'm really trying hard to improve my Spanish. Okay, let's see if it fits. Diego, will you please explain what we're doing here en español?
Gracias, Becky. Bueno, hola a todos, me llamo Diego Droguet y ahora les explicaré un poco lo que estamos haciendo. Estamos usando este succionador, como dijo mi compañero Gianluca recientemente, que hace la función de una aspiradora para poder extraer ciertos organismos sin dañar sus tejidos y tenerlo de vuelta acá a la superficie lo más conservado posible. Entonces recién extrajimos con éxito un pepino de mar, uno blanquito, uno transparente. Y ahora estamos intentando sacar otro, si no me equivoco, creo que ahora salió. Ahora están momentos críticos. Oh, bien. Y se pudo extraer ahora el segundo pepino de mar, que era uno bien grande y complicado. De hecho, lo vimos al principio cuando recién estábamos llegando al fondo y empezaba a moverse de una forma extraña. No estábamos seguros si era un pepino u otra cosa. Pero ahora tuvimos suerte porque funcionó el succionador. Intentamos en otras inmersiones anteriores utilizarlo, pero no funcionó. Y ahora por suerte, que cuando más lo necesitamos, está funcionando, saliendo todo correctamente. Y luego intentaremos extraer un ofiuro que anda por ahí, que... Ah, ahí se ve un poco. Ahí hay un ofiuro y vamos a intentar extraerlo. Y bueno, todo esto al final es para poder lograr hacerle un análisis más detallado acá en el laboratorio y con suerte podremos llegar al nivel taxonómico más específico posible. Esto quiere decir quizás llegar a tipo de especie o género o familia, como sea a nosotros nos sirve. Y bueno, esto es lo que quería explicar. Y aparte después usaremos esos sacos que se ven, que se llaman scoop bags, que se utilizan para sacar sedimento del fondo. Entonces ya después en la superficie acá en el laboratorio, en el buque, vamos a analizar los residuos que quedarán de este sedimento para poder verlo en la lupa y ver los organismos que no se pueden ver a simple vista. Bueno, quiero aprovechar la oportunidad también para mandar saludos a mi familia, que sé que me están viendo allá en mi casa, en Quillota, y a mis amigos también que me están mirando en alguna parte por allá en la quinta región. Todo tuyo aquí.
Bravo. Thank you, Diego, for explaining some of the cool organisms here. Give a shout out to his family. Diego is a student at Universidad de Valparaiso with Dr. Eulogio Soto, who I think is joining remotely. He's not on the ship, but very much a part of this expedition. And little known fact, Diego's really good at playing guitar. La guitarra.
Both fingers.
With all your fingers?
What did you say?
Oh, I told him the other day that he has fingers of gold. Dedos de oro. Yeah, very, very good.
Oh, what's up?
Matilda, do you want to tell us what we're doing operationally next?
Yeah, we are looking for the star.
Yeah.
For
I'm here.
yeah, but the second one. The first one is Rodrigo, and we're looking for the white one.
The white one?
The white one.
I like the pink one personally, but
No. But we moved a bit before, so we're
If
looking
there is a
for
black
it
one,
and-
I want that one.
Yeah,
I want the black one.
The visibility
There must be a black
parts.
one.
But we're gonna find it.
yes. But I don't think that we'll get the same one that we saw earlier.
So Rodrigo, you think these could be like turbidites but not consolidated?
Yeah. So due to the slope, we have the excess of the canyon. Most likely, most of these deposits are transported by turbid currents. So this would be turbidite deposits, but not consolidated. So if you remember in the push core, we had like a layer of sandy material on top of that, like a finer material, mostly clays, and alternating, right? And that's usually what in this type of environment would represent the deposit of a turbulent flow coming down the canyon, loaded with sediments. So it would be high density turbid flow and being deposited in there.
So yeah, these flows can be quite fast and quite violent, right?
Right. They're usually fast because they're turbulent. They might produce basal erosion on the seafloor. So sometimes the next flow will erode the upper part of the previous flow, and then you can imagine like a huge plumes of sediment, sort of dense with different materials in it. So as it loses kinetic energy, the coarser grains start depositing in a specific fashion. The whole plume is losing speed or kinetic energy. You get all the fine material raining down on top of the previous deposition. So you get like a nice coarse to fine stratigraphic
Deposition,
facies.
yeah.
Yes.
Like for wind particles on land.
Right. With the difference that on land the wind is really good selecting or separating materials by grain size, or we should say in reality grain size / density. That's what's really conducting everything. So in this case, everything goes mixed up in a turbulent flow. So it's like I don't know what it's like. I'm trying to come up with an example from daily life, but this is so.
It's
alien.
mixed up, yeah.
Yeah. But basically, you have different grain sizes, different densities coming down the slope very fast, and plumes that can be several hundred meters in height, other hundreds of meters in width. Many times these are so large that can overflow the canyon and have depositions on the side to form something called canyon levees. What's the name? Overbanks. And then those are really nice locations for coring. It's mostly fine material. low accumulation rates. So you get with the same core, you see longer time scales. But in this case, we're in a different position. We're right out of the mouth of the canyon, so we get the whole thing flowing to us.
Yeah.
To our location, I would say. I was thinking to us because before we said that, what happens if we get a mega earthquake right at the moment? So I got immediately thinking, what happens if we get like a turbidity flow right now? That would be cool.
Maybe Sebastian would have been that happy though.
Yeah, poor Sebastian. Yeah,
Poor
we don't like
Sebastian.
to
It's
put
actually a
Sebastian.
cool video in Bari. They said they had a ROV that was there when a turbidity flow came down a submarine canyon, was in the canyon. It's really, really cool.
Yeah,
And then
yeah.
you could see them flying up out of the, the turbidity current. It's really quite fast. It happens in a matter of minutes.
Oh, that's cool.
These
Do you know
turbidity
which
currents. But they
canyon
can
was
go. It was off the coast of California.
Maybe the one in Monterey Bay.
Monterey Bay, I'm pretty sure.
No.
I'm pretty sure it was Monterey, the submarine canyon associated with that. But these turbidity currents can go several kilometers out into the ocean, into the deep of the ocean, because they're just driven by gravity. So it's a denser flow because it's a mixture of sediment and water flowing along the bottom. They can go really, really, really far.
And they will find the best path to do it.
Actually, in this area, if we trust the geomorphology, the reach of the flows will be at least between 15 and 20 miles. So that's pretty significant.
Yeah, crazy.
There, the one right in front of us.
Want to get that,
You want?
sister? Diego?
Yeah. What?
That one right there?
I barely see.
On the screen, you can see it's right there.
En español, estamos discutiendo el origen de los sedimentos que estamos observando. Si ustedes han seguido en el push core o en el testigo por empuje que sacamos anteriormente, se veían unas capas de arena intercaladas con capas finas de arcilla. Y si ven ahora la pantalla, verán de que todo lo que estamos removiendo son una mezcla entre arcillas y material biogénico. Y en algunas partes, en el fondo, se ve que todavía quedan unas arenas un poco oscuras. Entonces, el modelo para explicar esto es que estos fueron depósitos que se produjeron por flujos densos de agua cargado con sedimentos que son conducidos por los cañones submarinos. A veces son tan, digamos, gruesos porque pueden tener cientos de metros de altura. Entonces logran pasar las paredes de los cañones y depositan un banco de sedimento en los lados. En este caso nosotros estamos ubicados a la salida, directamente a la salida del cañón, por lo tanto esperamos encontrar todos los elementos que conforman este flujo, es decir, las partículas gruesas y más finas que son arrastradas por estos flujos. Una vez que estas partículas finas y gruesas van revueltas viajando, ¿cierto?, por el fondo marino en algo que es bien violento, digamos violento en el sentido que va muy rápido. Imagínense una nube gigante, densa, que va bajando por el fondo marino, y si nosotros miramos la morfología del fondo podemos estimar que aproximadamente pueden alcanzar algo así como cerca de 30 kilómetros desde el punto de salida del cañón hacia estas partes profundas, lo que significa que tenía tanta energía cinética, ¿verdad? Venían tan rápido, tan cargados, que logran llegar muy lejos desde la salida del cañón. Entonces ahora estamos, tomando muestras de esto y vamos a intentar tomar muestras de otro sitio a ver si encontramos evidencia de estos flujos que se llaman flujos turbulentos, tratando de traducir, se llama turbiditas, es el depósito, y el flujo sería flujos turbios, creo que sería la traducción en español.
Yeah, I think they can go in the same.
Yeah, I just moved it off of that one so I didn't have to keep sucking on. So.
Yeah.
All right, I'll put it back down.
Suction, we're sucked in the.
Chris identified it.
Nice. You want to comment on that?
The star.
All right, so yeah.
Okay, I don't know too much about worms, except that they're cool. But our ROV pilot the pilot in command right now. Chris just identified this critter that's really close to the arm. Sophia, can we change the view so that they can see the worm? Sophia? Just gonna work on making sure you guys can see it. But it's kind of bluish gray.
Yes.
Oh, we can't. All right, we're trying to get everything at once. You can't see the worm on your screen, but it's called an acorn worm. It's kind of bluish gray. Maybe. We're not sure. Chris is making sure we know that that is just a guess at the ID. We'd have to bring it on board and look at it more closely. Oh, there we go. Now we can see it. Thank you so much, Sophia. Everybody's multitasking, and there's a lot of people in the room right now because this is a highly anticipated site. The worm that we're trying to suck up, we believe might be an acorn worm. And they can live in really, really deep water, like where we are now. They can be over a foot long sometimes. So, wow. Hemichordates. Let's see. So they're related to chordates, which are animals with backbones like us. Do we get it? Did we suck it up? I couldn't see. Do we get it?
Hold on, give me a second.
All right. I believe that Joelle
There it
is.
is.
Oh, wow.
Another.
Can you show us a view, Sophia, of the tank that we just put it in? Oh, it's moving around a lot. We have a view of the tank that it's in, so we can see when it plops into the tank, and it was moving all around. It's pretty cool. Wow. That was really fast. There's a view of the tank. Thank you, Sophia. Now it's not moving anymore. Maybe it'll get agitated and move again for us later. We're still checking to see if the sea pig bioluminesces. I want my $10 though.
I suggest you do a double or nothing.
Okay, double or nothing, John. We're so I can be farther out here. All right, Matilda, what are we doing now?
We want
didn't hear the planner.
We want the star, right? As the last target for this section. The worm got the priority. And now we go back to the star. Easy target in front of us.
Maybe we'll get something with it. The Xenophyphorian.
Another one.
We have.
With these, we would have 3.
We'd have 3 because we had 2 in the push cores.
One for each push core, yeah.
Whoa. Whoa.
There you go. No, that's like he's fighting for the back.
Let's see. We're going to watch to see if it goes into the tank here. He's fighting it.
Awesome. But he might not come through with the wait and see. We'll see.
Wait, why is it a he?
Good job.
Thank you. Little inset on your screen. Little inset on your screen. We're watching for the sea star, the little brittle star to come through. Ah, there it is.
Number 2?
That's in, yeah, tank number 2.
Yeah. Now I'm gonna move it to 3 just so I don't have to keep suction out on the entire.
Yeah.
Okay.
It was pretty full.
So 1 and 2, 2 creatures and 2 animals in each one.
Yeah.
Mm-hmm.
You got that? What is in 1 and 2? Okay. Was it John, do you have sea big worm in one? Or is it the other way around?
I'm pretty sure the
Is with the sea big.
He was very long. There's not here, I'm aware of. So. Do you have a unit? As long as I can move the vessel, no?
Are you guys happy now?
No.
Thing is, there's something that looks
You need mud.
promising maybe,
Mm.
but it's a mile.
We already have
to the
4
west.
inches.
What did you see in the
But we can
Volcanic?
try something closer, maybe move the whole thing.
I mean, I'm
I
just.
see. So let's well, but we want to have a look from the top a bit.
Yes.
Oh.
We move about, because we like to browse around, see why,
Mm.
if there's any indication, explain why we want to penetrate
I'm sure you don't have class.
farther enough.
You have class at 1?
Half an hour or something, and then,
Yeah, but can we not communicate with you?
oh, so this is like kind of fish eye, so it's kind of right.
Yeah, this is why you
That side,
saw.
okay, so that's not.
Nobody else in here can log.
I mean, they can. Ali knows that.
Allie,
I think we
can you
might
log?
want to just move about
Can you not
100
at that
meters.
log for
See
the
what happens.
geology?
Maybe we'll try again.
Midnight, so
If it doesn't work, we just move a mile
Yeah.
with the whole vessel.
Colo, are you okay?
Then I'm trying to calculate the best position.
So we are now evaluating the next sample location for the vibrocore and all the rest. We will have a look around us in a radius of 100 meters, and if we are not happy with it,
295.
290, 295 of azimuth. And
Like we can do this. We'll try.
if we are not happy with what we have around, we will move the whole ship with the ROV in the water for maybe a mile to reach a target that we already identified from our mapping.
Alright, so we will go.
So 100, we can try something like 100 meters in the 290 azimuth direction.
How much time do you think till we get to the next site?
100 meters, not very long.
Not very long.
Good, already have new waypoint way. A new waypoint for you? Point 2 is fine.
We do now have a little bit of a view from the top. We are moving of by about 100 meters. I see.
Flying 100 meters.
Quienes nos acompañan en esta maniobra, queridos y queridas de la Universidad Austral de Chile, aprovechar de mandarles un cariñoso saludo a la familia Valdés también, que se encuentra desde La Hermida viéndonos precordillera de Santiago. Acompáñenos en esta maniobra que vamos a realizar.
Ahora, ¿cuáles son estos residuos que se logra encontrar o se logra apreciar en este cañón Simpson? Guarda muchos vestigios de cómo se formó el archipiélago de Chiloé y todos los archipiélagos, canales, islas, fiordos, etcétera, hacia el sur, que se formaron al momento del retiro del hielo de la última glaciación, aproximadamente hace 14.000 años atrás, cuando el mar invadió los terrenos, los valles, las cuencas y los depósitos glaciares asociados al hielo, los que habían sido previamente labrados por el hielo de esta glaciación y de anteriores glaciaciones a su vez. Así es como el mar invadió los depósitos glaciares del Cuaternario. Podemos mencionar sectores del norte de Ancud, como Polokwe, Mar Brava, Pumillahue, Duatao, donde hoy en día existen vestigios de rocas volcánicas y sedimentarias del Mioceno inferior, junto a la península de la Cuy y del Piuchen, donde existen rocas metamórficas del Paleozoico y del Triásico, de la cordillera a la costa. Todos estos vestigios que hoy tratamos de vincular este trabajo de investigación tienen relación con esta última glaciación. El último periodo glaciar o glaciación llamado Wisconsin en América, conocido como la Edad de Hielo, es la última de las 4 glaciaciones del Pleistoceno o del Cuaternario, según una clasificación realizada en 1909, que comenzó hace 110.000 años y finalizó hacia 10.000 años antes de Cristo, dando paso al Holoceno, el periodo postglaciar en el que nos encontramos en la actualidad. Por lo tanto, todos estos sedimentos que se van a lograr recuperar en esta misión científica del Falcochú van a dar, primero, evidencia de lo que es el fondo marino, tanto del archipiélago de Chiloé, el mar interior de Chiloé, como en este momento un mapeo constante de... Ok, vamos llegando al sitio del segundo muestreo del primer sitio, según nos informa Rodrigo. Segundo sitio de muestreo del primer sitio seleccionado. De ahí, según nos menciona uno de los líderes científicos, nos movilizaremos 1,5 millas hacia el este de la isla Guafo, donde actualmente estamos ubicados, sobre el cañón Simpson, recordar a ustedes, y va a ser el segundo lugar donde se van a realizar muestreos, tanto de pushcore, vibracore. En fondo se ven muchos estrellas marinas, perdón, o fiuro, según aquí nos dice nuestra bióloga marina Colombina. Colombina, si nos puedes contar un poco de los seres que se van apreciando en este momento.
Por supuesto, Dani. Para los niños y niñas que nos están viendo, los ofiuros o ofiurideos son una clase de un filo llamado equinodermos. Estos tienen un aspecto muy parecido a las estrellas de mar, con las que están estrechamente relacionados. Tienen 5 brazos que salen de un disco central. Y este taxón, digamos, está incluido dentro de la superclase Asterozoa.
Ok, nos encontramos entonces en la sala de control del Rob Sebastian. Contarles un poco que en este preciso momento nos encontramos junto a todos los pilotos que están haciendo las maniobras. Acaba de estacionarse el Rob después de su desplazamiento aproximadamente 150 metros hacia el oeste de Isla Guafo. Tenemos científicos en este momento de Nueva Zelanda dentro de la sala Rob. Nuestro líder Sebastian Watt, que se encuentra en la parte posterior de todo el monitoreo. Tenemos a Matilda, que nos acompaña desde Italia. Tenemos a Becky de la Universidad de Alabama y Rodrigo, Universidad de Chile, los 4 líderes de esta misión. Los estudiantes de Biología Marina de la Universidad de Valparaíso, Colombina Valdés, divulgadora y bióloga marina de la Universidad Austral. Tenemos a Anka, que viene desde Nueva Zelanda. Tenemos también a Marianne, que está haciendo en este momento el logueo de todo, la descripción científica de todo lo que significa estas 11 horas de inmersión del robot Sebastian. Va a ser el día más intenso de este trabajo científico, considerando que la inmersión de Sebastian demoró aproximadamente 3 horas, si me corriges Colombina, 3 horas, 3 horas y media, 4 horas aproximadamente. Hay que considerar que la maniobrabilidad del robot a más profundidad se complica, por lo tanto es necesario tener la máxima coordinación, el máximo estado de concentración. Considerar que esta es una sala de piloteo, que existen múltiples cámaras que están enfocando a diferentes focos y se encuentran micrófonos disponibles en cada sector de investigación, de trabajo constante. Por lo tanto, las labores de divulgación que se hacen con cada micrófono deben ser acotadas y manteniendo siempre un rango de voz limitado para no interceder a lo mejor en las maniobras de coordinación de los pilotos.
Nos encontramos nuevamente visualizando el fondo con el objetivo de extraer a través del método de succión algunos tipos de animales. La idea de este método es no dañar los tejidos, como dijeron anteriormente, de los animales, para que después no tengamos que extraer más, que sea solo una extracción.
Voy a explicar en español más o menos el plan. Voy a ir a comer algo porque me muerto de hambre. I'm going to explain now in Spanish the next steps we're going to follow. Entonces hemos estado mostrando este lugar y la idea que tenemos es hacer una suerte de transecta con el robot. Entonces tomamos el primer punto, nos movimos 100 metros en la dirección cercana al oeste. Vamos acá a sacar otra muestra de la misma manera que lo hicimos en el primer punto. Y luego viene una operación bastante complicada porque nos vamos a desplazar alrededor de 1 milla, eso es más o menos 1500 metros, en la misma dirección. De hecho, la dirección es 295. Ahí alguien les va a explicar, que no sea yo, qué significa eso. Pero es más o menos, si uno empieza a contar los grados, haciendo que el norte es 0, y empieza a contar grados hacia la derecha, con una manilla de reloj, se da toda la vuelta, 180 sur, 270 oeste y 295, entonces sería 15 grados más hacia el norte de la dirección oeste. Entonces vamos a parar 1 milla después de ese último punto y vamos a hacer esta misma operación de bajar, tomar muestra, ver lo que hay, ver si nos va bien, y quizás vamos luego a levantar y movernos otra milla. El motivo de esto es porque tenemos algunos datos previos y hay una muestra que sacó antes en una expedición que está siendo analizada por las universidades de Andrés Bello y de Chile, y la idea es combinar estos datos, si es posible, de manera que un dato complemente al otro. Entonces de esta manera vamos a tener al menos 4 sitios de muestreo en este sector, todos en lugares donde tenemos exploración de tipo sísmica, en donde hemos hecho líneas de adquisición de datos en direcciones oblicuas una respecto a la otra. Así que eso es lo que se viene para los que quieran estar atentos.
Example here to arrive 90 azimuth degree direction from the first site. We are on the second site. And after that, we're gonna move 1 mile in the same direction and possibly another mile for a fourth site. And this site has been chosen for crossing, for lying on some seismic lines, so bottom profile lines that were acquired in a previous expedition. And we'll see what we get. Let's go for the second site now for a vibrocore. Sure, I think we're gonna look at this. Yes. So we are now starting with the vibrocore. Cominciamo con il vibrocore. Come vedete, questo ROV ha un braccio meccanico che è in grado di fare diverse operazioni in maniera piuttosto fluida, considerato anche le profondità, la pressione. I nostri piloti sono esperti. Il materiale di cui è fatto il vibrocore, anche le plastiche, sono speciali per operare in ambienti particolarmente salini, particolarmente profondi. Il metallo di cui sono fatti questi core è piuttosto spesso, è duro da tagliare. Abbiamo uno strumento simile a una sega circolare per poi aprire la carota, diciamo, la possiamo chiamare carota, a bordo. E ora siamo quasi pronti. Okay, so we are in place with the vibrocore. Yeah. Wait a second. Ready? Yes.
You want us to vibrate and go out, or to see the building out? You want vibrate to go out, or to see the building out?
No, let's test first. Okay. Okay. Mm-hmm.
So it definitely hits hard. It's not done any further.
Do you have any idea of the depth?
That would have been. So what happened was we went down and it stopped. We moved a little further and started to make the way up the water. Stop there and bring it back up.
And then it was already, yeah.
So we didn't go down anymore, so we tried again.
Yeah. Yeah. So from a first test on the vibrocore penetration and on the resistance of the seabed and the sediments just below it, it seems that there is something relatively soft in the first 50, 60, maybe 70 centimeters, and then something definitely harder. So we'll do another test now, and then we'll start vibrating. Vibrating now.
Lo que podemos ver en este momento es la utilización de la herramienta Vibracore, el cual es una herramienta incorporada en el robot Subasten. Para contarles un poco qué es el Vibracore, este funciona vibrando en el fondo marino a una frecuencia alta y una amplitud baja, moviendo los sedimentos hacia el núcleo en un estado prístino mediante la licuefacción de los sedimentos a su alrededor. Las capas finas se conservan en el núcleo, capturando momentos de tiempo geológicos como terremotos, inundaciones y erupciones. Los Vibracores son especialmente eficaces para estudiar eventos a pequeña escala en el registro geológico. Muchos otros métodos de extracción de núcleos, como los núcleos de empuje y de gravedad, comprimen el sedimento, alterando las capas finas dentro de la muestra. En este caso, el Vibracore también tiene menos probabilidades de fallar que otros métodos de extracción de núcleos, que ocasionalmente expulsan muestras o no pueden penetrar sedimentos más compactos y duros, extraídos desde la fuente Schmidt Ocean Institute. Para hacer un poco de historia dentro de todo este proceso investigativo en el que nos encontramos inmersos, de este equipo FIRE, de esta misión Fire and Ice. El 2 de mayo del 2008, el volcán Chaitén en el sur de Chile entró en erupción sin previo aviso, arrojando cenizas a más de 30 kilómetros de altura. Estas cenizas cubrieron el paisaje y las fuertes lluvias de los días siguieron provocando devastadores flujos de lodo volcánico que descendieron por las laderas de las montañas y se dirigieron hacia los fiordos. La cercana ciudad de Chaitén fue evacuada cuando el volcán transformó por completo el paisaje circundante. Si bien la destrucción fue fácil de observar en tierra, los científicos aún no han examinado de cerca los impactos que tuvo la erupción en los entornos oceánicos circundantes. En esta misión, el doctor Sebastian Watt de la Universidad de Birmingham del Reino Unido liderará un equipo y está liderando actualmente un equipo internacional que busca estudiar los efectos submarinos de la erupción del volcán Chaitén desde el buque de investigación Falcor 2, donde nos encontramos actualmente, que busca comprender la huella de la erupción del volcán Chaitén en el entorno marino. También ayudará a desbloquear registros de tiempos más profundos de las principales erupciones volcánicas de la región, lo que permitirá a los científicos reconstruir el comportamiento volcánico en el sur de Chile a lo largo del tiempo geológico. ¿Qué busca esta investigación? Busca proporcionar información sobre cómo el vulcanismo activo afecta la recuperación de los océanos y los ecosistemas marinos después de una perturbación importante. Además, el registro geológico de erupciones de la región puede proporcionar información sobre si la formación y la recesión de los glaciares a lo largo del tiempo pueden contribuir o no a los eventos de erupción, utilizando una tecnología conocida ya por ustedes como es el Vibracore, el Pushcore, que es manipulado por una de las grandes estrellas en esta misión, el Rob Sebastian.
Gracias, Dani. We are still vibrating here. We should definitely be able to recover more sediment, deeper sediments than the previous vibrocore. Let's see. Vibrocores are supposed to be particularly appropriate for sandy sediments. So sands is a peculiar material with peculiar physical properties and reacts to pressure and tractions in a completely different way than soft clay, like soft sediment like clay, and the vibration. So in theory, a vibrocore should be even better than a gravity core for sandy sediments. And indeed, we tried a gravity core in our cruise a couple of days ago, and we recovered 1.5 meters of sediments. The core was 3 meters long. It was the first attempt, and we were worried about hitting something too hard for it, because we only had one core and we didn't want to damage it, but that didn't happen, and then the operation went very smooth. But in the end, we recovered 1.5 meters of penetration, which was more or less the same as the vibrocore that we did in the same location at the same station with Sebastian. So we'll see now here. This is a completely different environment from where we were in the last 2 weeks. Very deep water setting. We expect to find here the sediments from the volcanic eruptions transported here and maybe reworked, maybe enriched by other sources of sediments. But we also expect deep sea kind of sediments, so from pelagic and the mid-pelagic deposition. Something like a rain that just deposits in the seafloor.
como nos comentaba Matilde, aquí vamos viendo cómo este tubo largo y delgado va entrando en el suelo aplicando esta vibración que nos permite que entre más fácilmente y reduce la fricción entre el tubo y el suelo. Gracias a esto nosotros vamos a poder reconstruir paleoclimas, evaluar contaminantes, por ejemplo, en el sedimento, investigar acerca de la dinámica de los depósitos sedimentarios.
We're going down very slowly. From the pushko that we collected before, this may be due to the sand layers that are intercalating the clay. Maybe they're thick enough to slow down a lot the vibrapore penetration. We are collecting the pushko afterwards, this vibrapore here anyway. To have a thermal comparison. Yes, before Danny was giving a very nice overview of the whole project. Since what we actually want to achieve through all these operations, through subasting, through the mapping, through the coring, the oceanography measurements, and so on, is to understand how we can. What we want is to study the history and to find a good record of the Chaitan volcano and its past eruption, especially focusing on the 2008 one. And we know that coastal volcano and like island volcanoes are relatively difficult to study in terms of their history because all the information that we get on land are primary tephra deposits, which they don't definitely give us a complete picture of the history of the volcano. And instead, when volcanoes are close to the sea, we know that part of the volcanic sediments. It's stuck, so we can go up again and we try it again. Yeah. This is like how much?
Right now it's just below the 60 mark. So we'll see how much it goes up.
Sorry, that wasn't the story. Yeah, we are taking out the vibrapore because it got stuck. We will know in a bit how much did we penetrate. But anyway, the message from the story before was that the marine environment, so studying the record of volcanic eruption in the marine environments, actually allow us to study in a more comprehensive and more complete way the history of the volcano. Because we get to study also secondary and tertiary deposit, and also because we have much less erosion that we could have on land, in the case of coastal volcanoes. So what we are doing here is it is important in general for the study of history of coastal and island volcano worldwide. And we really hope that we already have a very nice data set and a lot of a very consistent observation, also a lot of questions, and we hope that the analysis that we will be able to do on all these samples that we are collecting together with a correlation with the seismic data and in integration also with the bathymetry and the oceanography will give us insights on this sourcing system and clarify a bit. So we have 70 centimeters from this vibroport. Cool. We hit something hard again. With this push, do you want to stop? Do you want to stop? Take it to the section. With the push. And with the push, do you have any preference? Okay. Because before we got this. We're gonna have this section. Okay. So just talking with Diego, biologist. In the room because he saw something moving. No, just one bite. Yes, makes sense. So Diego requested a sample for the suction sampler, but we're gonna do the push core first. Now that we are securing the second vibropore of the day, also preparing the third one for the next side, which we're going to do afterwards. This vibropore was 70 centimeters. So today we have our last ship to shore connection. We had so many of them. We are so happy of how much did we communicate and disseminate the science of our project with the local community mainly, but not only. We had kids and people of all age actually. The vibropore is secured in the meanwhile, the second vibropore. Yeah, I was saying that we have the last big dissemination event today. Thanks to Colombina and Dani for this. And then of course, with the geohazards associated to this scientific project, it's even more important to do science communication and dissemination and actually communicate to the local authorities and to the locals in general what risk do they live, how their landscape, their seascape did change, can change following an extreme event like an eruption, how their life would be affected, their economic activities. We are now preparing the third vibrocore that we will do in the third side.
So you want two of this location?
No, we are just preparing.
Just putting it in direct.
Yes. This is what Rodrigo recommended. Looking at the map that I cannot look anymore because there is a password.
Oh, I see. So he wants to move on to the next location.
Yeah,
makes
and
sense.
these are the, and eventually a
Go
fourth
further.
one.
Yeah.
And these are all on crossing line on the SVP
Okay.
here. The previous core would be somewhere like here.
Okay. Sounds good.
Real-
So we're going to move to that next one. Yeah.
Well, we do a push core and a
Oh, you want to do push core bit first?
don't you think so?
Yeah, I think so. Obviously.
And also we have some requests from the biology just now as well to do with the suction.
Okay, so now push
Great,
core.
yeah. One push core for sediments instead of one push core per piece.
Number 3 is okay?
It's very special to think that we are at 3,000 meters and a half of depth. And we actually saw super colorful and magic creatures going down, especially in the first 1,000 meters.
Yeah, just do a regular push
Yeah,
core.
yeah, we don't really. Yeah.
Puedo llevar a cabo la succión de manuales. Es conocido para los marinos en este momento, pero estará por aquí.
Great.
Me retracto de lo dicho anteriormente, ahora estamos sacando el tercer push core para el análisis de sedimento.
See any back? You didn't see any back. Just one? See, just one. And then we do a suction sampler, but I'll pass the word to Gianluca because they have a packet. So, push core, the first and the only push core of the second site, successfully collected. Now we are going to do a suction sampler on a specific target requested by the biologist that you see on the right of the push cores on the camera that we are sharing with you. You will see soon.
El push core ha sido realizado de manera exitosa, entonces ahora procederemos a usar el succionador para extraer el organismo como se ve a la derecha de la imagen, a la derecha de los Puchkur, para poder averiguar el origen biológico de esta especie.
I'm asking Gianluca if he has any idea of what this animal is.
Estás pidiéndole ayuda a Gianluca para poder ver qué tipo de animal es.
Diego is very nice.
Bueno, aquí habla Diego, del equipo de Biología Marina, y es algo bien extraño lo que estamos viendo, pero creemos hacia primera vista que puede ser una anémona. Sí, anémona.
It's an anemone.
Anémona.
Anemone.
Podría ser.
Yeah, thank you, Diego. Diego, I have a question for you. How will you bring back all these biological samples? What's the procedure to do it?
With this sample?
Yes. Also in Spanish, if you like. I can try to translate.
Gracias. Bueno, cuando
No problem.
Cuando llega a la superficie, la extracción es súper simple. Solamente lo tomamos y lo dejamos en un recipiente con agua de mar, y quizás sobrevive algunos minutos. Podemos ver como un poco su comportamiento y luego se fija en alcohol.
So what they do, the procedure they follow, Jan and Diego, the biologists that we have on board, looking for this kind of fauna, it's that they actually put them in salty water for some time before putting the samples in alcohol. And during this time in the salty water on board, some of them may be still alive and still observable by, let's say, the behavior point of view. And then in alcohol and stored to be brought home. Yeah.
Para ser estudiado posteriormente con más tranquilidad. Para ser estudiado posteriormente en alcohol. Claro.
Yes, it's conserved in alcohol to be studied afterwards in the university in Valparaiso or elsewhere if they send the samples elsewhere. Yeah. So now we are getting close to the suction sampler to get this anemone that we identified. You cannot see it now because it's too messy. don't get a lot of visibility now. And after this operation, we will move to the next side.
Is that what you want? Oh, you can see the camera coming out, the stars and stars.
Diego, is the one?
Ahora se realizará la extracción del organismo para después llegar a cabo el siguiente paso en otra zona. Ahora nuestro compañero Gianluca está dando las indicaciones sobre el organismo que queremos extraer.
Yeah, there are lots of stuff moving here on the seafloor. You can see the red tip of the suction sampler on the top of the camera we are sharing with you.
En la parte superior de la pantalla, en esta tapa roja, pueden ver la punta del extractor y lo que se realizará acá ahora.
Ready to suck the anemone. Suction on. Oh, it's very beautiful. We have it and we're gonna see it soon. The jar. Here it is. Done. Thank you very much. So Zach, we move now.
Entonces el organismo fue succionado con éxito y en la parte superior izquierda de su pantalla pueden ver los organismos ya recolectados.
Oh, 7. Wait. 7.
Se puede ver un fiuro, un pepino de mar.
One mile from the division 1, not far from the division 1. Okay. It's not very much. That's not even true because the mile is more, it's less than that.
I thought you meant I have a Matilde English Spanish translator.
And then this is site,
So whenever
that would be
you
DC,
leave, we like to go 1 mile from
This is what I told these bed loggers, that it's
1
27.
mile.
27 is the first 100 meters. I told them that, so I'll try to five.
So the next one will be 28.
About 145.
That was 27.
There's about 140 centimeters. Yeah, 450. Okay, so you want different number?
1 mile is more than 1 kilometer.
Yes, that's what I said. 1.45.
But don't you have now?
Sorry?
That's what I gave you.
I can see.
I think it's 1.8.
Not that way. I don't see a lot of that.
What direction?
295.
It's supposed that is
Matilda, have you done the push core here?
Yeah, one.
You've done it?
One, yeah. One is fine.
Yes, but did we already take it?
Oh,
Yes.
I'm so wrong.
Okay.
You want
One's
to
fine.
have another one?
One's fine.
1.8. 1.6.
1,600 meters at
Sorry, I must have missed that.
295 is possible. Yeah.
And then the back before the Jason was cut. Was one of the modified ones.
I was confused with the
It was the one in position 4.
BP in the way.
look. You have on your screen, you have a map that has the terrain.
Just one part before from here, right?
Yeah, you've got a push core from here, right?
No.
Yeah. So they're both, so one push core.
Oh, that an enemy.
Both 27, 27,
An enemy? You're saying we'll get it?
An enemy.
We're gonna start moving at about a 295 FY, so we'll start to get
Enemy here.
There's no enemies here.
It's always sound. I'm missing my coffee mug. Oh, that's why I kind of sleepy now. Blown coffee.
That's all on you, man.
No. No, so you got anything?
I saw the hamlets. That's what I'm
Do we want to open a push on the next side?
I think the next site, just vibrant, pushing in. We're gonna try to hit more than 3.
Which
Yeah.
number?
Oh, I
So,
don't know.
4 of us.
No, up to 5.
Just
Right?
1, 5, 1.
I think it was position number 4,
So we already used just 2, right?
Yeah.
which was the modified cone
Two more.
catcher. Just check with,
I mean,
check with
2
Matilda.
sites.
Yeah, do you
Two
want to check
sides.
with Matilda?
So the only one, right?
Was it penetration 15?
It was going, the first one was going into position number 5. I think.
I heard.
Yeah, and then this one I think was position 4.
Says,
Just check.
The pilot told him that we were going 70 something. But I'm sure.
It's like
Yes,
a
yes, sir.
innocent.
Yes, or maybe it was 50.
Yes. Yes, it's correct. I need to write it down. First one was 5. I need to write it down. Position 5. Position 4. And the 3 of them are this.
Yes. I think we already used 4 and 5 have the latest modifying products.
Zach, which position is the divided that you already prepared?
Which position?
3, right?
You might have to check that.
And slash, I agree
That's actually the best.
Sorry?
So that means only 2 minutes.
Yes. Yeah, because we're moving down. So it's a new station.
How many are we doing?
I don't know, it could be up to 5.
Probably the best after than that, it's gonna be pretty long. Transect, we could probably.
Bueno, actualmente nos estamos moviendo para realizar el próximo pushcore, que es este instrumento que sirve para recoger sedimento.
Del 11.
Pasaremos a la estación número 28.
If it gets around 80.
John, did you do the sequin? The sequin?
The coral.
Oh, you saw the coral? That was a coral? Okay. The biologist, I study dead things. What's that? Is that a sea pig? Is this a sea pig?
Yep, I think so.
En las imágenes podemos observar algunos erizos, otros pepinos de mar o fiuros. Básicamente se repite el patrón de la composición de la comunidad bentónica en estos sectores. Básicamente la epifauna se encuentra dominada por equinodermos. Es un filum que se encuentra compuesto por estrellas, holoturios y erizos, principalmente. Y claro, dentro de esto también abarca los fiuros y el pepino de mar, entre otros.
brillante. Really, always.
Hashtag Scotland.
And if there's something on this section, okay, that's yours. I can get you carbon and nitrogen data.
That's so
Well, I'll share it with different dishes.
How far to the next station, next waypoint?
1.8, or sorry, 1.6 kilometers.
This waypoint, did you choose it based upon the morphology? Is it on
Yes,
the
and
crest?
that and also previous data.
Right.
I'll show you. So this was the first one. Now, the first one. This line, this point represent the previous line again for the other side. So 1 mile is that one. So we're gonna get a crossing.
Okay.
And then if we move this direction, and this is in a height, and then we move this way, then
You can see this.
yes. So this kind of this shapes, and so from this point to this point, that's 1 mile, and another mile you get to this other crossing.
Are we gonna be in the crest or in the top?
Like near the crest.
Near the crest.
Yeah, not right on top. Thing is, if we do that, then we're gonna have 1, 2, 3 samples side with crossings, and this is the previous one with this kind of crossing.
Got it.
So if we convince this guy to share, so we'll have several samples, all with cross lines and stuff. I thought it was a good idea, and this is a profile from 0 will be that one. So the next one will be there, and the other one will be kind of there.
The first two stations are 100 meters apart. So station
Yeah,
26.
so it will be kind of that point
There.
and somewhere there.
Okay.
And the next
And then
point.
station 27 that we just poured.
No. Wait. No, we did 2 stations already, right? So those are 100 meters.
So they're
Like
really tiny on the
right,
graph.
yeah, in this flow will be 0 and almost next to it. The next one will be there.
Wow, 1.6 kilometers.
Yeah.
Okay.
And then if we decide, if we want to spend the time, I was thinking another one here, just because we have a crossing
Yep,
from previous.
perfect.
And this track line I made because it's parallel to the, in theory, the main flow
Of the channel.
of the shop, yes.
As it goes out to the
Right,
fan.
right.
Did you get any good stuff on it from that?
Right. Yes, pieces here and there. You actually see that it's a station.
Well, but then it's like jumping.
It's jumping, but also you get decent data in, like here, then it jumps, no data, jump, no data, then good data, so it's all over the place. You might want to try with Matilda to put all this together and yeah, and try to see if we can improve
You
it.
just print it and then like cut them out
Yeah.
like a puzzle.
I know.
Is that a type of cucumber? You don't know what that is.
En las imágenes vemos distintos tipos de pepinos de mar. Están discutiendo aquí el grupo de científicos. Se puede ver una variedad de formas y tamaños. Se puede ver uno más aplanado. Uno fiuro moviéndose también. Y sí, este tipo de raíces que se ven
Look at all the little traces on the seafloor.
probablemente son comunidades de foraminíferos
A little bit of a problem.
que no son especies pertenecientes al reino animal.
Square inch you look, there is biodiversity.
Can we step one up? Are we too late to stop and step one up? Is that okay?
Yeah, is that okay? But
Too
we
big.
just measured. Ah, you mean one of those, Vicky?
Yeah.
Oh. This guy is so big, he's gonna get stuck in the vacuum.
Well,
Try it.
let's try it.
No, poor guy. Run away, run away. These people want to. For him, we're just.
Ahora se realizará la succión de esta especie de holoturio o pepino de mar,
An alien suction.
que parece, están diciendo aquí que es como una abducción alienígena.
Oh, it's actually pretty big.
Oh, good. Can
I
you
trust
change
you.
the view, Sophia, so we can see the suction arm from above?
Los pilotos de Sebastián ahora están realizando su mejor esfuerzo para poder extraer esta especie, para ser estudiada por los biólogos marinos acá en el buque Falcor, en la superficie. Les queremos recordar también a los que no están informados o están llegando, uniéndose recién a la transmisión, que estas son las primeras imágenes. Aquí se ve un crustáceo nadando, un tipo de camarón de profundidad. Estas son las primeras imágenes en vivo transmitidas por un robot submarino en este cañón. Nunca antes se había grabado la superficie del fondo marino en esta parte del mundo.
You're abandoning us for your coffee mug?
What?
You're abandoning us for your coffee mug?
Yes.
Yeah, I see.
Huh? Yes, yes, we're in
And we can
transport.
watch.
Where-
Big, flat, big, what? Big, blue.
Yeah, sure.
Scientific.
Scientific, yeah. Very technical.
Okay, we might have to abandon this plan, don't we? What do you guys think? I'm gonna wait a long time for it to clear.
Bueno, ahora por el movimiento del robot submarino Sebastián se ha levantado una nube de polvo, por así decirlo, por el sedimento, y entonces debemos esperar a que se pase un poco para poder actuar y realizar un muestreo de mejor forma.
Okay, moving on to the next one.
Bueno, recientemente no tuvimos éxito en la extracción del holoturio anterior, por lo que avanzaremos hacia otra zona para seguir con la toma de muestras, tanto de sedimento como biológicas.
Oh, wow. Another one?
Do you think that's a worm? Like sticking up?
Oh, yeah.
Cool.
También me gustaría mencionarles que esto es solamente la fauna bentónica que se puede observar por fuera de la superficie. Es decir, estos pertenecen a la epifauna, ya que una vez que tomemos las muestras con las scoop bags o bolsas, después en la superficie acá en el laboratorio podremos analizar lo que se encuentra por dentro de la arena.
Probably be about 11 hours before the ROV comes back up to surface to the Falcor 2. So since he abandoned us, I'm sitting in his chair. This is Dr. Becky Totten from University of Alabama. And the marine biologists are very happy right now. We're making a transit to the next site. Wow. Yeah, can we suck it up while we're flying? We are testing the capabilities of the ROV Sebastian. There's a little, there you can probably see now, the right hand part of your screen.
Intentaremos extraer esta especie
Louisiana
que se
wants to
encuentra
see what these
nadando.
taste like. Just kidding. We're not allowed to eat the sea creatures. I think. Did it work? Oh my gosh. Was that you, Scott? Oh my gosh. That was Zach?
Extracción realizada con éxito.
Scott. Can we get a little view of the tank? Oh, it just went in the tank. Sweet. Wow, he's kind of cramped in there. Oh. Very cool. Great job, guys.
Actualmente no se ve en
I think
cámara,
he's the
pero
only one that will
estamos viendo
fit in
las
that tank,
imágenes
so
del
we'll close
contenedor
that
de esta
one up.
especie que acaba de ser extraída.
Carlos, can we get a view on the tank there? Ooh. 2 has got a brittle star. I think 3 has an anemone. Anemone?
Yeah.
Wow. It's really moving around in there.
Estamos siendo privilegiados de poder observar la
Ooh,
diversidad
yeah.
de
3's
fauna
got
bentónica
the
en
brittle
esta
star
zona.
and the worm, the acorn worm. 1 has got that swimming cucumbery thing that we picked up. Ooh. Defensive goop. I need some of that. Oh. Marianne Mane has taken a break. She is en clase online en este momento, but she'll come back soon. It's wonderful to see so many people watching, families of all the scientists on board. Thank you for your support.
Queremos agradecer por todo el apoyo que nos han brindado acá en los comentarios en el chat y por toda la gente que ha estado viéndonos alrededor de todo el mundo. Les recuerdo que estamos en el cañón submarino Simpson a 3.412 metros de profundidad exactamente. Este sector se encuentra al suroeste de la isla Guafo, al sur de Chiloé. Esta es la inmersión más larga de esta expedición, ya que llevará a cabo alrededor de 11 horas entre subir y bajar, por lo que ha sido algo que estamos muy expectantes.
Hola, madre de Marianne.
Hola, Moira, ¿cómo estás? Soy Amalia.
Sí, Amalia aquí, acá.
En representación de la Mane que está en una clase.
En clase online.
¿Todo bien por allá? Les mando un saludo. Yo creo que Mane también quiere mandarles un saludito. pero no está aquí.
Y buenos, la familia de Rodrigo.
Hola, Benito. Ah, se fue a tomar un café, como siempre. Su hijo Rodrigo se fue a tomar un café. Yo soy Amalia, su estudiante.
And we're looking at all these cool pepinos del mar. Sea
Pepinos,
pigs.
sí.
There, we just passed another sea pig that had some really cool ornamentation on it.
Ujú.
Now we're ooh,
Succionamos.
that's, yeah. I'm pretty amazed that we were able to suction in midair. See some worms sticking up out of the seafloor. Those are those kind of weird critters that have they're sticking up out of the seafloor and they have some spiky looking things on them. Some sea cucumbers, sea pigs, and sea stars, brittle stars. Oh, Diego.
Yo también me encuentro muy sorprendido. Estoy acá muy entretenido mirando toda la diversidad bentónica. Es algo totalmente nuevo para mí, personalmente.
Diego te está mandando saludos. Diego te está mandando saludos. Tu prima, Alejandra.
Ah, ya. Saludos, primita. Gracias por verme y por los saludos. De acá no alcanzo a leer el chat, pero sé que me están mandando cariños. Así que un abrazo, besos a todos por allá.
Dice que son secos.
Sí lo somos. Sí, la gente de acá, todos, cada uno del equipo científico son todos muy secos.
And seco, which means dry, is like a special Chilean slang. Can you explain what it means?
Seco is dry in English, and it means like you are very good at something.
Yeah, like if you call a person seco, it means you're really good at it. Oh, that's
Yes.
another sea pig. What? La gente seco. Secos?
La gente seca.
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 Yeah, lots of unique slang in Chile. It's a wonderful and interesting language.
Un abrazo para ti también, Moira. Yo creo que Mane también te manda un abrazo y un beso. ¿Ah?
Gracias por su apoyo, todos. Especialidad, las familias de los científicos. Muchas gracias.
Muy bien. Excelente.
Brillante.
Brillante.
Okay, and now back and also caffeinated is our leader of the geophysics, who's been leading this dive for the last few hours, Matilde Ferrante from the OGS in Trieste in Italy. Italia bella.
Ahora vuelve con nosotros Matilde Ferrante, nuestra geofísica, que vuelve de su break, ahora cafeinada.
So we're still traveling towards the third site, having a fly over all these creatures, living at 3,500 meters. For the Italians that may follow us now, more or less at dinner time. Siamo a 3500 metri di profondità, ci stiamo muovendo verso il terzo sito del nostro dive, 1 miglio nautico dal primo che abbiamo fatto, cominciando questa mattina, e stiamo volando a qualche metro dal fondo del mare.
Can you go on the log, the shape of the seafloor there?
We have some
We
morphological
have some
feature.
topography that looks like it might be a smaller bed form that's superimposed
Mm.
on the larger.
A bed form.
I'm trying to observe.
We can see a bed form here,
It's a big dune form.
and we are flying exactly on its axis. And wait, oh, this is nice. There is some topography here. It's a dune.
Yeah.
A small dune, right?
Yeah. Let's do a frame grab on that too, once you're done vlogging.
During our expedition in offshore Chaitan, we did find a giant dune field with dunes kilometers long. Very interesting features on the seafloor. These are much smaller one. Something similar, more similar to what you would see on land on our beaches. But still they can be an interesting target for us. And also they tell us something about the currents here, so also about how the sediment can get transported. So it's very important to track down their orientation. Abbiamo appena sorvolato una piccola duna sul fondo del mare che potrebbe dirci qualcosa sull'andamento delle correnti qua e quindi sul trasporto dei sedimenti, che è uno degli obiettivi del nostro lavoro, capire come i sedimenti e possibilmente i sedimenti vulcanici delle eruzioni del Chaitan, primari, secondari, vengono trasportati fino a qua, a centinaia di chilometri di distanza, a 3500 metri di profondità.
Go ahead.
Let's try a 0.5.
0.5.
What do you think that was?
Another sea pen? Oh, okay, that there is a sea pen, the worm that's sticking
A
out.
sea pen on the left, right?
Things. Pen.
Sea pen. Diego, do you want to tell us something about it?
About the seabed?
Yeah. Also, again, also in Spanish, maybe you can translate as you like. Just wait a moment for Diego to give us some information on it. Oh, look at that, that is different.
Ooh.
Bueno, en las imágenes pudimos observar una pluma de mar, en inglés llamado seapen, que son una clase de nidarios. Estos es un filum que compone a las principalmente a medusas o hidrozoos, corales también. Bueno, y específicamente esta pluma de mar pertenece a la clase Octocoralia. Estas son especies sésiles, o sea que no se mueven, se mantienen ahí enterrados en el sedimento y obtienen sus nutrientes a través de la materia orgánica que cae desde la superficie.
So, thank you, Diego. Trying to translate, these are organisms that stay still and they don't move. They get their nutrients from the pelagic rain for the nutrients from the pelagic rain, and they are part of the same phylum as jellyfish and corals.
Nidarios, claro.
Nidarios.
Y en relación a esto, durante la inmersión pudimos apreciar varias especies de este filum de nidarios. Pudimos ver algunos sifonóforos, que son organismos que forman colonias. Un ejemplo de este es la famosa fragata portuguesa, que pareciera como un organismo muy grande, pero en realidad son organismos muy pequeños que forman colonias. También pudimos observar alguna medusa, una helmet jellyfish, en inglés.
Yes, so we saw several jellyfish, and the Portuguese is the...
Fragata portuguesa.
Sí. Es la peligrosa, la portuguesa?
Sí, es una especie tóxica.
It's a toxic species. The Portuguese one.
Portuguese manowar. Pero claro, esa es una especie de sifonóforo y vimos otro tipo de esta especie.
Yeah, we observed several types of this species.
Acá, hablando de nidarios, se puede ver una anémona en el fondo. Se podía ver.
Anemone on the left of us, front left.
Que también pertenecen al filum de los nidarios.
So it's actually full of life here. And we have a long trip ahead of us until we can arrive to our site 3. The camera on these ROV are amazing. You can really see lots of details, and here in the control room we have several cameras and several screens showing several angles, so we can appreciate every operations of the ROV. And together with it, in the control room we have other information coming from other systems and the bathymetry that we acquired last night. The EK80, which is a sonar normally used for fisheries, which works in 5 different frequency channels. We have it on board with a specialist from NOAA, which is here, has an observer to work with it. So we're flying 2.5 meters above the seafloor. So I have a question for the biologists, if they are happy to take it. So why do we still, it's a very basic one, why do we still see colorful organisms here where there is no light? Never. I know it may be not a simple answer, but I think the question is something that.
Bueno, Matilde nos pregunta acerca de por qué podemos ver organismos tan coloridos en el fondo del mar, o sea, claro, a más de 3.000 metros de profundidad, donde no es posible, no llega la luz del sol. Entonces por eso nos hizo esa curiosa pregunta, que justamente nos habían preguntado hace unos días una compañera. Actualmente al menos yo no tengo como una respuesta para eso. pero sé que muchos de estos colores brillantes sirven para advertir o decir algo. Quizás hay algunas especies que son presas fáciles, entonces usan esta ventaja evolutiva de estos colores brillantes para advertirle a los demás organismos acerca de algún grado de toxicidad, puede ser.
Ah, sí. Solo más colorado, lo más... Ah,
Puede
puede ser. Como normalmente la toxicidad es colegada a un color.
Claro.
Ahora, si ellos son colorados, el mensaje es soy tóxico.
Claro.
Puede ser. So one possible answer to it could be that normally, well, this is also with animals on land, right? When you have very colorful animals, very often they are also toxic. Things about like these super colorful frogs in the Amazonian forest or in Asia, in Southeast Asia and so on. So maybe they want to transmit the message that they are toxic to the predators. This is a possible evolutionary answer to it.
Yes, those are sea cucumbers.
Sea cucumbers everywhere.
And we saw some swimming.
Look at this one flying.
Oh, that's jellyfish.
Medusa.
Una medusa, una piccola medusa. En español es medusas.
Medusa.
Sí, medusa.
Mismo.
Bueno, también otra respuesta que podría hacer a esa pregunta acerca de los colores es porque el espectro de luz los colores más rojos, naranjos, no llegan a tanta profundidad del mar. Entonces por eso estas presas, organismos que pueden ser más presas fáciles, debido a una ventaja evolutiva, pueden obtener estos colores más rojos y así son menos vistosos en el fondo del océano donde no llega luz. Al contrario del color azul, que puede llegar a mayores profundidades, estos podrían ser más vistos.
So Diego is explaining us that another answer for the color question is the different wavelength of the colors. So blue has a larger wavelength than red in the light spectrum. So it means that it can travel in the water more. So at this depth, even a shallowest depth, we lose the red colors and the colors close to red, while we can still see the blue one. So if you want to disappear, you're red, basically. If you don't want to be seen, you're red.
Es una cuestión de supervivencia, básicamente.
It's about surviving. Yeah. And previously we said that medusas, jellyfish, and corals are part of the same phylum, right?
Exacto.
And how does it work? I mean, they're part of the same.
Ser parte del mismo phylum.
They are the same organism transformating somehow.
Lo que pasa que lo que tienen en común estas especies que son formadas por pólipos, y los pólipos, si no mal recuerdo, son como la parte más fundamental o más básica de estos animales. Entonces, al principio, ya cuando estos son larvas, son todos muy parecidos. Entonces las llamamos pólipos. Y después llegaron a evolucionar y a convertirse en formas más complejas de vida y que pueden verse tan diferentes como lo son un coral, una medusa o una anémona. pero
Sí.
ya estas en su etapa más básica, su etapa de larva, estos ya pueden ser muy parecidos.
Sí. So both of them, jellyfish and corals, come from the first first level in the evolutionary scale of polyp.
Yeah, polypus.
In English as well?
In English is polyp.
Polyp, and they get differentiated in several branches. Let's say they can become corals or medusas, jellyfish.
But eventually they went in a different direction from the waves.
¿Sí?
Algo que dijo un compañero, las grandes similitudes, como dijo él, en la parte evolutiva, es que ambos, ya sean las medusas o los corales, presentan células organolépticas. Quiere decir que tiene estas células en sus tentáculos o en sus brazos, por decirlo de una manera más simple, y que sirven para poder atingir a las presas para así poder alimentarse.
Sí. So thank you, John. He's explaining us that one main thing that both medusas and corals have in common is their, we can call maybe arms. So something like arms with urticant, like kind of urticant toxic. How do you
Yeah.
say urticant in English?
Urticaria.
So what you get from jellyfish when they touch you, basically?
Stinging.
Yeah, maybe stinging. Yeah, I don't know. They both have these kind of arms with this characteristic, which helps them in. I think I lost this part in Spanish. In eating, so in the feeding procedure. So yeah, well, both of them.
Claro, tanto los corales como las medusas, sifonóforos, anémonas también, todos tienen en común esta célula urticante.
So the anemone as well, they have this stinky cell.
Alabama time, 3 to 4. 4 to 5.
So we're still traveling. We are not even halfway from our third target. We are moving very slow, of course.
Bueno, y todavía estamos en camino hacia la siguiente estación. Estamos moviendo a una velocidad muy baja debido al tema de la profundidad y la presión. Este procedimiento tiene que ser muy cuidadoso.
Yes, so I was looking for pictures where do some waves and stuff, but it's getting a bit late. It's 2:30 something hours, so I'm not sure I'm gonna be able to do the whole podcast. Do you know what's the plan after this?
You mean after the ROV?
Do you have waypoints and stuff? No?
We have 3-4 hours of ROV coming up. So we need to check the direction of the wind and the wave.
Right. No, I'm thinking that is like it's becoming late. Maybe we're in this part, but in theory we're, if it's 1/3, we're in this area. We're moving that direction. So this is the next point. So what if we just sample here
and then after this one, like one by here, and we do two here because we have three left, right?
Yeah.
And that's all.
No. Yeah. Three.
Three. And we finish because we're going really slow.
Another possibility is to go back and cycle the sun in between. But
that would be nice as well. That would be nice. How long ago was the was it while ago?
I think they marked it down. Did we track down the small bedforms, the small dunes?
Do we have a landmark? Can you give it to me?
Bueno, aquí se ve una estructura que parece un palo enterrado. Esto en realidad es un octocoral. Los octocorales también son nidarios y son especies que presentan esa forma enterrada en el sedimento. Que aunque pareciera una alga o alguna especie de planta, en realidad son el reino animal.
So, since we are still traveling and actually discussing a bit if we need to relocate our third site because we are running late and ROV ascent will be very long, 3-4 hours. In the meanwhile, I'll present you Paula, which works for the Geological Service of Chile, I will say in English, and is part of our expedition in the hydroacoustic lab and also helping actually in the geological lab. She's a geologist. She did geography and geomatics in her career, and she can talk a bit to you about how the Geological Service in Chile works and how they got involved in this project, in this marine project, which is something maybe unusual for them. So, Paula, to you.
Hola, gracias Matilde. Bueno, yo soy parte del Servicio Nacional de Geología y Minería. Aquí en Chile estamos divididos en dos áreas, la parte de minería y de geología. Y en geología abarcamos distintas cosas y dentro de ella está la parte de la Red Nacional de Vigilancia Volcánica. Entonces, como este proyecto se basa principalmente en la erupción del volcán Chaitén en el 2008 y cómo esto afectó el fondo marino, es muy importante para Senagiomín poder participar en esta expedición y también nosotros podemos aportar aquí porque el Senagiomín fue muy activo durante la erupción, durante la emergencia y hemos sido parte desde el comienzo. La erupción del volcán Chaitén fue como un cambio, un antes y después para la investigación volcanológica a nivel nacional. Así que para nosotros es muy importante estar aquí para ver qué sucedió con los depósitos bajo el mar de la erupción. Actualmente hemos ido encontrando en algunos testigos estas capas que tienen ceniza que se correlacionan con la química que tiene característica este volcán, que principalmente rico en sílice, así que hemos estado encontrando cosas bastante interesantes. A mí, a modo personal, me interesa mucho la evolución de los deltas. Yo tengo trabajos previamente en la evolución de un estuario que queda en el centro de Chile, entonces es interesante poder compararlo con lo que pasa en Patagonia, que tenemos otro clima, tenemos otras condiciones y particularmente tenemos aquí el input de los volcanes. La pregunta de Matilde está enfocada también a qué se hacía en Cernagemín. Entonces, bueno, tenemos distintas áreas. Está la geología básica, ¿cierto? Que se hacen mapas de geología de todo Chile. Tenemos mucho en el norte que está enfocado en la exploración minera, pero también investigamos la parte del sur. Yo particularmente trabajo en la Oficina de Sistemas de Información Geográfica, que es donde se hace el control de calidad de estos mapas, y además el servicio tiene distintas departamentos. Entonces hay un departamento que es de hidrogeología, hay otro que es de geotermia, de peligros geológicos. Entonces tratamos de abordar todos los temas que acontecen al país y principalmente a los que afectan a la población. Tenemos que pensar que Chile es un país muy largo, ¿cierto? Tenemos variación climática y el hecho de que exista la subducción, ¿cierto? Que la placa de Nazca esté subduciendo la placa Sudamérica genera condiciones específicas para que tengamos la cordillera, tengamos depósitos metalíferos en el norte y también tengamos volcanes. Entonces Chile es un lugar particularmente especial para hacer geología. Es por eso también que eligieron Volcán Chaitén y Chile para hacer esta investigación, ya que además de que esta erupción fue hace poco y está registrada y fue monitoreada mientras ocurrió durante el evento y también los meses posteriores, lo que se pudo... este es un lugar importante en términos de glaciación, ¿cierto? Entonces es otro factor que se puede ir estudiando, la variabilidad climática y cómo esto ocurre en conjunto con los distintos eventos de erupciones de distintos volcanes, porque si bien es cierto estamos estudiando aquí el volcán Chaitén, justo atrás está el volcán Michimaguida, que tiene otra componente que también creemos que hemos visto en algunos testigos que obtuvimos por el Vibracol, y también tenemos el volcán Merimoyu, que tiene erupciones mucho más antiguas. Entonces va a ser interesante los estudios posteriores a esta expedición. Para Cernagemín es muy importante estar aquí. Se está reactivando el área de geología y geofísica marina. Tenemos otro colega que va a estar en la próxima expedición del Falcor, donde se van a ver venas hidrotermales, ¿cierto?, asociadas a otros procesos de liberación de calor del fondo marino. Así que esta es una gran oportunidad para la geología del país. En particular, a mí me gustaría recalcar que somos distintos científicos de distintos lugares, entonces la multidisciplina y también la multinacionalidad es un gran aporte, es una especie de práctico, de capacitación que tenemos la oportunidad de vivir, así que esta es una gran oportunidad para todos dentro de mejorar el conocimiento y poder replicarlo en otros cruceros. Chile también tiene cruceros, la Armada tiene el Cabo de Hornos y tiene otro que es de la Antártica, así que también está la esperanza de que el futuro poder colaborar también con ellos. Aquí estamos muy profundo, 3.400 metros bajo el agua en el cañón Simpson, y hemos estado revisando desde el seno de Reloncaví, ¿cierto?, que teníamos profundidades de 100 metros recorriendo todo el mar interior de Chiloé. Entonces, aparte de poder buscar el input de las cenizas y el impacto que ellas tuvieron en el fondo marino, podemos tener una idea o buscamos obtener respuestas de cómo es el transporte de sedimento a lo largo de todo este mar interno. Hemos encontrado que hay canales, lugares donde no existe depositación en el fondo, mientras que en lugares más encerrados hemos visto material más fino. Aquí se ve que es mucho más fino que era lo esperable por la profundidad. Entonces, esta expedición puede responder distintas interrogantes.
Gracias, Paula. Te interrumpo un segundo para hablar acerca de lo que estamos por hacer. Vamos a extraer esta rara estrella de 4 brazos con forma de cruz. Los pilotos están haciendo su mejor trabajo posible para extraerlos sin poder dañarlos. Pero al ser una especie igual de un tamaño considerablemente mayor, ya se ve que es un trabajo más difícil.
The guys are saying that it makes itself stiffen up.
Yeah.
So it's not gonna go.
It's stiffened itself.
Yes, it's a defense mechanism.
It worked.
Yeah. So now we can use the arms.
¿Funcionó?
Grab it.
Bueno, al parecer la extracción fue correcta. Ahora veremos a través de las cámaras que tienen estos recipientes. Bueno, me retracto, al final no la extraeremos. Está muy difícil, ya se puso muy rígida y nos dificulta más la misión. Así que ahí se puede ver. Así que abortaremos misión. Mira, muy bien. Nuestra doctora Rebeca Toten se ha esforzado mucho por aprender español en la última semana y ha mostrado un gran avance.
So thank you, Paula. We're still traveling after having stopped and decided to not to sample the star anymore. It was defending itself. And we will see if we are gonna stop before what we thought it would have been our third site.
Yes.
Because we are a bit in a rush, considering the whole operation, the whole of the operation at this depth is very long. And so we'll see if we see something interesting on the seabed, some topographic feature as before, or some change in the seabed properties. We're gonna stop and do a vibro core and a push for that. Otherwise we get directly on the third site, which is a site that we identified on the basis of previous geophysical surveys. And when we will arrive over there at 4 more or less Chilean time, we will have 1 hour.
It's good.
Our job.
Yeah, but the problem is that when people say that they cannot hear. It's good. I mean, you can still try, but make sure that someone read the comments. Because early in the morning when they comment, we're not hearing anything.
Oh yeah.
Yeah.
So it's myself, I'm a PhD student from the University of Birmingham, looking at volcanic collapse, particularly in Indonesia, but also really interested in what's happening here in Chile. On the mic, we've also got Anke.
Kia ora everyone, I'm Anke. I'm based in New Zealand and I usually work on stratovolcanoes and their long-term behavior, mass flow processes, and how these deposits end up where we find them. And we've also got someone else here from Team Volcano.
Hello, I am Alistair. I'm at the University of Edinburgh. I'm a physical volcanologist. I work on explosive volcanism. I look at eruptive processes, long-term eruptive histories, and try and piece things together based on their deposits. So looking at past eruptions to see what they might do again in the future.
Yeah, so we've had a lot of talk about the different biology and the seafloor that we've seen today. But we thought we would come in and explain a little bit more about what we're doing here with sort of the volcanology, particularly sort of closer into that Bay of Chaiten. Anke, I don't know if you want to talk us through a little bit of the sort of volcanic area that we're in right now.
Yeah, so we are in a very active volcanic area. A lot of andesitic stratovolcanoes we've got here, basaltic stratovolcanoes, all the way to our more explosive rhyolite calderas like Chaiten, which is one of the volcanoes that we're studying. It last erupted in 2008, and we've been trying to trace.
There's lots of photos going on in the room.
Yeah, lots of photos. Too many paparazzi around here. And yeah, we've been trying to trace the ash that was produced during the 2008 eruption around the coastline around Chaiten, but north of Chaiten town and down the rivers that are derived from Chaiten volcano, as well as its neighbor Michimueda, which produces. There's a really nice starfish there that we haven't seen before.
Yeah, it's a bit different to some of the thinner starfish we've seen.
Very pretty. Yeah, so we've been working our way along the coastline, working our way towards the volcano, and now we are probably at the most distal point from the volcanic source. We had to change our plans a little bit because of the approaching weather, so we haven't been quite in chronological order with distance. We're at our most distant point now, and also at our deepest point at about almost 3,500 meters.
Yes, so what you guys can't see from this dive stream is up at the surface where we are.
That's beautiful.
We've got quite a roll going on, so choppy seas.
So we're just looking at a starfish. I have no idea if it actually is a starfish because we're not biologists, but trying to listen to what the biologists are saying.
Yeah, we're just having a quick look to see if we can identify it.
It looks like a star. Looks like a cross between a star and a fish. So it's probably
it's
a starfish.
It's got 5 legs.
So, yeah. It's pretty cool. It's pretty cool. Might be a bit flatter when we bring it to the surface if we were to collect that. It's not going to fit, is it? It's not going to fit in the tube.
No, I think we might see if we can grab it.
Moving on.
Wow.
So,
too many creatures today.
So many things on this seafloor. Lots of these sea cucumbers. Something floating.
Crustaceous creature.
Yeah. Crustaceans. That's a bit of sediment that we're zooming in on.
Although we see not much light, it's all vibration.
So yeah, we're really excited that we are going to be approaching our next sampling site and hopefully manage to get a really long vibrocore so we can look at the fine sediment that is deposited down at the ocean bottom and hopefully find a few tephras in there.
So for those who perhaps have only just joined the dive stream or haven't watched any of the previous ones, we're using a coring equipment called the vibrocore. This is slightly different to the push cores, which we sort of push into the surface and use sort of slight bit of suction to remove them. The vibrocore, we're using a vibrating bit of machinery, which as the core gets pushed in, it helps to liquefy the material around it, helping to preserve the stratigraphy or the layers inside the core tube. which means when we bring it out, hopefully things will be in pristine condition for us to study. So like Anka mentioned, we're looking at the tephra, which is sort of the volcanic material, looking if we can piece together the storyline of what's happened here, but we might also be looking at various different other processes which involve volcaniclastic material, so material that's been washed in by sort of landslides, lahars, which are volcanic mud flows, flood events.
Yeah, thanks, Kiris. I have no idea what you said because I'm looking at the screen and just seeing all these weird things. And weird and wonderful things. Another cucumber, another star thing, other spiky things. Yeah, lots of spiky things.
There's a lot of excitement building in the room now.
Some of the features are superficial.
Lots of like that one's moving. Doesn't look like it should be moving.
Like bumps on the seafloor, and that might be related.
Oh, it's a tadpole.
It's like deep seafloor.
I'm surprised at how much life we're seeing down at sort of this deep level. It's much more than I was expecting. I mean, I'm no biologist, but...
You've got to think that's Jurassic Park. Life finds a way.
Yeah, it looks a bit like a moonscape with all that fine sediment on top. And that is because we are quite deep, and this is where the fine pelagic sediment gets deposited, the fine-grained clay-sized material that gets transported across the ocean either through turbidity currents, and this is the distal runout of them, or we can also get sediment input from the atmosphere through volcanic eruptions, for example, which is what we're looking for, or dust that is blown into the air and that slowly settles. It takes quite a while to reach the bottom of the ocean. So we're expecting a lot of different layers, hopefully, when we get to see our push cores or get our vibro cores up. Whereas when we get closer to shore, where we've taken our last lot of samples, you've got a lot of sediment coming in from the coastline through our river systems. So you get a lot more coarser sediment there because it's close to their source, and a lot thicker deposits as well. So when you're going down a meter, you're only seeing sort of the last few hundred years potentially. Now that we're further away from the coast and we've got this fine-grained sediment settling, with a meter we probably get down a few thousand years, I'm not sure. Hopefully we get a nice course so we can get an idea of how far we get back in time.
Yeah, and so one of the main parts of this expedition is for us to try and understand sediment pathways. So we're calling it source to sink, so the source of which they're coming from, so that's from the land, the volcanoes, and the processes, but then understanding where they finally end up. So this is why we're at this more distal location today. We're wanting to understand across, as we move away from the coastline into various different basins and different parts of the seafloor, whether that's sort of much lower and flatter or there's more topography going on. And we want to understand what are the processes moving these sediments around and how can we use these to start piecing together the geological history of the area, particularly with the relationship to the local volcanoes, but also the last glaciation.
Yeah, and it's possible that these further distal sites as well will have a lower sedimentation rate. So we might have a deeper record as well that are preserved. So we might have more tephra layers, maybe less tephra layers if they haven't reached as far. We really don't know. It's completely unknown what we'll find. First step is trying to recover as much material as possible in these vibrocores, and next step is then trying to piece it together after that. So a whole bunch of things. Oh, just seeing, looks like a football on the seafloor. Oh, it's a bobble from a hat. Yeah. It's a pom pom. It's like one of those.
Very scientific, Alistair.
It's like one of those light up things that you get when you go to firework displays, and they're like, They just end up in landfill, polluting the environment, but...
It's when we find out it's actually one of those.
Could be. So, loads of things on the seafloor here. Not many fish, though. Haven't seen Finding Nemo yet. Don't know what water depth Finding Nemo is set in, do you?
I think a bit shallower than this.
A bit shallower, yeah. Well, yeah, he does make it into a fish tank halfway through the film or something, doesn't he? So if that's a spoiler for anybody watching.
So, Alistair, there is some comments in the chat about an ongoing debate about how you pronounce the word anemone. How would you pronounce it?
pass this to Anke.
I got taught anemone, but in German it would just be anemone. But yeah, same thing.
Yeah, I would say an enemy.
It's quite a tricky one to say though.
Yeah, say it 5
took me a
times.
while. And then anything else in the chat, Kiris?
No, not yet. If anybody wants to submit any questions, we're happy to work through them. We've got a bit of time before we start our next site.
They don't have to be sensible questions either. Anything about
Yeah,
the
anything from the
spiky things we're
science to
seeing.
life on board a research ship to what we get up to day to day.
Yeah.
The other day we spoke about the different flavours of ice creams we've had.
There's a fish there, yeah. So the chief scientist is shouting out, "There's a fish."
Fish,
Oh,
fish,
that's
fish.
cool. Oh, a little
Yeah.
octopus.
Little octopus, maybe. Yeah.
Very cool.
Wow, fish.
Another pick of
I would
the
never
sea.
have expected to see fish in the sea.
Groundbreaking
So
discoveries.
You get an idea of the relative importance of volcanism with respect to seeing
Yeah.
an octopus on a screen?
Exactly. Yeah.
So you know your place.
Yes, I got told by my colleagues in Aotearoa, New Zealand, to look out for some of our ashes produced by our big super eruptions over the last million years. I'm not sure we're going to get quite that far down, but yeah, shout out to anybody who might be listening from down under, Australia, New Zealand. Might be a bit early in the morning there. And also a big Hallo nach Deutschland, falls jemand von dort zuhört. Yeah. Do you want to say hello to your mates? Have you got any mates, Alistair?
No, Alice has not got
no.
any friends.
No friends. No, not at all. But hopefully I've got some that are listening now. So yeah, maybe we can add one or two. But yeah, my wife sometimes watches this, so hello to my wife, my parents as well. Don't know about my brother. He hasn't really said anything. I've sent it to him, but I haven't got a response. So, but yeah, hello in English. Yeah, that's about the only language I can speak.
How about
Say
you do it
hola.
in a Scottish accent,
Hello.
being that you're now based in
So,
Edinburgh?
yeah. Hello there, my fellow Scots. Can you hear me? My name's Alistair. Alright, I'll pass this on to Kiris now.
I've already said my hellos. I don't think I've got anyone listening right now.
Ah. Hallo nach Hannover.
Hallo, ja. Skipper? Ja. Skipper kann das sein.
So we've got a question about is how long is our current trip? How many dives have we done? So we've been on board the RV Falcor 2 since the 2nd of September. We left port on the 3rd. So we left from Portimont. And then we'll be getting into our end destination on the 23rd, and we disembark the boat on the 24th. So however many days that is. Just shy of 4 weeks, I believe.
Yeah, and I think this is station 27. Is it, Alistair? Yeah, so we've named our stations where we stopped to take samples, and in some cases that was our vibrocore samples, where we push the core in through vibrations, or our shorter push cores. We've also taken some grab samples where we just lowered sort of a digger.
Yeah.
I don't know how to describe it. A scoop, yeah, a scoop down over the side of the boat and just grab whatever came up. So a lot of sediment, some creatures came up through that.
And then we've also done a gravity core. So this is where we lower a core barrel, sort of similar to how the vibrocore looks, but it's got sort of a pointier nose on the end, and we use sort of the velocity of weight, so the gravity, to push the core nose and capture into the sediment. But yeah, we've only done one of those so far. We need the right conditions to be able to do it. We need sort of the seas not to be too rough, but also for the sediment to not be containing anything sort of too large, hard and rocky, otherwise we won't get the penetration we need.
Yeah, talking about rough seas, it's been a bit different here. We've been in quite a sheltered bay around Portimont and Chaiten so far. Never had to really secure anything in the lab until we got hit by some swells yesterday, and all of a sudden there was panic, and let's get the microscope fixed. A lot of banging happening at night, waking us up, drawers opening and closing.
Yeah, I think
bottles
Alistair was unlucky
rolling.
enough to not secure his belongings in his cabin, so they went flying across the room about 5 a.m. this morning, and me and Anchor on the other side all could hear it.
Yeah, so the walls are quite thin, so I think everybody heard it. But yeah, everything flew off the table. Thankfully, we share cabins, and I'm on the top bunk. So my cabin mate, Ivan, senior patrol, also a volcanologist, he had to pick them all up. And I had the excuse of not wanting to climb down the ladder as another added risk in this rocky weather. So.
Yeah, not quite as organised as me and my cellmate, Kiris.
Yeah, me and Anchor sharing a room.
Well, I wouldn't say that because we have cabin inspections once a week, and we just won the top prize as well for cabin inspections, which people aren't believing. They're thinking that we stole the prize thing because it's just a little sticker on your door, but we didn't. We did win it.
Yeah, we're getting to the bottom of it. Yeah. I don't think so.
It wasn't any probes, no.
Speak of the devil, Ivan has just walked in.
Come say hi.
We're here to help you.
Thank you.
Go and join Kiris.
Yeah.
Got number 4 of Team Volcano show up.
Yeah, we've got a bit of a volcanology takeover. Ivan, do you want to come say hello?
I will talk in Spanish.
In English.
In English?
Yeah.
Okay, Ivan's going to speak in Spanish and English, probably.
If Danny asks me to talk in English, I will talk in English. Yeah, so hello everybody. I am Ivan Suñer Puchol, the cabin mate of Alistair, and yes, this night, past night at 6 a.m., everything fall from the table because the sea now is rocky. It's moving a lot, and I'm feeling a little bit seasick, but still here. And yeah, today is a quite different day than the others. We are in 3,400 meters deep, seeing a lot of strange animals.
They are pretty strange.
Yeah, today we are far from the volcanoes.
Brilliant.
Yeah, this is one of our favourites, the sea pig.
Sea pig, yeah.
Very interesting creature.
Doesn't look much like a pig.
Yeah, you Google it and you can see some similarities.
Yeah. One of the top pictures that comes though is just some pigs swimming in water, so don't get confused by that.
How much further? Scott?
Just going for a Sunday drive.
600 meters.
So I think we'll be arriving at our next waypoint at around 4, so 45 minutes or so. But if we do see anything interesting along the way, we'll stop off there.
Anything in the chat?
Any more questions from anybody? I used to have good eyesight. I could read that back in the day, but I can't.
Getting old at Dr. Ali.
So they've asked if it's possible if we could zoom out on the camera that's showing on the live stream a little bit so they can see more of the seafloor and less of the equipment.
I don't have those powers. I don't. I think that might be a no.
Yeah.
It's just going to be like, I can't read it. It says, I was going to make a comment about there being enough cucumbers to make this sandwich. It will be sediment, which
Yeah, I got a big laugh from the room.
Yeah, keep them coming.
Yeah.
The days can be quite long here, so we're looking for any forms of entertainment.
Yeah, and we've got Zach here. He likes playing pranks, putting googly eyes on everything. They give you a fright when you're not expecting them.
My favourite was the little bit at the end of the tap that made the water shoot up at you rather than down the sink.
Yeah, that was a bit mean. Got 6 of us.
Yeah, including the chief scientist.
Yeah, so we've got an awesome crew here. Had really good get-togethers. Yeah. Yeah, we've got some favourites, eh, Scott?
Oh, he's happy now. Look at that. What's going on? Just saying your FAs.
Yeah. Scott and Zach are looking after the ROV today. Yeah. Getting us to the right spots, operating the equipment.
Pete, though, the captain, not a fan. Not a fan.
Don't say that. He's going to kick you off.
Yeah.
So Alistair, we've just had another comment as well about, so what I'm hearing is more puns. So a few of you have picked up on that. Me and Alistair have been playing a game when we come on to see how many puns we can fit in. I think we've been found out.
Oh, look at that.
Oh, what's this?
Is it raining forums?
Yeah, so there are some googly eyes on the ROV itself. I'm not sure if you can see them, but I think when we show the angle from vibrocoring, you can just about see the googly eyes. So now we're actually seeing an octopus right sort of in the lower centre part of the screen.
Okay, so Mane's sitting next to me. And Mane knows a lot about forearms, right?
Well,
You know more than I do, right? So
yeah, maybe.
I was told earlier we saw a forearm colony.
Yes.
Right. How do they make this forearm colony when they've many arms and hands and feet? And all
That is an amazing question to which I have absolutely no idea. That was actually the first time I saw a foraminifera colony. So it's called, well, I don't know what the pronunciation here is, but Xenophiophora.
Yeah, sounds better.
Yeah, Xenophiophora in Spanish.
Yeah, they're actually my favourites.
Yeah, really? Anke was just lying about it.
But I think I saw one of them in one of the grab samples, and it was really pretty. It really stood out. It was quite big.
In the push course.
And now in one of the grape samples where the stuff fell out of the push core and we scooped it up. Oh, not grape sample. We scooped it up.
Oh,
and
right
we looked
now?
at the different components, and that was one of them in there.
Oh, really? Today?
No, a few days ago.
This is interesting because it says that this foraminifera colony used to be about great depths.
Okay,
And
maybe
they're
it was
very
a
fragile and-
shallow water brother. or
Yeah,
sister.
might be, because they have been very understudied actually. So there isn't much research done on them because they're very fragile and kind of like hard to get out of the abyssal depths. So it's gonna be very cool once we get this push course out and have a look at them. Yeah, the biologists were equally amazed.
Yeah, we're still waiting for our big, long 2-meter vibrocore. So we've been excited. And
Today may be the day, Anke.
Yeah.
It may be the day.
Been looking forward to this day for a few days now. And yeah. I mean, we did find a few volcanic ash layers. Won't call them tephras because that would imply they are more of a fallout or primary product. So we just stuck to the componentry. They're mostly consisting of fine glassy volcanic particles, volcanic ash particles. And we think some of them might be fallout that were deposited on the ocean floor. Others might have come in through lahars from Chaitan volcano. So if you've got a big explosive explosive eruption, producing a lot of fine-grained ash or coarser-grained pumiceous material that gets deposited on the landscape, and then you add a bit of water, and then these loose sediments will get redeposited. They will get mobilized and transported along the fluvial river systems. In the case of Chaitan, the river is quite a short way away from the ocean, so it transported a lot of the fresh material into the ocean, and it built up a very big delta of what we call volcaniclastic material.
Yeah, and part of what we're doing here on board is once we collect these cores, we bring them up to the surface, we split them open, and that's where we do our subsampling. So we subsample to sort of take a closer look, and so for us volcanologists, we're looking at those layers that we're assuming to be tephra, so volcanic material, but also some of the more volcaniclastic things. And by zooming in on these, doing some further analysis, when we get back to land, we start to tell us more about the processes in which they got there, where they maybe have come from. So we're hoping to be able to pinpoint some of the different volcanic origins, and the processes moving them in.
Yeah, and I guess we just don't really know much about these processes in marine environments. We studied lahars and volcanic eruptions a lot on land, and we still learn new things every time. Every time there's an eruption, we learn new processes. We have really seminal eruptions in sort of historic times, like the 1980 eruption from Mount St Helens was the first time we sort of documented these large-scale collapses at volcanoes. Mount Unzen in Japan was one of the first times that we saw pyroclastic density currents in these pyroclastic flows, that they had a top part of the flow which was finer and lofted over the edge. Fortunately, resulted in the death of around 43 people, and the volcanologists that were there as well at the time. We learn new processes all the time, every eruption that happens. So being able to study the marine environment and look at eruptions, which we know a lot about already, and studying on-land processes.
So Alistair, we've actually had a question come through on the chat. So that question is, what type of plate boundary is causing the volcanism here?
So here we are on the Pacific Ring of Fire. We are at
Johnny Cash song, that isn't it?
That's it. Basically on the other side of the Ring of Fire, where I'm normally based, which is in New Zealand, it extends all the way around Asia, across Alaska and the US down to southern Chile. So we are at the subduction zone, not a hot spot. We've got the Pacific plate dipping under is it the Chilean plate? Nazca. It's still Nazca. Yeah, the Nazca plate. So we've got the heavier oceanic crust from the Pacific plate getting pushed under the lighter continental crust of the Nazca plate, and this helped form the Andes, and also as the sediment goes deep down into the mantle and there's fluids coming out, that will help reduce the melting points, and we get a bit of magma generated. And we've got a lot of volcanoes here. They're also associated with some of the bigger fault systems we see here, and lots of beautiful volcanoes. Different types of volcanoes here. We've got andesite stratovolcanoes. They're actually named after the Andes. It's a specific medium composition of magmas, building our big mountain volcanoes like Mount St Helens, or the ones I study in New Zealand, Mount Taranaki, my favorite volcano. We've also got a few more basaltic cinder cones that we've seen, smaller cones that also occur in the Eifel, where I'm from, and then all the way to our more explosive eruptions, where we've got a very sticky, very high silica magma, lots of gases, and as they come up in larger volumes, we see these big explosive, what we call Plinian eruptions, after what Plinius the Younger described at the eruption of Vesuvius in AD 79, producing a large volcanic eruption cloud, from where we then get tephra and pumice deposits deposited that fall out from that eruption cloud. Or as the eruption cloud becomes unstable, we get the development of pyroclastic flows that travel really fast along the landscape. So some of the most dangerous processes we get at volcanoes.
So in the
what
sort of,
Anka's been touching on there is about the. Sorry, did I just?
yeah, Alistair just cut me off. So rude,
It's
so
hard for
rude.
me to hear because I haven't got the headphones on. So
Good excuse.
Good excuse. I don't know what I was going to say.
Well, I was just going to talk a little bit about how these sort of systems have produced really dramatic landscapes here along the coastline of Chile. You've sort of got towering mountains and volcanoes mixed together due to the volcanism, but also the orogeny that's formed the mountain chains, the Andes. But then you've also got the interaction with glaciers, so you carve out these really steep-sided valleys to create really flat topography that these rivers cut through and lead out towards the seas.
Cool. So I've just oh, this is really difficult. I've just found out that I've been speaking to the microphone but from the back. So apparently, you probably can't really hear me. She's probably all the best news for everybody at home. I don't know what Kerry's just said because I can't hear her from the other side of the room. But I was going to talk about silica in eruptions. So Anka was touching on different types of eruptions, the explosivity of eruptions, and this is generally driven by silica, not always. There's volatiles and water contents as well in magmas, which drives this. But silica is a really kind of main factor. So if it's got a low silica content, which is still around about 50% of the magma as a whole, that's what produces these sticky, runny magmas, which are generally low volume. The hazards are lower. They're generally lava flows which are produced. They're not as explosive. Whereas as you go up in terms of silica content, and you get to higher silica contents, around about 70 to 80% weight percent of that magma, that's when these become really, really sticky, and they fragment a lot, and they produce these large Plinian ash columns. So this rock type is the more silica-rich type we refer to as a rhyolite. And Chaiten is the only rhyolitic volcano that we know about, the only volcano that's produced rhyolitic eruptions in southern Chile, apart from Puero Cordencalier or Cawie. I can't pronounce it.
Tricky word to say.
Tricky words to say. Which also erupted. That was 2012? Erupted. Somebody can fact check that. I think it's 2012. It was around about then. So it's quite a clear, distinctive layer essentially when we're looking for this in the core, because it really stands out. It's this really white, pale,
so when we
grey
say
layer, which is indicative of this high silica content.
So when we say rhyolitic, it means it's got a different composition, which creates it's containing these lighter minerals, which is giving this much lighter sort of colour to it. Whereas if we were seeing something perhaps more mafic, more basaltic, we'd be expecting to see darker. So it's helping us do sort of our preliminary identification of what these layers are.
And ultimately, we're going to take the samples to the lab where we can actually analyze the composition. And typically, different volcanoes have different fingerprints, we call that, different compositions of major and minor elements. And even different eruptions from the same volcano might have slightly different compositions depending on how the magma ascended through the mantle and crust. So we've seen our deposits, we can say that they are rhyolitic, and we found some at various depths. So we assume the ones we see at the very surface or within the top 20 centimeters are from the Chaiten 2008 eruption, because that's the closest source. But we've also seen some deeper ones, and we think there might be an older eruption. So this has been one of our really exciting finds, I think. But we have to confirm in the lab. We have to do some analyses, shooting X-rays on those little glass shards to give up their secrets. And we've also found some more basaltic tephras or ash in the air. Sometimes it's mixed up with the other detritus that you can find in the air, so it must have been just washed in rather than fallen on top of the ocean. I think geochemistry will help us identify where they're from. And eventually we also want to do a bit of a field survey in the area to see what we can find, and ground truth, some of the stratigraphy or the different types of layers that we're seeing in our ocean cores. see what components of our sediment come from which areas, because we've looked at quite a few different river systems that have different sources. And also at a fjord further north where we started, which is near Kalbuka volcano that erupted in 2015?
2015.
Yeah. So, yeah, a few different things left to do when we get home. I think that's when the real work starts.
Yeah. Are there any more questions in the chat? Or
And they could hear you just fine.
oh, they could hear. Oh, brilliant! That's great. I'm very sorry that you could hear me just fine.
Yeah, we've had no further questions just yet.
Keep them coming. Keep them coming. Yeah.
There was something about funding, so I don't know if Sophia wants to talk
Funding?
about that. No. Where the funding comes from. Sure. Talk a bit
Yeah.
about SOI.
Yeah.
Turn off my speech jammer. You guys can hear me fine. Yeah?
Yep.
Okay. So, this is Sophie. I'm the multimedia technician. I am behind the scenes for these streams and ship to shores and other outreach activities on board. And I can talk a little bit about the funding. So, we are a philanthropic nonprofit organization. And so, we are funded by the Eric and Wendy Schmidt Family Foundation. So that's where our funding comes from. It's a very simple answer, actually. So, and my microphone's moving around. Okay, back to you guys.
Cool.
Let me know if you have any more questions. Say goodbye.
Yeah, so we're still just transiting to our next site, just looking at what we see on the seafloor as we go.
Yeah, there's more cucumbers.
Definitely going to be able to make that sandwich.
Yeah, a lot of cucumber sandwiches. Yeah. She's cut the crisps off as well, make it very posh.
But Alistair, do you not want your hair to go curly?
My hair's already curly.
Is that what happens when you eat crisp sandwiches?
Yeah, that's like an old wives' tale that's told in the UK to make children eat their crusts.
Yeah. I didn't really eat my crisps as a child, so...
I always did.
Yeah.
Didn't help.
Didn't help.
Doesn't work with German breed.
Another starfish, another starfish, two starfish. Starfishes, is that the correct term?
So why do you say starfish or sea star? Is it the same in different English-speaking countries, or do you have a...
I don't know.
Because it's
You're
Seestern in
asking,
German, it's
asking the
sea
wrong guy.
star, but-
Yeah, I don't know. Starfish, sea star, yeah, I guess they're the same thing. I don't know, maybe they are different.
There's a famous paper, Christmas in 1929 or
Ooh.
1931, that says that starfish is not a fish.
It's not a fish.
right.
Okay, so sea star. We've just been learning sea star is the correct term because it is not a fish.
I guess that's like seagull. There isn't a seagull, there's only a herring gull. But a seagull is just a colloquial term that everybody uses. So.
That's just
Well,
English.
Well, you've been using seagull quite a lot. So I've got all
Yeah.
the seagulls. You know,
Because
it's been
that's-
niggling at me, so I just wanted to get that out there.
That's what
It's a
I've been
passive
taught,
aggressive
you know.
one.
I'm not a native English speaker, so to me they're all
Yeah.
mover.
Catfish isn't a cat. A catfish isn't a cat.
Catfish. Yeah. Yeah. So we call them Wels. So we don't have a catfish in German either. So it's just the English speakers confusing us.
And we have 3 vibrocore left. So we do 2 here.
So we probably approaching our site quite shortly, hopefully.
See where we're at tonight. We're just having some discussions in the room about what we're going to be doing next. So I think we might be considering stopping at a point near here, possibly deploying 2 of our vibrocores. We're also having a changeover of our drivers of the ROV. So because this is such a long drive, or dive, I should say.
Does this mean I get to drive?
I'd rather not.
I don't know. I mean, it looks really fun. I'd love to give it a go.
You could try bribing again, you know, like you did for your cabin inspection.
I didn't do that. I didn't do that. It's just flies, isn't it? Jealousy. Oh yeah.
Here
so
we
all
are.
these I don't know, like bits that are floating in the water, I guess.
Forams.
They're forams, little tiny shells, they're organisms. It's life. It's actually living dust, essentially, is how I would describe it.
Maybe Manu should tell us.
Yeah, tell us more about the forams, Manu.
Forams
Yeah,
are.
they're brilliant
And what we
things.
can do with them, how they help us with
Yeah.
climate reconstruction.
Yeah, exactly.
Depositional environments.
Your favourite foram, obviously ammonia Beccari, probably. Yeah, it's the only one I know. Tell us about forams.
Yeah.
Okay. We're about to core and I have to log, so...
Just quickly.
Okay, very quickly. About forams. So forams are protists, and we've been talking in the chat a little bit about them. They build their tests out of, well, we have two types of forams. One that are arenaceous, and they like building their tests with sediments, so they agglutinate the sediments with calcite. And then we have other types of forams, which are completely made out of calcite. Those are the ones I like the most. And yeah, we do paleoenvironmental reconstructions with them. We measure different elements in their tests, for example, magnesium and calcium. We can also do isotopes, and we use this data as a proxy. We were talking about that today in the morning with Dr. Totten. And what we do is reconstruct, for example, salinity in the ocean, temperature as well, and ice volume. I have a whisperer behind me. Ice volume. So yeah, we can get a lot of information from foraminifera. And my favorite foram, that's a good question. I'm not sure. I can maybe answer that question after looking at all the samples. But we really do like Polyminia aculeata. Yes. We all like it. We like the name. And we also like that foraminifera because it's closely related to circumpolar deep water in Antarctica. And yeah, we're always, well, not always happy when it appears, but it's a strong indicator of circumpolar deep water, which is something we're very interested in. So yeah, that's more or less all I can tell about forams.
Thanks, Manu. So we've had some questions come through. The first of which is which ROV is currently on the dive stream. So this is ROV Sebastian, named to be accordingly with the RV Falcor 2, which all relates to the book and the film The Never Ending Story. It's a German origin, so Anka, maybe you can
tell us more
a bit more about the film and the book.
I'm not best placed for this.
Yeah, Alistair didn't quite enjoy the movie. We had a movie night the other day because we've got a nice little cinema here with a big screen that unfortunately we haven't been able to use as much as we hoped because we've just been too busy with the samples. But the other night we had a Never Ending Story movie screening, two actually. One for the earlier shift, one for the later shift. And yeah, I quite enjoyed watching it. It brought back childhood memories. I grew up with it, read the books, had audio tapes, and yeah.
Yeah, just to interrupt Anka, we've just started vibrocoring, so the core tube is into the seafloor, and we're starting to use the vibrations.
So just for our German listeners, Falco, the name of the ship, or Falco 2, is Fuchur, which is the luck dragon out of the Never Ending Story. And the submarine is called Sebastian because Bastian is the boy who reads the Never Ending Story. And yeah, again, I don't know if you've seen it, but the scene where Atreo tries to pull Artax out of the swamps of sadness was just, brought all that childhood drama back.
We've also been quite enjoying have the ROV Sebastian because our chief scientist's name is Sebastian. So you know, made especially for him.
He's also yellow. Bright yellow. He's got two big arms out to his claws. Likes to grab
you talk
things.
about Sebastian, not Sebastian.
Oh,
right?
yeah. No, just getting confused.
Easy mistake, Alistair.
Yeah. Well, we are in Simpson Canyon today, so there is a bit of a link there. It's good. Yeah.
It was first discovered by Homer Simpson.
Isn't it because it's like the Homer Deep?
Becky, I didn't. No, that was all right. That was good.
Who brought their saxophone? That's what I want to know, because I brought my skateboard. Donuts?
Silence in the room.
Saxophone in the room.
I think the American humour here and the British humour is
I don't even
clashing.
think it's American humor. I think it's dad. It's Dad. Scott is the only one who laughs at my jokes. That's why we're besties.
He's just too polite.
Oh, he's got a big wad of dollars in his back pocket as well. I wonder where that came from.
Look, we've got Dream Team back.
I'm realizing he's not laughing at my jokes. He's laughing at me trying to make jokes.
Yeah.
He's laughing at me.
That's more accurate. He's not laughing with you.
Yeah.
He's laughing at you.
Scott, see how it is.
But yeah, now I've got the Dream Team back. We've got Chris back steering the Viper core. Hopefully we're getting it. Is it going down?
Oh, but back to the Simpsons.
I think.
Okay. I should say
Southern Chile's named after it, so I'm guessing it's the same.
that when we got to the Simpson Canyon, it was just like the beginning of The Simpsons, because everybody ran in to sit on the couch in the mission control.
Yeah, well, exciting day for us.
Yeah, been crazy.
Yeah, so because we are so deep, it takes a long time to transit down to the seafloor. So there was a lot of anticipation building this morning. This is going to be our longest dive of the whole expedition. We've normally been averaging somewhere, I'd say, between 2 and 4 hours. I think this dive is expected to take possibly up to 11 hours.
Maybe even more, yeah.
So lucky you guys at home, you get to hear us for many more hours to come.
Yeah.
Was that a threat?
Yes, it was a threat.
Well, we've got the dream team here now, so I'm sure everybody's tuned in.
Either that or
Team Volcano.
a bunch of dysfunctional members of the Simpsons family.
Any more questions coming in?
We did have one about how we're connecting this live stream. How are we broadcasting
Through the
this?
internet.
Thank you,
That's how we're
Alistair.
connecting it,
Thank you.
through the internet.
I believe it's Starlink.
Starlink.
But I don't know, maybe...
Starlink.
Like, do you want to...
I thought you said Stalin there.
Is it Starlink?
We've got two systems. One is Starlink, the other one is VSAT. I don't know which one we have. I believe for VSAT at the moment, but we may divide it with Starlink. But there's two independent systems.
Okay, so we have two independent systems on board. One is Starlink and one is VSAT. Not entirely sure which
We're
one
not
we're
sure
using at the moment. We'll find out for another dive stream.
So I think the internet was quite a good answer there then. Yeah, so the internet. YouTube.
YouTube, did you say?
YouTube, yeah.
I think so. We're not just broadcasting on YouTube. We're also on Facebook and on Twitch. So you can tune in on any of those platforms.
I thought they were all owned by the same person, but I don't know.
And if you really liked Alistair's stories and jokes, you can watch it anytime afterwards on YouTube as well.
Yeah, I'm not sure he's realised he's going to be on the internet forever.
Well, there's enough things on the internet. I don't think people want to sit and tune in and listen to me all day. So maybe just me replaying it.
At least people have a choice.
It's all those new friends I've just acquired, isn't it? Right. Yeah, you can't really see anything at the moment. There's a lot of sediment that's being kicked up from this.
Yeah, so I think we're just waiting for it to settle.
We're going to move
Yeah.
the pipe a little bit to the sitting thing, so let's start over.
Is it track going for it? These more forearms. Don't. Bits. all gone very quiet, hasn't it? Mm. Have you seen The Never-Ending Story, Manet?
Yeah, I have.
Did you like it?
I loved it. I read
Okay.
the book.
It's just me that didn't like it then.
No, but
It's just-
mine is part German as well.
yeah.
Yeah, and I've read the books in German, and it's bad.
Read the books as well. I bet they went on for a
Because
while.
no.
Because it's a book about a book.
Never ending,
so it's kind
Alistair.
of like, yeah.
It's actually got a lot deeper meaning than what you might think.
Well, I'm a very superficial person. There's no depth to me.
Yeah, and I believe, I could be wrong with this, but this is why the ship is named the Falcor 2. So it's not spelled TWO like the number 2. It's 2 as in the next iteration. So the Falcor itself is also never ending.
Yeah.
Really?
That's deep. That's very deep. And we are very deep today. We are at 3,411 meters, which is pretty deep.
Yeah, I think the airtime's going to Alistair's head a little.
It's gone down to 1.77 degrees Celsius, so.
Very low oxygenation as well.
Yeah. Do you mind? It's still probably colder outside.
Well, it's been actually surprisingly warm in some of the areas that we caught. I thought, especially in the fjord area, which was quite deep. I think we did go down to about 400 meters.
Yeah, it was about
and
11
it was 11
degrees.
degrees. Yeah, I was expecting much colder water coming in there, feeding off the glaciers.
Warmer on the seafloor than it was air temperature above the sea surface, which was, I think, surprising for a lot of us.
Yeah.
So there we are. I think the Vibracore is being lowered back down to the seafloor.
Just so I can change with look on the over. What time you are thinking about starting to bring it up?
I think we're shooting for 1700.
That's good to know, because we're doing a lot of outreach on this boat, which is one of the aims of funding the ocean research. So it gets transferred to the public and inspire other people, or especially our kids, to go into the sciences and help us understand what's happening.
Yeah, so we had a really cool stat yesterday that this expedition has clocked the most numbers of ships ashore, which is connections we do with schools or local groups, sort of within South America but wider. So far we have achieved the most. I think that was 21 individual calls. But we also had a series of local schools from Chaiten and the surrounding islands come to visit the ship. We got to show them around our facilities, show them some of the science we're doing, and sort of really get to understand those who are living in the communities around Chaiten.
Yeah. I think that was a great day for everybody on board. We had 16 schools come and visit, and we had we had the mayor of Chaiten and some other officials, important people, I guess. But for us, the most important people were the children. I think that's passing on that knowledge to the next generation is the most key and important thing. What a profound.
I'm just going to take it away before you say something wrong there. Yeah, and we've also had these ship-to-shore events where we connected up to different school groups or different community groups, the Geological Society or outreach groups for an hour. They basically came on board through a video conference call for an hour, and we show them around the ship and talk about our work, show them the different stations, the bridge, the bio team, the geophysics. We're all in slightly different areas, quite next to each other, but slightly different groups of people, and also, of course, the volcano team and our course that we're looking at. So I'm doing one of the last ship to shores, I think, today. There might be another one tomorrow.
Yeah, we've got one tomorrow and another one on Friday.
Oh yeah, a couple more. So yeah, I'm connecting with my daughter's school in New Zealand this afternoon. Well, it's going to be 9 o'clock for them, and apparently the kids are all excited, prepared some questions, and yeah, we'll see what we can show them, and it's good to know that it's on the go, so I can take them to mission control and see what's happening here. Yeah, that's going to be good.
Yeah, Anka found out a fun stat earlier of how many beds are on board the RV Falcor.
I think if I remember right, it was 98. Was it 98 or 96? Yeah, but I mean, beds are not the only facility you need to accommodate that many people. There's also the kitchen, dining room, and of course, we're not discharging the water that we're using up into the ocean, so that has to be discharged at various ports. So you can only have so many people. I think I heard someone say we've got 67 on board at the moment, and I think that's a good crowd. So you can still find a quiet corner if you need it, get some fresh air, walk around the outside of the ship if it's not too rough, and go for a run around the helipad. We've also got a gym here on board, yeah, and an outdoor treadmill, and I've had really good intentions, but I haven't been there yet. It's just my first cruise, so everything's interesting. There's a lot of learning. You want to see what everybody does to understand how everything comes together in the end, how things are done. And I'm also doing the sort of first year lecture into marine geology, so I think I can make it a lot more interesting now, now that I've got this experience. And I think it's second year with surface processes. So I normally do the volcanic clastics, the land stuff, as well as the ocean stratification and marine geology. Just very briefly though, it's only an hour. But I'm gonna put my foot down, get an extra hour tutorial. I've been taking lots of photos and videos, so I can make it a bit more interesting. Yeah. No, it's really fascinating.
About the hydrothermal vents, maybe you can answer that. Like, we didn't know if there were hydrothermal vents or not, but since we were in a fault, like fracture zone, it could have been possible, but we haven't seen anything.
Yeah, so I guess, there's a question about hydrothermal vents. So, I mean, it's possible. Anything's kind of possible in terms of what we're discovering offshore here. I guess we've got a lot of sediment that's covering here. We've got these large polygenetic volcanoes which are on the land surface. I mean, myself and Keris were on a cruise last year on a German research vessel, and we were in the Mediterranean, and we were just below Sicily, and we were mapping out and trying to discover new underwater volcanoes. We found a few more. One of them's named after Matilda, who's on this cruise with us as one of the PIs. We also came across some hydrothermal vents as well. We could actively see some flares, which are in the water column on the data.
What was really cool was when we were bringing up samples, we actually sort of brought up some of the vents from these sort of hydrothermal vents, and they were sort of these cylindrical rocks that had sort of a hole going right way through them, so you could see where the hot fluids are percolating through. That's something I've never seen before. Very cool.
Perfect hole all the way through, exactly. I mean, I don't think many people have seen before, and it's really cool. And they've kind of got this core to them, and they've kind of grown outwards with sticking on the outside.
Yeah,
so
incorporating lots of the material that's around them, not just the minerals that they're precipitating.
Yeah, so a bit like a snowball, I guess. Things just stick to the outside, and they just grow outwards and outwards. So they were really cool to see. So I'm not sure we come across these here because we're not necessarily looking at any underwater edifices or any volcanoes which these would appear on. We're looking really at the sediments and basin infills. We're trying to get cores that are coming through the sediment so we can get as much material as possible to record this background sedimentation within these volcanic clastic and these volcanic tephra layers as well, which are preserved within, which give us an event that's essentially happened. Geological time is very slow. We have 4.5 billion years of geological history on this planet. And when we're looking at these upper sediments, we're only recording just the very, very, very surface of this material and the shortest point back in time. 2008 happened, less than a millisecond ago in terms of the history of our planet. So, we're looking at a really short time scale, I guess. For most people, looking back at hundreds of years or thousands of years, this seems like quite a long time. But for us geologists, this is this is absolutely nothing. So with these layers, we effectively have events. These volcanic layers are recorded as events, which we assume to be geologically instantaneous. It might be an eruption that lasted a couple of months or a couple of weeks or even days or hours. But the layer that's deposited there will be, considerably more rapid than the background sedimentation. So geologically, that's an instantaneous layer, which gives us a point in time if we can date that eruption and tie that into other sequences or on-land records, and allows us then to work out the rate between that event and another event and see what the background sedimentation is accumulating between those 2 points in time. How many millimetres per year or centimetres per year. I mean, it'd be a very high sedimentation rate, but normally we're dealing in terms of millimetres of year per layer of sediment, and you can have thousands and thousands of metres of sediment before you hit any rock. So it kind of tells you how much time we have recorded in these basins.
Yeah, so we're hoping to use a couple of different methods for dating these cores. It sort of depends what's in them. But if we find any sort of marine life that are in their life position, so when we say life position, they're preserved how they were living, not just sort of been washed into the area, we can use radiocarbon dating. We're also hoping to potentially do some isotope analysis alongside using the diatoms and the forearm assemblages to see if we can provide some constraints on the timings of these. So not only can we potentially pinpoint specific volcanic material from specific eruptions, but we can also look at understanding the sedimentation rate within the basins and the surrounding areas.
And the Vibra core is just coming out. I think it went in okay. Seb, they're going all right?
It got met quite a lot of resistance after a half metre.
Yeah, about half a metre.
It's not all the way.
We've got a few more shots though, haven't we?
We have, I think, yeah. Becky, what do you think? Do you want us to repeat right here or move a little bit?
I mean, it's stuck. I think we fly farther.
And talking about, sorry, Alistair, steal the microphone back. Talking about events, so one of the aims of this expedition is to look at the impacts of these events, volcanic events or other instantaneous events that bring sediment into the system. A lot of sediment is to look at how the marine environment might have been disturbed by that event, how long it takes for it to recover, and that's what our marine biologists are going to look at. They're going to look at the marine fauna and flora before the event and what happens after and how long it might take. That's where the dates come in as well.
Yeah, so we have a whole team of scientists on board. For anybody who's not watched this previously, I don't know how many there are of us, maybe 20...
25, I believe.
25 scientists, yeah.
26 maybe.
So most of our scientists are Chilean researchers, which is brilliant. We have people from Italy, from the UK, from New Zealand,
the US,
Spain, Malta, all over really, and the crew as well are really diverse as well in terms of where they're from, their backgrounds, which is really great. So we've got a really brilliant international team of
and
people.
everyone's sort of brought their own selective expertise, and we're working together as a team to sort of accomplish our goals of understanding these sediment pathways and the influence of both fire and ice through volcanism and glaciology.
Yeah, exactly.
So that Vibra core is now out, and we're just sort of securing it in the rack.
Should we just say we're going to move for 15 minutes, however far that is, stop, Vibra core, push kind of do another one?
You can just get a hint from the camera behind this as well, just how dark it is down here. We're obviously below any sort of areas where sunlight would penetrate, much below. So obviously all the lights are generated from our ROV for us to see things. I think we should have some party lights fitted to it though. I think we should have different colours and play some music. That'd be quite cool.
That'd be amazing.
Yeah, exactly. See cucumbers and
see them dance.
See them dance. Yeah, get some cucumber songs. Yeah.
However far we can get in 15 minutes. Stop.
So we're just in the room. We're just making some decisions on what to do next. And we're fitting one more Vibra core here. Have another attempt.
So hopefully we get to cut one open tonight.
Yeah, so that's what we're lots of the science is happening behind the scenes from what you guys see. When we get all these samples, there's a lot of work to get through and process them, sample them, describe them. We take slides from them as well, some smear slides to look at the components of these. So everything we do is kind of initial sort of first scientific pass, and then follow-up research will happen when we're all back at our respective universities and institutions and research organisations. We'll work on this all collaboratively. The international team has got the biologists, which can tell us a lot about the water today, can tell us a lot about the life and the fauna which are living here. We've got the microbiologists, which can tell us a lot more about the timing and the dating of sediments and the environments as well that have been generated in these points. So if we get a mix of freshwater things coming in as well, then we can see there's an influence of freshwater, for example. If we don't, we see really saline species, and that can give us indications on the past sort of conditions comparing to what we're seeing today in the sedimentological conditions. The volcanologists are obviously giving us insight in terms of we're kind of going through the eruptive processes. We're going through the timing of these events, comparing these to on-land records. Most of our work is done at volcanoes and is done around volcanoes. From cuttings that we see layers, road cuttings or cliff sections or anything around volcanoes, and then on the volcano itself. We can also do chemical analyses of these layers as well. We can fingerprint these, hopefully, to their sources. So we can, there's a lot of assumptions at this point, which is why we describe everything in a lot of detail. We make some very initial interpretations. But when we get further along and do more of the analysis, our interpretations change and grow based on the data we're getting. So we won't never say anything until we're confident.
Yeah, so just to interrupt you there, Alistair, we've just completed our first push core for this location. I think if we're looking closely, we might be able to see a bit of change in colour as it goes down the push core, suggesting that we might have a few layers in there. The reason why we do push cores is because when we're vibrocoring, we tend to lose those top few sort of 10-15 centimetres of the vibrocore. So the push core helps us capture that very top surface of the core, as well as the water sediment interface, which is really important for those who are looking at the sort of microbiology and sort of the interaction between these two sort of different realms. But yeah, it helps us to capture what we're missing in the vibrocores. So we're just trying to secure that, pop that away into its holder.
There's quite a few layers.
Yeah, I think this one will be very interesting.
Yeah, so these push cores as well don't really compact the sediment, so that's brilliant. We can kind of just basically take a nice tube into the upper portion of this and get a very high resolution of the most recent sediments.
We will also have to consider, because we're working at such a depth, normally when you're thinking about coring, you're concerned about things like compaction, so you're compacting the sediments, but we might actually have some expansion as well. So because we're at around 3,400 metres below the sea surface, the pressure that the water is exerting is much different than what we're experiencing up here in the atmosphere.
Karis, do you want to talk about the little experiment we've got going with the styrofoam cup?
Oh yeah, so to show sort of an example of what happens with the pressures, last night we decorated a polystyrene cup, so just like a normal cup that you would have a hot drink in. But what you do, if you put it onto something that's going down to the seafloor, so like the ROV, the pressure causes it to sink. So we're seeing how small we can make our cup go. Everyone signed it. A little bit of fun behind the scenes, but yeah. So because these sediments are under such pressure, as we bring them up towards the surface, we might actually see some expansion. So it's something we need to be mindful, sort of along with these other coring artifacts, so you can get channeling down the side, movement of both sediment and water. You might see some sort of deformation to some of the thin layering. So it's all something we have to bear in mind, be careful with. That's not to say, they're not useful, but it's just, yeah.
Yeah, it's the same for the biology as well. So to make it a little bit more more scary. So the blobfish is is it doesn't actually look like that when it's down. Well, look like it's the blobfish. Do you know the blobfish? No. Okay, everyone Google blobfish and you'll see what I'm on about. It's quite an ugly fish. It looks like a big blob, and with a face. Yeah, when it's down in its natural habitat, it looks like a regular fish. But the pressure and the deformation from bringing it up to the surface is what gives it that blobby texture. So I think it was dubbed one of the most ugliest animals on Earth or something, which is a bit harsh, really, when it's mostly depressurizing this poor fish that's related to it. I mean, I'm sure if it depressurized me, I'd probably, well, maybe it'd be an improvement, I don't know.
I was going to say, you definitely don't want to be going down to those levels, Alistair. There's a reason we send the ROV down and not you.
Yeah, I used to scuba dive when I was a bit younger, and was part of a dive club in Germany, and we did this experiment where we went into the compression chamber, and we went down to 50 meters basically in a controlled environment. We took a few games with us, played some games, and you could feel the pressure increasing with time, and so they stopped and said, "Oh, how far do you think you've gone?" And we were like, "Oh, that's at least 10-15 meters." It was 50 centimeters. Because over the first meter, the pressure doubles. So you already feel the pressure on your ears then. And I mean, at 50 meters, you start to get a bit of the nitrogen toxicity happening. So you start to get a bit silly, feel a bit lightheaded.
Is that what they call the bends?
The what?
The bends?
The bends?
Like bending.
I've
heard that's what divers call it, sort of nitrogen.
Yeah, so if you go deeper, just like with a bottle of Coke, if you open it, you depressurize it, so the bubbles start to actually dissolve and come up. But if you put pressure on something, it gets dissolved. So you get a bit more little creature there. Jelly. You start to get a bit more nitrogen in your blood, and N2 is a narcotic as a gas. So you start to get a bit silly, a bit giggly, and then of course that gets worse when you start talking, because for anybody who's done the childhood prank with a helium balloon, you sound like Mickey Mouse. So under pressure you sound like Mickey Mouse, and then you get the nitrogen on top, and then of course you slowly go up in stages to make the nitrogen come out gradually out of your blood, because if you go up too quickly you form these bigger bubbles and they can block your arteries and you can actually die. So don't laugh. You have to take it easy.
Human biology lesson, yeah.
Yeah, so we've just had in the chat the organism that went past. Someone's asked, is it a centiphore? I think I'm saying that right. We've just had the thumbs up from our biologist. You are in fact right.
Yes.
Centiphore?
Yeah, sounds about right. Yep. Centiphore.
Centiphore?
No, 57. No, it
54.
was Cotta. It was 50, not 57. So, and we didn't stay for very long. I think we stayed for a couple of minutes. I think the deepest I've actually done was 44 meters, and that was scary. I wouldn't want to do that again. That was just going down to look under a rock where there were a few catfish in the Mediterranean. Wasn't even worth it. I prefer the upper 15 to 20 meters, where you still get some light and some colors and lots of life and reefs. It's amazing.
Thank you.
I would quite like to see some glowing things in the twilight zone though. I was looking earlier when we were passing that, but I didn't see anything.
Now you've got to explain what the twilight zone is.
Twilight zone? Well,
it's the zone between 300 to 600 meters where light doesn't penetrate into the water as much, but you still get a little bit of light. So kind of like twilight. You've got different organisms living there. We got told by one of our biologists that that's where the animals live that glow in the dark, or sort of like anglerfish that still use light to attract their prey. So yeah, we've got to keep an eye on that when we're going up. I think I missed it on the way down.
Twilight zone is a layer of the ocean spanning across the whole of Earth. beginning at 200 meters below the surface and ending at 1 kilometers down, where the pressure would be equivalent to 10 elephants standing on your head.
Wow.
There we go. Thank you, Google.
10 elephants.
10 elephants. I mean, I can't verify that this is correct. I don't know what my source is.
This makes me puzzled how the sea cucumbers survive at the bottom.
Sea cucumbers, Seb, are very, very strong.
Probably if you take them
the
out,
strongest animal in the animal kingdom. So I hear. They've got a thick skin, so you can insult them as much as you like.
You can poke them as well.
You can poke them.
That's what we used to do as kids. Going on holiday down to Croatia, diving down 3 meters just to poke a sea cucumber and see how it put out the sand. It was okay. It recovered.
It did? Okay.
Yeah, just a little
Emotionally?
bit. Not
Or
taking it
just
out.
physically?
Physically.
Are there more questions?
No more questions just yet.
So you haven't done your shout out yet, have you, Keris? Is he still there?
No, hopefully not.
Manny, have you got anyone to shout out for?
Yeah, your mum was just there before.
Is your mum still watching?
Say hi.
Oh.
Hi to Manny's mum. Manny, say hi.
Hello.
Hola, Mama. Hello. In case you're there, I don't know if she's still there. You know, my mom became one of like the main followers of SOI Divestreams.
Yeah.
So she's been telling me that she's been watching all of the dive streams.
Wow.
Like even from other expeditions. She's
0.4.
been just playing those in
Yeah.
bed, just like watching.
It's very calming.
seafloor. Yeah.
Yeah, I've heard it's quite nice background noise. I've
Yeah.
had a few friends
Apart from
tell me.
Alistair's talking, maybe.
Maybe,
Yeah.
maybe.
Just a really annoying nattering in the corner of the room.
Maybe like white noise or brown noise, like maybe it's like that.
I don't know who this other Alistair is that I've met, but there's 67 people on board. There might be another one. So.
Oh, well, by the way, interesting fact. Did you guys get to see the whales?
No.
No, we didn't see the
We
whales.
saw the video.
Yeah.
We saw the
You're
video
too
of the
late.
whales, but
We believe those were humpback?
humpback
Okay.
whales.
Oh, cool.
So some of the people on board saw humpback whales, and some of us didn't.
We're not sure if they
I'm not
were-
bitter. I'm not angry. I'm not upset. Just disappointed.
But we did see the penguins, Alistair.
Well, you say we saw the penguins. I mean, they were a very long way away.
Humboldt penguins.
Humboldt penguins, apparently.
Splashing in the
I
water.
mean, they
and we
just-
also saw the young seals having
I didn't
like
see
fun
those.
in the waves.
We also
I
believe we
didn't
saw
see the young
some
seals. I saw-
dolphins, and yesterday an albatross.
I've seen one dolphin. I've seen one big bird, which could have been an albatross, but I don't know.
I
Sounds
believe
very
Seb.
vague.
I believe his identification
Yeah.
skills.
You think
Have
it's
some
an
faith,
albatross?
Alistair.
What type of albatross?
Black brown albatross.
Black brown albatross.
Black browed.
Black. Oh, okay. Black browed. Browed.
He identified it based on the undercolour of its wings and beak.
Okay.
Well, an exceptional photo of it. If you'd like to see it.
I'd love to see the
Oh,
photo
yeah?
of it. Yeah.
Yeah. Taken on a Nokia
We're
brick.
just waiting for Seb to find this photograph.
Evidence.
Is it
we don't
grainy?
believe anything without evidence.
How close did it come to the ship?
It landed on his shoulder.
Ah, look at that.
Oh,
Wow.
Okay.
That's a beautiful.
Another
Wow.
10-4?
We're
Is
seeing
that
a
10-4?
a possible 10-4.
I don't know.
Nope.
Not a biologist.
Or a sea
Oh,
slug.
it's a woodly
Yeah,
thing.
get out.
Wow. Okay.
Probably once per year.
For everybody watching at home or at work or wherever you,
Oh, yeah.
hopefully not while driving,
Yeah, totally.
Seb is showing us a photograph of a
Of an
bird,
albatross.
and it's definitely a black-browed albatross.
Probably has to be one for the wildlife.
Yeah, it's going to get young wildlife competition. Yeah, young photographer of the year in wildlife.
That's a sea pig. What?
Yeah, it was very grainy. I don't know what it was. Oh, that's an even better one. You can see it's black and white. Although, Anke, you got a really good picture of a kingfisher, didn't you? the other day?
Yeah, that was really pretty. So
Yeah.
when the school kids came to visit, I got a chance to go on shore and have a look at the deposits there. So me and Javier, we went for a little walk along the river and along the beaches and collected some sediment samples there as a reference, so we can get an idea of what components are coming in from land, and so we can correlate them to what we find on the ocean floor. And yeah, that was really cool. We got to go to the museum and saw some of the houses that were buried in the Laha deposits, talked to a few locals and learn a bit more about the event.
So this is how Anka's justifying this, but I'm sure she went to a cafe and had a coffee.
No coffee.
No coffee, okay. Maybe something a little stronger than coffee.
I wish.
Maybe a beer or of some sort. Beer is in general term for drink, yeah. Not necessarily alcoholic.
Cerveza.
It was quite a short period of time, quite a heavy backpack full of rocks, and quite a quick walk. So we had 10 minutes at the end, so we did have a quick local beer, which had, sea cucumber. They're actually really elegant when they're float. Really nice to watch. Maybe I won't poke one anymore in the future. But yeah, it was with this berry, Mane, this local Chilean berry, the beer. Yeah, like a little blueberry type. So that was just, local cuisine testing and cooling down a bit.
Maki or...
Yeah, I'd like to have some berries without the beer as well. They were really tasty.
I've had the Patagonian tea that's on board. I guess that's probably got some of these berries in.
Patagonian tea?
Yeah, I don't know what's in it. It just tastes like fruit tea. But it says it's Patagonian fruit tea. So,
I might have had that.
yeah.
Alguien busca por el... a los jefes.
Where's that cucumber gone?
Find it.
So we've just landed at the next site and the dust is just sort of the sediment settling. So we disturb it each time we lower ourselves to the seafloor because it's made up of so much loose, fine-grained sediment.
Calafate. Oh yeah. Cerveza austral. Yeah, that's very good.
Okay, it's just getting really rocky on the ship at the moment.
Yeah.
Rocking from side to
It's,
side.
difficult to stand up sometimes when you've got such a role.
Okay, so
We have a
Connor's
curtain.
been giving us some good advice.
Sorry, Connor.
Yeah. To go up to the bridge, spend some time on the bridge in the next little while to see whales. Yeah. Be fun. So I got a bit distracted. What are we doing? Another vibrocore?
I think it's just about sediment, isn't it?
Yeah, so I was watching.
Okay, it's a sea cucumber factor.
Yeah. Now look at the track of the ROV. It's quite cool. On one of our screens.
Okay, so everybody that's really excited about sea cucumbers probably knows a lot more than I do. There's some interesting sea cucumber facts. So apparently there are over 1,200 species of sea cucumbers throughout the world. Don't know if that's correct. If anybody wants to let me know if that is, that'd be great. Probably the person who wrote it would be good. Sea cucumbers do not have a brain. Just seems a bit like an insult, really. Sea cucumbers are nocturnal. How do they know when it's night? I mean, there's no light.
They might have eyes.
Oh,
Or sensors.
I don't know, I don't believe that one. No, they're more active at night. The species can reproduce either by themselves or with a mate. That's pretty cool.
Interesting anecdote there. I actually once went to an art exhibition at a local geology museum to Birmingham, where they had some poets performing spoken word to sort of a background of footage of sea cucumbers mating. Sounds quite weird, but it was quite interesting.
Why?
Why was it interesting, or why did I go?
Why was this in the exhibition?
It was a collaboration between sort of science and art and how these can come together. So there was someone who was mixing sort of live music alongside the spoken word with the visuals of the really close-up, high-resolution footage of nudibranchs. So sea cucumbers.
Fascinating. Yeah. But David Attenborough would love that.
Yeah, right up his street.
Right up his alley, yeah. All right. Sea cucumbers are echinoderms.
Yes,
Yeah,
they are.
yeah.
Surprising.
There you go.
Yeah. They can swim.
Seb says it's surprising.
Yeah, they can swim. We saw them
We,
swim.
we just saw them swim, yeah.
Just saw them swim, yeah.
Also, they're not green. And a cucumber is normally green. Do you get green ones, Becky? Do you get green sea cucumbers?
Because
they seem quite red
I
and-
have seen a sea cucumber when I was in Belize in very shallow water
Okay.
on the seafloor, and it was kind of brownish, greenish.
Might have been ill though. Might not have been.
Yeah, I think they come in all sorts of shapes and colours, and they have all different frills, and that each one sort of. Some of them I think could be. No, I know some of them could be really vibrant colours. You get whites and pinks and bits of yellow on them.
Oh wow, that's not a sea cucumber, is it?
Oh yeah, any cucumber green.
How do you feel about sea apples?
Sea apple. Yeah. So Seb's just found an example of a sea apple. Well, it's a sea cucumber, but it looks like an apple. And we recently discovered that
You wouldn't
Seb
wanna bite
has a
into one of
phobia
those.
of apples. It's the crunch of the apple. Is that correct, Seb?
Oh yeah. What was that called against it?
What's do you want to talk a little bit about your phobia? See if anybody else out there has experienced similar. No? Okay. He's not ready to talk about it yet, but
Do you guys ask the ROV pilots this question? Are there any consumables in the ROV that limit the dive duration, like batteries?
No.
Sorry.
The only thing that would, assuming that nothing goes wrong with the ROV, the only two things that limit our time is weather and if there are any kind of collections that the scientists want that we need to go on. Other than that, we say that.
Do you want to summarize that, Kiris?
I think it was picked up on the
Yeah,
mic.
was it?
I could hear it in my headphones.
Okay.
I would add to that probably shift schedules is the other one.
Yeah, and so that's Becky just mentioned that the shift schedule is actually something that limits the ROV. So already today we've been down for quite a while and we've had several shift changes. So normally the shift patterns are a bit longer, but because they're having to focus and they're in control of a very expensive but very important piece of kit, we need to make sure everyone's refreshed and feeling happy.
Safety first.
Yeah, always safety's first.
Okay, so
but in terms of the time we go down, I think it can be down for a really long time. I think they said they can go for over 24 hours. That's because it's tethered to the ship.
If we're going to be doing, if we have an expectation that we'll be down for a long time, we have 8 people on board and need 24 hours.
So there's just been a request on the chat for me to talk a bit about Back to the Future from Andrew. I don't know who Andrew is. It might be my dad. He's called Andrew. So I don't know how anybody would know that I like Back to the Future, but yeah, I'm a Back to the Future fan. And it was much. It's better than Never-Ending Story, right?
It's different.
It's different. Come on, it's way better.
I've
It's
watched it like 100 times. Probably more than the Never-Ending Story.
Yeah. So, Back to the Future. Yeah. So, number 1 and 2, brilliant. Number 3, it's
Too much love story.
Yeah, and a bit sad when the DeLorean gets hit by the train. Yeah. Although I've kind of got over it, but I kind of feel sad every time.
Flying train, time machine train. It's pretty cool.
Exactly. But yeah.
It's like a different type of star, isn't it? Right below the arm. Oh, you cannot see it.
That anemone?
No, you can see it there. It's right now. It's below the arm. Oh yeah, that one. Is that?
Looks like a tarantula or
That's
something.
an anemone, I think.
Oh, that's
Anemone.
There
There you
There's a
go.
lot
Do you want
of
to talk about that, Anka?
Not really. I mean, I really like anemones actually because they're a fun thing you can see in like rock pools in the Wellington coast. We sometimes go. There's a little snorkel trail in the marine reserve, Island Bay. So you see a whole lot of different anemones. You even see wandering anemones that just attach themselves to the seaweed, and then you get the ones that sit on the rocks. Yeah, they look amazing. And I've just been over to the States as well, and we went to Astoria and Cannon Beach, where the Goonies were filmed. Don't know if you know, like the Goonies, seen the Goonies? Yep. And they have a lot of rock pools there that are always really busy on the weekend, and they've got volunteers there talking about what you can see there. And they had these really big green ones, and they were called giant green anemones. They were really vibrant colors, really amazing. And I got to see my first puffins on Haystack Rock as well. They were still there. That was really cool. But we were just there to show our student around some of the big debris avalanche deposits that are produced by volcano collapses. The most prominent example is Mount St. Helens in 1980 that really opened our eyes to such events happening. Before that, they were poorly understood. The deposits form a very hummocky terrain, mounds in the landscape. You can see that around New Zealand, Mount Shasta, Mount St. Helens, a lot of other places in the world. And it's been a mystery of how such a large amount of sediment got there. But it was basically either part of the flank or a large chunk of the edifice of a volcano collapsing away. So that's what I did my PhD on in Mount Taranaki. And that volcano's collapsed about 14 times at least in the last 200,000 years. And then after each collapse, it rebuilt itself, and then you get different types of mass flows being produced. Normally the proximal deposits, like the primary deposits, like lavas and tephras, ashfall deposits, you can't find because they're buried or they're carried away by the debris avalanches. But the Laha deposits pick up things along the way at the time, so you can get a good idea of what deposits and compositions were around at the time, and reconstruct the volcanic history, and also with a view towards volcanic hazards and future monitoring of what the worst case scenario could be. And we had a very good colleague from USGS show us around, John Major, who I hugely admire. He's done a lot of work on such deposits, and he's also worked on Chaitan volcano. So just before I got here, I got on the onshore Chaitan deposits. So I had a good chat to him while we were in the field, walking around the Mount St. Helens debris avalanche deposits, about his work here, and also at Mount Pinatubo in 1991 in the Philippines, where he worked on the landscape response. The dramatic events that happen after an eruption. It's not always the eruption that is the most hazardous. It's all the loose material that gets pushed and put into the landscape and then reworked over years and decades, and in some areas even centuries. So if you put a lot more sediment into the environment, the rivers fill up. You don't have a nice sinus river anymore. You get more of what you see in cold climates like Alaska, the Southern Alps in New Zealand, where a lot of sediment comes in from weathering, but a volcanic eruption can do that instantly, cover the landscape in a lot of debris or loose material, loose sediment, and that then fills up the rivers, and you get a lot more erosion happening, a lot more sediment transported into the oceans, building up new land, for example, like here at Chaitan, where Rio Chaitan built up a delta. And unfortunately, we've just missed our seminar. Javier, our colleague, has done work on this delta, so he'll have to give us a private show of his slides later to see how the delta evolved. It's quite impressive.
I got a sneak peek earlier, actually, so it was good.
So we're just firing a Niskin.
We're just firing a Niskin. So Niskin is essentially to collect some water from this depth and this area, so we can then filter this water. We can see what's in there, any of the stuff in there. We can look at the properties of the water. We're measuring all the time with our instruments on the ROV Sebastian, the salinity, the O2 concentration, the O2 saturation, temperature, and we combine this with all of our mapping data and our sub-bottom profile data, make sure everything matches, everything talks to each other. And then we also do something called a CTD, which is where we have another Niskin instrument, basically, which we lower down to seafloor. It records all this information and acts as an independent calibration tool to check that all of our data coming in is accurate. So we just fired this Niskin. So
for those of you who might have just seen the smaller inset view. We just panned around to the sort of side of the ROV, and you can see just how dark it is, how our lights barely penetrate beyond the ROV itself, showing just how deep we are.
I need to put them on full beam. Or are they on full beam?
It's okay.
So we're just getting ready for our next push call.
I'm sorry. Don't hate me. Never. I could never.
Yeah, so Karis and I are actually part of Team Pushcore. We were branded.
TPC.
Alistair is a guest on our team. He comes in when he's done cutting the Viper cores to size.
So what we do is we take the notes from those who are logging in this mission control room, so Mane or Jacob, and their notes tell us how full the push cores are expected to be, whether they've been disturbed, whether we've managed to capture some water, and that helps us decide what we go on to do. So depending on how many we get per dive, that can be between 1 to 3 to 4 per site, but I think this one we're aiming to fill up all of our push cores, being that we're so deep. But we choose whether to archive them. So to archive, we push down another tube into this, so we have contained the sediments, we're able to preserve the stratigraphy, and then we sample at 5 centimetre intervals everything that's outside of this sort of inner tube. And then the other material, we then push the push cores out of their holders and slice them off at 1 centimetre intervals, so sometimes that's called salami slicing. The idea there is that we sample at each centimetre interval. That goes off for things like grain size, microbiology, isotope analysis, and that tells us information all about this top layer of sediment of the seafloor.
Yeah, and I think one of our colleagues, Maka, she's also looking into contamination. So she sampled at various intervals to see what else is actually incorporated into the seafloor sediments.
Yeah, I think she's specifically interested in looking at the mercury levels, but also how this affects the microbiomes that are living within these sediments. And then we're also sampling the water, so that little bit of water that's sitting above the sediment captured within the push core, to have a look at the sort of components within that as well.
You haven't done any scoop bags yet?
Yeah, so I believe we were just discussing the scoop bags there.
Very good.
Some tense moments as we're waiting to watch the push core go back into its holder.
Looks pretty good. It's good. I do want to have a go with the robot arm. Quite good. Oh no.
The what?
The robot arm. Be good. Just have a play around.
Yeah, do you remember that Big Bang Theory episode with Howard? And the robot arm he developed for the International Space Station. You need to watch it.
Okay. I shall watch that. Right, it's just been secured. Just been secured now into to its base where the core catcher will hold all the sediment in.
Push core location number 4. Number
Brilliant.
4 on the rack. Forget my lap on this one. I think I have it done. Can't read the 4.
Just pushing down the lid. Perfect.
So yeah, We might have to check to see what's happening next. What's the plan?
We're taking let Matilda lead.
Yeah.
So we are back and we are doing the last picture. Our fourth site, which is more or less 1 mile and 1 mile and a half, no, 1 mile and something after the first site in the east direction, more or less, and we are doing our second push core here, which is also the sixth one of the dive, the last one. We already did one vibrocore here, which we didn't recover yet. It's still in place, and after having recovered it, we will do some scope bags for collecting biology, and after that, if we have time, we will do a last vibrocore. Otherwise, we will start coming up our long journey of more than 3 hours, I think, to go up, and our dive day will be over. We didn't have so much penetration with our vibrocore today. The maximum was, we estimated something over a meter, but we have always met something hard, possibly sandy, that stopped the penetration. And on the other side, we had good recovery in almost all the push cores, and we managed to do very nice suction samples in the last site, 2 sites ago. We did 4 in total, so we collected a lot of data, and we moved quite a lot with the ship along us. Between the second and the third side, we did almost a third of a mile, but very slow velocity. So we are now.
So this push core has just started to fall out of the holder, and so what they're going to do is they're going to shake it out to remove all the sediment from there, because we don't want that falling in and contaminating the capture. Then if we can successfully get it all out, I think we'll probably have another go. This is a nice thing about them being sort of the clear cylinders, is we can see what's going on inside there. So yeah, they're just doing this waving motion to waft all of this sort of loose material out.
What do you think, Lonnie? More is that enough? We got one. It would be nice to have an archive. Yeah.
Mane, you may want to also write that a little bit of sediment did fall into the capture.
We can save notes on the sheet, but I wrote it. Do you want to take that over again? Yes. I'm just waiting for the light. Everything. Everything else is the same.
Right, so we're going again now.
Let's say full penetration. This one as well.
Ooh, this is looking good.
Shouldn't have crossed it out. And you need to rate
So we've got second try, also got full penetration, so we can see if we can get this over to the capture.
Now, fingers crossed.
Yeah, let's pretend like
Positive vibes into the chat, guys.
getting into the end zone here.
Yeah. Oh.
So it's got to travel a long way from the seafloor up.
A little bit.
Just go for it.
Yeah.
You got this.
Very delicate process.
I didn't want that bit in the way. It's fine. bet these guys win all the toys at fun fairs on the like grabber machines. Yeah, exactly. I'd ask them if they weren't so busy with us. It's a business in there, isn't it?
I haven't seen them in the PlayStation room though.
No, need to give those fingers and thumbs a rest from doing all this, otherwise won't be on the best form for work. Look at that muddy top. Huh.
So yeah, the ship's quite well equipped for us. We've got the mess with the nice dining area, buffet, breakfast, lunch and dinner by our two chefs, Craig and Pete. And everywhere on the ship we have big screens, so if there's an ROV dive we can follow that, or we can see how the seafloor mapping is progressing. It's quite good to stay in touch, even on the TVs in our room, which we haven't even turned on. Haven't had time to do that, but we can pick between different channels and watch this from bed. But yeah, when we're in bed, we're actually sleeping. And yeah, we've got a little kiddie area. It's called the pen, and it is like a bit of a... The what? Yeah. Yeah, it's very colourful and it's very relaxing sitting there. Yeah, the cinema we've talked about. It's got a few comfy couches with drink holders, a big screen, and what we haven't tested out yet is the karaoke room. We've had a few jam nights with people playing guitar and singing along, mostly in Spanish. But yeah, we're training them up with country roads. One of the crew, John, he's quite good on the guitar. Maybe we can convince him, and then yeah, karaoke would be another thing to do.
So what's going to be your karaoke song then? When? Well,
probably have to be 99 Love Balloons, you know.
Ah, okay.
I normally do country roads.
Country roads.
Yeah.
I'd probably have to be Spice Girls, I guess.
Yeah.
Ja.
Dann ist ja nicht schlimm, wenn wir es versauen.
Yeah, we'll have to try that out, won't we?
Yeah, so tomorrow might be a good opportunity because tomorrow we've got a Chilean Independence Day. There's going to be some decorations going up soon. And yeah, I don't know what's planned for tomorrow. Will be a surprise. Karaoke.
It's been planned right here, right now. Karaoke, good food.
Excellent company.
Probably excellent cause that we're working through as well.
Change your mind. How much penetration do you guys think?
Very little.
60 centimeters at the maximum.
Yeah, but I'm gonna make sure it's out. I would need to close that gate.
So we think we've got a max of 60 centimetres there, so everybody's just going through recording everything. To give you an insight into what we can see, we've got, I don't know how many screens are in here, too many to count on fingers and toes. Anchor's actually counting them now, so I'll wait for how many?
About 20 screens.
20 screens,
Some
okay, you
have,
just count them.
Similar things on. Some have multiple images on it. There's some with 4 different camera views and data views.
We've also got some of our sonars. We've got the EK80, which allows us to see sort of through the water column as well as into the sort of top part of the sediment. So that helps us understand things like the currents, the different sort of zones within our water column, which is useful information to have. We have our location.
Yeah. It's really cool.
Particularly alongside the ship, so we need to monitor, you know, how far we're straying from the ship. Do we need to ask the bridge to move, or vice versa?
Yeah, location data all the time for where the ROV is and where the ship is.
And the wind.
So we're moving quite a bit because of the currents and the waves at the moment. But we can also see on the the bottom profile in a 3D image. We can see the track that the ROV is going as well, which is really cool. And all the real-time data as well that's coming in. So which way we're heading, the depth, temperature, salinity, oxygen levels, etc.
So we're just using a little bit of vibration as we're pulling it out, just to help us release it and capture it again.
Alright, grab with the other arm probably. Let me see what is it.
So we're now having to use our other mechanical arm to help us come round and grab it from the other side.
Alright, so I think it's camera number 4.
Is there anything else in the chat? Karis, I can't read it from here.
No, nothing at the moment. Yeah, do if you have any questions or comments, do send them through. We're really happy to work through and answering them. The chat helps us drive the conversation.
What's been your favourite moment on board Keris?
Yeah, we need to grab the bags.
It's a tough one, Alistair. I think there's been many highlights for sure. I think, you know, when we brought up the first cores, it's always exciting, especially when we get to open them. I think when we found the layer that we suspect to be from the Chai-10 2008 deposits was obviously really exciting, particularly for us volcanologists. But it's also been so nice just getting to meet and work with a whole new bunch of colleagues. You know, Mane's holding her hands up in a heart. But no, it's a really fabulous team and crew.
We met everyone but Mane.
Getting to work together.
Joking.
But learning from each other as well. So it's been so nice. We've been sort of teaching each other, lots of people helping out. So, you know, how are we collecting each other's samples for times when you're not always around? It's a real big group effort. I think, although for me probably the biggest highlight was the schools visiting, all the school children coming aboard, along with their local teachers and council members. It's really exciting to share the research we're doing, show what it means to be part of a marine research expedition, but also, you know, likelihood is they've seen our ship from shore. So actually to show them, to experience it, introduce them to the world of the science we're doing. Perhaps, I don't know, we've influenced some new young scientists from the local region who may now want to go on and study the deposits they see in their oceans and further.
Yeah, my favourite thing was when the children came and had a hand lens. So we use a hand lens, a small magnifying glass, which we put to our eye, and we look at hand samples, and we keep the glass to your eye, and then you pull the sample closer to see it. And everybody always, when they pick one up, holds it as far away as possible from them, as though it's a magnifying glass. And with my limited Spanish, I could kind of just show them how to do this, and their faces when they realised that they could actually, first of all, you know, they couldn't see anything through it, and then when they realised how to use it, you know, they were really, really excited by it, and that was really cool to see. Yeah, what's your highlight? Okay.
I don't know. I don't think I can decide because everything's been a first for me. So coming on board was a highlight at the time. Seeing the submarine, seeing the CTD equipment, everything as a first, doing the first push core, getting the first vibra core, opening the cores. it's been just a really great experience of learning, working in the lab, seeing the different areas. Probably
Lab work.
and yeah, seeing the different disciplines coming together and see how we can all, you know, fill in different pieces of the puzzle. So, and then of course the first ash layer in the core probably, and then the first ash layer at the top, which we are pretty sure is Chai-10, 2008. The other ones were exciting, but we were not sure if they are. So, yeah, and then you know, the first of everything.
Seeing the penguins were pretty cool.
The penguins was cool, but I've seen penguins.
So whales today.
Yeah.
We raced up to the heli deck to see if we could
Missed
find
them.
them, but we were a bit too late.
Right alongside of the ship.
No, we're being told they're actually fake dolphins. You guys saw.
Yeah, Matilda says you shouldn't trust them.
But
They
no,
were
I've
definitely humpback. We need a mammal marine biologist. Well, Diego and I saw it in the mess, and he
Yeah.
took a video, and I took a video.
They look just
and
more
he
for
sent it to his
humpback, I
followers.
think.
Yeah, I sent it to a
Oh,
friend
no?
and they thought we were with humpback.
Definitely humpback, yeah.
Humpback whales. Humpback
Yeah,
whales.
okay.
What is your friend say?
Yeah, I mean, I'm probably a bit spoiled in that aspect. I've lived in New Zealand for the last 20 years now, so I've explored it quite a lot. So we've got 3 different species of penguins living there. The little blue ones, the smallest ones, they're really cute. They're probably my favorites. They come and waddle on shore when it gets dark in big groups. So there are certain areas where you can go and watch them. They're distributed all along the coast of both islands, but some bigger colonies down near Otago, on the Otago Peninsula, near Dunedin. And they also have a royal albatross nesting colony there. And then a bit further north, we get the yellow-eyed penguins. They are endangered. The colony's numbers are going back, and they're the second biggest penguin. And I've seen one of the third species when I was down on the west coast of the South Island, the Fjordland crested. It's a very cute one. But yeah, so I've seen them from the boat, swimming around and coming on shore. They're just super cute.
We have a question in the chat. I think that's from a while ago. Oh, really?
I don't know. I think it really depends.
Could you just repeat the question for us? I don't think we can see it on our screens.
What is the average size of particle for the sediment mostly you've been dealing with? Or in the sediment? Is it like a silt, or what is it classified as?
We've had a bit of a mix so far. We've
Everything,
sort of gone from clay-sized particles all the way up to sort of gravel and pebbles. That's one of the sub-samplings we're doing. So obviously we can have a look with our eye, our hand lenses. We're able to sort of discern if it's sort of clays by seeing if we can sort of move the sediment around in the water and see if we can get it to, I'm not sure what the word is, percolate through the water. But
in suspension.
Suspension is the word. But then also, you know, you can feel it with your hands. You feel this grittiness. So particularly when we're working with ash, you can sort of feel this grittiness to it. Right the way up to sort of being able to see like coarse sand, granules, and sort of pebble-sized material. But what we'll be doing is we're subsampling, and then we'll take that back to our labs to be able to go and do grain size analysis. We use this on a bit of machinery which uses laser and sort of measures how much of the light is obscured, and it can give you sort of an average grain size and how sort of that trend within that sample is.
Shoulder in, shoulder up.
Yeah, so of course closer to shore we've had much coarser samples. So when we were near the Rias Delta, we got a lot of sands and up to pebble size, mixed black, probably basaltic material, and lots of pumice, likely from Chai-10 washed in. And as we move further away from shore, all the larger particles would have been washed out of the sediment, and we get the finer sediment. We also always have a bit of a fine-grained silty clay layer sitting on the top of the ocean floor, like what you're seeing here. And yeah, mostly probably sand size would be the...
Yeah, so sedimentologists have a scale for this. So it starts with clay being the smallest, and silt and goes into sand, which is split into very fine, medium, coarse. They each have micron sizes and down to millimeter sizes as well as you get higher. Most volcanologists use a different scale. We refer to things as ash and lapilli. So our finest particles we have is very fine ash. So ash isn't really a product. It's in a volcanic term. It's a grain size. So everybody will refer to volcanic ash, whereas volcanologists will refer to tephra, which encompasses is a term which encompasses all of those different grain sizes together. So when a volcano erupts, the coarsest stuff falls out of the eruption column first. So this will be the larger class. So you might have stuff that's pumice class, for example, which are up to meters in size in cases. And then as you get further away, you'll generate more fine ash. So all the finer stuff will stay in suspension. It will be carried further distances away from the volcano. And therefore we use this grading system in terms of grain size to work out our proximity to the volcano, to look at the dispersal direction. So if a volcano has erupted in the past, then we can work out which way the wind was blowing, the prevailing wind from the column. This will change in terms of different things. Anka's just telling me how much I'm boring everybody about volcanoes.
It's a bit of a dry topic, Alistair, talking us through the grain size chart.
It's also the boat moving from one side to the other.
What is?
That makes you kind of like want to sleep. Sorry. Can you give me the? No, it wasn't. Woohoo!
Sure. Oh, got it.
Wow, guys.
Yep. Well done.
You're the best.
Can we cut it open?
Don't tell me.
Not there.
So we managed to store the fourth vibrocore. Now we are securing
When he cannot handle it.
all of them.
Winning. And chess.
It was a tricky one, almost fall down. Then it was in a very difficult position, but in the end, Eruption managed to save it.
Research articles while you play. Good.
So now once they are secure, we quickly pass to the scoop bags.
Perfect. Perfect. That's a plan.
So Matilda, what is the plan from here? Have we got another waypoint, or are we due to start surfacing?
No, I think that after the scoop bags here, we are going to come up.
Okay.
Yeah.
Have you used all the cores?
We miss one vibrocore. In theory, we could do another vibrocore.
Yeah, that'd be
But I don't think we have any time.
Are we doing any scoops?
Yeah, we're about to do scoops.
Over there come the scoop bags.
Yeah, so we want to scoop near where we push forward, but not directly over it, I guess. We're missing your jokes.
So we're just bringing out the scoop bags now. So essentially it's a very high-tech piece of equipment. It's a big bag that we scoop into the sediment, and we collect the upper material. So yeah, we'll collect lots of sediment. We might collect some biological life in there as well. And then we normally sieve this when we get on board, and we work out what we've got.
The other day we had some forgotten scoop bags sitting there, and they also contained marine life, and it wasn't a pleasant smell. But we got the sediments out and sampled it, and yeah, let's see what we find now. I think our biologists might be quite excited.
Not yet, no.
Oh no. They will be when they come up.
So where are they? They want to go here where they core, but not on top.
So I think we're going to have some of the biologists join, and they're going to talk through some of the things we're going to be doing with the scoop bag. So I'm going to pass you over to Gianluca.
If you check Elon's flag,
How much? Shall we look off?
on 417.
Ya, buenas tardes a todos. Mi nombre es Gianluca Fedele, estudiante de quinto año de la Universidad de Valparaíso, la carrera de Biología Marina. Y en esta expedición me encuentro con un compañero de universidad, Diego Droguet, que nos encontramos en el mismo proceso universitario, por decirlo de alguna manera. Bueno, nosotros vinimos apoyando el proyecto de la Biología Marina, en donde estudiamos los invertebrados marinos, el bentos, ya todos los animales que habitan sobre el fondo marino, o también los